Okay, I think that we can start. Welcome to this section. This section of the conference is dedicated to the relationship between architecture and technology, with a particular focus on the topic of energy. This section is specifically conducted by me. I am Maurizio Sibilla. I am a senior researcher at Oxford Brookes University. My expertise is in sustainable construction and environmental design. Thank you for participating in this section. Thank you to the moderator, Dr. Salar, to conduct this section with me. Thank you to the committee for inviting me. And it's a pleasure to stay here. I hope that this section will be productive in terms of knowledge exchange and interaction. After the section, we have 15 minutes dedicated to exchange opinion about the presentation, question, and to go into detail of your work. I have read your abstract, and I have seen that we have a different approach and different contribution, and it will be productive if at the end of this section we can activate a meaningful discussion about some common point about this the topic of architecture and technology with this specific focus on energy. I'm going to share my screen with you and start with this video recording presentation. The first is the topic entitled Exploring Blockchain in the Realm of a Network of Positive Energy Buildings. This contribution was elaborated by me and my colleagues, George Bloomberg. So I'm going to share and start. Please, I need that you activate the possibility to share the screen. Please, I ask the host to activate the possibility to share the screen.
Dr. Maurice Sibilla, sorry, I think Dr. George Bloomberg. So you are going to do the presentation online because we already have YouTube presentation, so we can share directly from there.
Okay.
But if you want to do it online, we can go with that since you are the first one.
No, there is a recording. You can launch the video.
So what we need to do from the PDF file, since we have to copy the link from the PDF file, then open the video in your YouTube. After opening the YouTube, just stop it and then go to Zoom and then share your screen, then go to that Zoom Google Chrome page. And
yes, I have done this, but I have the option to share my screen blocked by the host. So you have to activate the.
I'm sorry.
Yeah.
Sorry.
No problem. No problem at all. Okay.
Good morning. First of all, I would like to introduce myself and my colleagues. My name is Maurizio Sibilla. I am a senior researcher at Oxford University. My colleague George Bloomberg is a senior lecturer at the same school. Our contribution is focused on exploring blockchain in the realm of a network of positive energy buildings. This slide is about the ground on which our work has been developed. The innovation of urban energy infrastructure has become a key action of the European Strategic Energy Technology Plan. The said plan takes into account a multitude of advanced low-carbon technologies, such as nuclear, solar, wind, among others, in order to achieve the Paris Agreement. However, only renewable energy source can generate lost relationships between cities and communities. Nowadays, the high level of maturity achieved by renewable technologies, together with ICT advancement, has made the evolution from fossil and passive management infrastructure to renewable and interactive energy system feasible. However, this new typology of infrastructure has not been codified yet. So, the literature presents different concepts such as active buildings, positive energy block, positive energy district, and energy community, which are the new paradigm on which the energy policies and practices in Europe are being developed. However, established positive energy blocks and buildings has a common practice required development of appropriate tools to allow the local actors to exchange energy within a shared regulatory framework. Technological innovation, therefore, is the key factor to drive the energy transition. In this regard, blockchain technology is a possible solution. However, how blockchain-based energy systems can contribute to local carbon transition is an open issue. And our research is an exploratory research in order to clarify the property of blockchain and the relationship between this technology and the vision of positive energy block. The figure contains a model of positive energy block showing the three organization layers: data, device, and user. Particularly, the transfer of information between the user, the device, and the storage of the information must be protected. And blockchain provide novelty by their ability to hold critical data that, once written, are immutable and protected. For this reason, the blockchain technology is based on cryptography. This is the image is represented the different block cryptographied that use different technologies to use code in order to make the file immutable and protected. However, this contribution will focus more on the relation between this technology and their field of application. So, for example, this flow chart describes how transactions are reported on blockchain.
Doctor, we have problem with the sound. The sound is very low. So can you check the setting, please?
Can you hear me now?
Yes, now it's good. Thank you very much.
I have the maximum volume of the recording, so I hope
that records are written by individual nodes. We can
still it's slow.
Sorry.
Maybe the setting of your laptop, can you check the setting of the volume?
I have checked is the maximum value. From my computer is the volume is quite high, so I don't know why you are so low.
Let me try from my side if I can present it from the beginning, because I think the audience didn't hear very well.
Okay.
Can I?
Yes, yes, please. If
Please, you can.
Is it okay now?
No, it's mute.
Without sound.
let me share my screen if it's possible. Maybe it will work.
Of the information
But what now?
needs to must be protected.
We have problem with the 1 minute. We try to solve the problem.
Called critical data that once written are immutable and protected. For this reason, the blockchain technology is based on cryptography.
Yep.
This is the image is represented the different block cryptographied that use different technologies to use code in order to make the file immutable and protected. However, this contribution will focus more on the relation between this technology and their field of application. So, for example, this flow chart describes how transactions are recorded on blockchain. In this diagram specifically, arrows show the direction of the record that records are written by individual nodes. We can suppose that these nodes are nodes of a positive energy block. Then agreed upon and distributed to other nodes on the network. So the concept of blockchain is about the network of consensus, where each member of the community are informed about the document produced. So, in conclusion, our work seeks to establish the role of this technology towards the organization of the so-called self-organized energy community, where each citizen can sell their energy, can activate energy, peer-to-peer energy exchange, but within
safety framework, and another characteristic is that these arrest flows can activate in real time, and these can revolutionize the sense of making infrastructure. Thank you very much.
Okay. Thank you. I think that there was some problem with the synchronization. We can go ahead in order to respect the agenda of our.
I will take care about the storing of all the code what you have done. Okay.
Okay.
There is no dumping multiple times. You just if you want to observe that multiple results, you just need to click.
Dear Dr. Sibila, sorry. First of all, I would like to thank Dr. Maurice Sibila and also Professor Dr. George Bloomberg. I didn't know that he will join. That's why I would like to welcome Dr. George Bloomberg, and I would like to thank him as well, providing such a great research so that you will discuss at the end with the authors. So welcome to Dr. George Bloomberg. I thought that he is also here. And we shall continue with the second one, as you mentioned, with your permission, dear Dr. Sibila.
Yeah, yes, of course.
Today I want to introduce my team and introduce our presentation. Systematization of features and recommendation regarding architecture and urban planning and placement of university hospitals. In the civilized world, the state of development of the medical industry indicates the standard of the social life, the attitude of the health of citizens, or for the health of future generations. This phenomenon is caused by many factors, including environment pollution, lack of the gradual and timely architecture and modernization of the medical system, limited access to quality and modern health care, lack of the culture of health living, prevalence of the self-medication, untimely treatment and abuse, numerous chronic diseases. The only way out of this situation is to introduce step-by-step change without abrupt and cardinal instant updates, which in the approach provide a basic for more correct adaptation and coordination. Then studies in architecture and urban development of healthcare in the leading countries like the United States, the United Kingdom, Germany, France, as well as studies of success factors in leading countries of the medical field like Hong Kong, Singapore, and United Arab Emirates, evaluated a number of patterns and direction of development and urbanization, among which one of the most characteristic in the consolidation for the structural and multifunction of the newest medical institution. Therefore, in the following context of the study have been attempted and introduced at the main design features of the university hospitals, which are the next evolutionary step in comparison with clinical hospitals. The closed type of the post-Soviet medical institutions, the university hospitals are clinical hospitals, where medical departments operate and where young doctors undergo internships. The example of clinical hospital are the Kiev Clinical Hospital number 8, the Dnipro Clinical Hospital number 9, the Minsk Clinical Hospital number 1, and the National Clinical Hospital located in Russia. The university hospital provides a complex combination of medical diagnostic, rehabilitation, training, research, and experiment functions, combines them, and attracting is in one multifunctional complex located within the same territory or in different areas. University hospitals, as a rule, are revised state status and are designed to serve the population of the whole country without connection with the place of residence of the citizen. Based on those provisions, the capacity of the university hospital should be calculated at least 800 to 1,000 dependent beds. We've talked about historical experience of the university hospital design. The first of all is the university hospital Hamburg Panthers, located in Hamburg, Germany. Next example is the University Medical Complex Freiburg, located in Germany. The Jonas Gutenberg University Medical Center, located in Mainz, Germany. Today, the architecture of healthcare facilities is gradually losing the features of the architectural shell for the technical organization of therapeutic process, and itself acquires certain therapeutic preparation. One of the important trends is also the use of environmental design approach in the design of medical institution, which creates the basic for sustainable development of architecture in the field of the health care. And if talk about example, one of them is the Queen Elizabeth University Hospital, Glasgow, Scotland. Another example is University of Montreal Hospital Center, located in Montreal, Canada. And Koga University Hospital, located in Koga, Denmark. Today, the university hospital is one of the most promising and effective forms of organization of hospital structures. This is primarily due to the fact that the university hospital is a multifunctional medical institution, which within the territorial boundaries of the one complex combines and synthesizes the interaction of a number of related functions. For example, multidisciplinary and specialized medical education and training, medical profile research, and experimental production, as well as many ancillary services, with together create the conditional for an emerging effect in the work of the hospital. It is possible to design university hospitals both in the new suburban area, free from the surrounding building, and with a significant potential for landscaping of the medical complex. In this case, it is advisable to design a centralized building of the university hospital with a fairly extensive form of small and medium-sized building, which in case of future need will allow more freedom to expand the health care facility. In this case, when it is decided to create a university hospital in the existing urban environment on the basis of the expansion of an existing hospital or educational medical institution, it is advisable to design a centralized building with a combined volume of high and medium stories. The main conclusion is the understanding that each university hospital is a unique object and cannot be designed as a typical project. In each specific case, it is necessary to conduct a thorough project study together relating the task, goals, capabilities of the future hospital, the characteristic of the territory, the living population, etc. Thank you very much for your attention. Good luck and good day.
Thank you. I think that you can continue to share. Thank you very much.
Dear colleagues, welcome
Thank
to
you.
the presentation
Thank you.
called Contemporary Adaptive Systems in Architecture and Structural Engineering, State of the Art and Future Perspectives. My name is Yeni Vakti from Mashar University, Turkey. Presentation has 4 sections. In the first section, I'm going to make an introduction about the main concepts of adaptive systems in architecture and structural engineering. In the second and third parts, I'm going to summarize types, technology, and contemporary applications of adaptive systems. In the last section, I will try to construct a future perspective for these systems. The concept of adaptation in architecture goes back to ancient times. Throughout history, architects have always searched for methods to design adaptive buildings and building parts that can adapt to ever-changing environmental, spatial, and functional requirements. Technology became an increasingly important factor in facilitating architectural adaptation and innovation, especially after the last decades of the 20th century. The developments in automation, computation, and material science have also facilitated the applications of adaptive systems. Due to these developments, adaptive systems of the era have all been integrated with sensors, control intelligence, and actuators. These systems have a strong interaction with the physical environment and users. This interaction has created a demand for these systems. This presentation and in my paper, I summarized adaptive systems and concept of adaptability in 4 groups. These are adaptability in structural systems, adaptability in architectural components, adaptability in building envelopes, and adaptability in materials. It is impossible to explain all these subgroups and their principles in this short time. And for deeper information, you can read my paper. But here in this presentation, I would like to emphasize that the concept of adaptation has a potential to change our design approach. The structures first. Conventionally, our building environment is static, and building structures in its environments are designed considering the worst situations that they may face. This means the cross-section of a conventional building structure is always more than the needed sizes at ordinary situations. The foreseen worst situations are very rare and sometimes never happen during the life of a building structure. This means we may be wasting materials by this conventional design strategy. And adaptive structures can be a response to this problem. One of the primary philosophies of adaptive building structures is to design the structures as light as possible and well prepared to rarely seen violent load through an active manipulation of the structure. Studies on active structural control with sensors and actuators, there are many deployable examples which search for adaptation via geometric transformation as well. Flexible scissor bridge in Geneva is an interesting example for deployable structures. While many well-known deployable bridge structures have only one active geometry and cut the pedestrian or vehicle flow at their contracted positions, this bridge structure can be active at any position. You can see the deployment process of this bridge structure in the video and the figure. development on the adaptive system technologies has not only affected the structural engineering, but also the spatial characteristics of the buildings. Architects of the era have realized that the buildings or building components can interact with the user or create multifunctional spaces for different uses at the same architectural space. As a result, a novel design conception, which is completely based on adaptation, has emerged. In this conception, architects and designers aim to design buildings that are flexible, interactive, multifunctional, sustainable, and future-proof, rather than fixed, immovable objects that are stuck in a specific context and time. This novel understanding has an important potential for the future of our planet. It is known that the construction industry is responsible for almost 40% of the carbon emissions, and attempts for multifunctioning may decrease this ratio. Page designs of color systems for different multipurpose homes are a good example for this design understanding. Instead of constructing several flat and inclined walls for different functions, capacity, and special qualities, these multipurpose walls change their geometry, capacity, and height according to the number of the audience and necessities of the function. This means it's possible to obtain numerous spatial or architectural alternatives in one wall. This situation creates remarkable spatial efficiency. The concept of adaptability is very common at design of building envelopes as well. This is because envelope is the physical interface of a building with the physical environment and the urban context. This means building envelope is not only the group of surfaces separating the building from the exterior climate conditions, but also the interface to interact with the city and the society and the street. Adaptability in building envelopes can be realized in two groups: climate adaptive building shells, retractable roofs, shading devices, and adaptive glass technologies are mostly in the first group because of their great efficiency against the environmental conditions such as wind, rain, and sun. Adaptive shading systems and foldable systems are so popular climate adaptive building systems in architecture. The second group of adaptive facade systems are the performative skins. Interactive facades and media walls, which create interactivity between the building and the user, can be expressed in this group. These systems mostly do not have any climatic aims, or these aims are not the primary design objective. Instead, movable or interactive features of these buildings play a part in the architectural aesthetic as the interplay of image and technology. The movable facade of the Bond Finance Center is an innovative example for this group. You can see this building in the figure. Due to the rapid development of computer technologies, design computing, automation, and material science, the demand for such systems will continue rising. If structural and technical advancements drive this trend and demand, we could be approaching a specific turning point in architecture where technology is directing architectural aesthetics. At this point, it's possible to ask, what is next? In the next few years, it will not be a surprise to see the robotic structures which allow huge simultaneous transformations in a few seconds. Again, it will not be an unexpected situation to see robotic systems constructing the buildings. The research studies on smart materials reveal new materials every day. For this reason, it will not be wrong to predict that these materials will be much more common in the construction industry and our daily lives in the future. And of course, by the help of material technologies and active structural control systems, it will not be wrong to say that the buildings will be lighter than today. this point, an important question may be asked. Are the architects, engineers, and the education systems ready for this change? A cross-disciplinary approach is crucial for the design of adaptive structures. It's very clear. This is because the design area has always been at the intersection point of architecture, structural engineering, and mechanism design. Material science and mechatronics have already joined this intersection for a few decades. The designers of adaptive systems should be aware of the state of art in all these disciplines and should deal with the design problem in a cross-disciplinary manner. This means the design and education philosophy of today should be updated according to the needs of the era, which doesn't exist at the moment. Feel free to ask questions.
Thank you. We can move from the last presentation for this part.
Perfect. Thank you, dear. I think we finished. There are three presentations that we have. Let's say, shall we have roundtable, or we can continue, dear Dr. Mauri Sibila? Are you going to have roundtable to discuss these three articles to let them to have discussion with the authors, or what we do? We can. Do you have any question from the authors to ask them to introduce themselves a little bit?
In the meantime, that we can collect this question, and I invite all author and participant to make their reflection. I would like also to point out some common point among this presentation in terms of relationship between technologies and architecture with this specific focus about energy. I think that all contribution can be interpreted with regard to this focus. For example, the first contribution in terms of economic tools to manage the transition. The second contribution can be interpreted with the need, for example, to establish procedure to identify the role of specific building typology within our territory. And the next, also the adaptive structure can have a relevant role in terms of to reduce the impact of our transformation in terms of environmental impact and capture the potentiality from the environmental cyclical variables. So if author want to clarify some aspect of their work, or there is any question, please, I invite you to share your opinion with us. Okay, thank you. If there is no question, I invite you to follow the second section that starts in a while. Thank you very much for attending this presentation. Bye.
Thank you, Doctor. Dr. Maurizio, do you hear me?
Yes.
I think if we can assure that the authors are here, let us to start the next session in order to get more time for the discussion for the last round table. What do you think?
I agree. I agree. So we can. I don't know the problem.
Just first, let us to start to know. Let us to check if the authors are available.
Okay.
Because we are a little bit in advance.
Okay.
You can ask about the authors. Yes.
If there is the author of the paper entitled Evaluation of Photovoltaic Noise Barriers Design Criteria, a case study in Istanbul, we can start to the presentation. The author is here?
Yes, I am here.
Okay, thank you. I check also the other contribution. There is the author of Environmental Performance Analysis of Heat Insulation Glass Fiber Reinforced Concrete Facade Panel. Professor Nurai or other colleagues? No. And the last one was the paper entitled The Micro District, a Smart Sustainable Vision in the Architecture and Headquarter Buildings.
Yes, here.
Okay. So I
sorry,
think that
sorry for intervention, but I want to, there is a title of a new design proposal for perforated solar screen. I don't know, this is the title. I think you skipped to mention. We have
I skipped to mention because it was in the first section. So I don't know, it now moved in the second section. It's okay. There is the author of this paper.
Yes, if he's...
Okay, we can start from this. That was the last.
Okay,
Okay, we start with the, please, if the host can share the presentation of a new paradigm, a new design proposal for performant solar screens and optimization in terms of solar control.
Hi, my name is Fatma Zorlu-Çağlar. I am a doctorate student at the Architecture and I am a research assistant at Yıldız Technical University. The title of our publication is a new design proposal for perforated solar screens and optimization in terms of solar control. I will explain our research with the following titles. The building envelope separates us from environmental conditions and provides creating a comfortable interior environment. Especially transparent areas are one of the most important factors affecting indoor comfort conditions because they are the most effective building envelope components in solar gains. Solar radiation should be controlled before it gets the inside of the buildings, and it is possible with the use of exterior shading devices. Nowadays, the use of the perforated solar screens is increasing, especially in large glazed facades. In this study, the perforated solar screen design proposal with an approach with difference from the previous studies was examined especially for the classrooms. The perforated solar screen proposed by different methods has been optimized. Within the scope of the study, a new design has been proposed for the use of perforated solar screen. Verification of the model and calculations was made with the measurements. The proposed design has been optimized in terms of harmful and helpful solar radiation. As a result of optimization, the best perforated solar screen was optimized again according to the twist angle for maximizing view by minimizing annual sun exposure. In addition, thermal comfort conditions and inner window surface temperature have been evaluated according to the whether the optimum perforated solar screen is used or not. The classrooms on the university campus in Istanbul were selected for investigation. Meteorological data are given in figure for Istanbul, which has temperature with climate. An existing classroom on the southern facade was determined as an example with a large number of occupants and a large volume on the university campus. The selected classrooms is B500 and is located in the south of the building on the 5th floor. The properties of the classrooms were defined. The following were determined by measurements. The existing classrooms was modeled using Grasshopper. Simulations were conducted using the same program. Grasshopper integrated evolutionary optimization tool based on genetic algorithms was used for optimization. The harmful solar radiation performance was calculated and optimized. The optimizations were made by calculating solar radiation coming to the window surface. Optimization has been done so that the harmful radiation is the least and useful radiation is the highest. As a result of solar radiation optimization, the best perfect solar screen was optimized again according to the twist angle for maximizing view while minimizing annual sun exposure. The figure showed the adjustments were made for the thermal comfort calculations. Another step of the study is verification of the calculation by measurement. Verification was conducted for 3 classrooms. Measurement and calculations were made when the classrooms were unoccupied for the existing station. Thermal comfort measurements were performed with test 480 device. The measurements were conducted at 3 points in classrooms and calculation results verified according to the average of the values of these points. The verified results are given in figure. A similarity was obtained between the measurement results and the calculation results. The results are the more similar with the windows closed. It can be said that comfort is provided when the windows are closed during the winter months. The measurements were the first design variables are the dimensions of the Voronoi cells, the width of the horizontal shading dividers, the distance between each other, and the twist angle. Figure and table show the perfect solar sequence, its variable and its variable evaluated. The horizontal geometry is twisted around its central axis. The width of the horizontal geometries is equal to the distance between each other so that they rotate around the axis and don't intersect with each other. The dimensions of the Voronoi cells vary according to the different cell radius. Even if the width of the geometry changes, the preparation ratio is the same when the cell dimensions are the same. Different from the specified design variables, the rotation angle was also optimized. The rotation angle was same central axis. The rotation angle was optimized for the best result after the first optimization. The positive angle represents the rotating horizontal geometry clockwise. The optimized perfect solar system has been recommended according to all year use. When we come to the results of this study, the first solar radiation optimization was done for twist angle and other variables. The optimum results were obtained when the twist angle was 0 degree. The dimensions of Voronoi cells radius were defined as 0.4 and the width and distance is 0.15 for the best twist perfect solar sequence. Then optimization was performed with the rotation angle variable for the geometries perpendicular to the facade. 30 degree was determined as the best angle as a result of optimization according to the rotation angle variable. These calculations were made for the annual station. We evaluated the optimum perfect solar sequence in terms of twist angle for region only. In this case, the best perfect solar sequence when the twist angle is 720. Solar radiation is the least with this perfect solar sequence in the summer. As a result of solar radiation optimization, beam and annual sun exposure optimization were done for best optimize the perfect solar sequence according to the solar radiation. Twist angle was the design variable for this optimization. The twist angle was determined as 0 degree best twisted perfect solar degree. Solar radiation were calculated for the Best 3 perfect solar screen determined according to the annual sun exposure and wave optimization. When the twist angle change, a lower amount of the solar radiation was calculated in summer as determined in the results. It has been calculated that the effect of the perfect solar screen, which gives the best results, determined by optimization on thermal comfort and window in surface temperature. Predicted mean mode values obtained as a result of the calculations were evaluated according to the limit values in the standard. According to the standard, if PMV is between -0.5 and plus 0.5, it is considered as comfortable. If the determined perfect solar screen are used, the thermal comfort conditions have changed positively in comparison the existing situation. The window indoor surface temperature decreased with the use of perfect solar screen. The decrease in window temperature is higher in summer months as in thermal comfort. A new design proposal presented by considering the basic principles in terms of providing solar control by perfect solar screen within the scope of the study. The solar radiation view and annual sun exposure optimization were done for the best optimized perfect solar screen. Consequently, it has been observed that the use of 0-degree horizontal geometries is the best for twist angle design. When the twist angle change, a lower amount of solar radiation was calculated in the summer. It is possible to find and apply optimal results according to the modes for the perfect solar screen suggested in this study. Better results can be obtained if it is designed as a kinetic. The proposed design allows kinetic applications. Design proposal can be developed for the east and west facade by using the method of this study. It is necessary to analyze and find the optimal result for proposed perfect solar screens to be used in the existing new buildings. Otherwise, the desired shading devices will not be able to perform their original functions. Thank you.
Thank you. We can go ahead with the next paper entitled Evaluation of Photovoltaic Noise Barriers, Design Criteria, a case study in Istanbul.
Perfect. Thank you, Dr. Mauri and Fatma Zorloku and Dr. Kulay. So we shall go to the second one, as you mentioned. Just before that, if Dr. Mariam is around, I'm going to give the host to her to. I should go to the session C. Professor Dr. Madrigal some health issue that needs to go to hospital. That's why I have to be in session C. If Dr. Mariam Iranfar is around.
No.
Or Dr. Salar, or I can give the host. Would you please?
Dr. Horax, let me to check out with Dr. Mariam if she is around. She says I am in the platform. Yes, she is in the platform. You can talk to her.
So I make now to be safe side Dr. Mariam host because I have to leave. Dr. Mariam, would you please share the second our author's YouTube link, please? Evaluation of the photovoltaic noise barrier. Yes, Dr. Mariam, can you hear me? We can't hear you. You are mute. Yes.
Yes, doctor. I am here.
So please, I can. If you have the program, open the presentation with the title of Evaluation of Photovoltaic Noise Barrier.
1 minute, I will.
Doctor, this is my presentation. Tarhan Hasmadan. Photovoltaic noise barriers.
Evaluation of 1 minute.
Search it, Control F, evaluation.
Evaluation of photovoltaic noise.
Yes, please.
Yes.
After opening the YouTube file.
Yes, yes, I'm opening now.
Please start to share your screen by going to your Internet Explorer.
Okay. Now it is opening. Now I will. I share it through the Internet Explorer.
Yes, please.
My internet little bit is very slowly. Now I am opening and sharing. Share it.
So I'm sharing by myself. Please try to learn it for the next one. And
okay.
Hi, dear conference participants. Welcome to my presentation. I'm Fatma a PhD student from the Technical University. I'm going to research assistant at Istanbul University. I will give you a presentation about evaluation of photovoltaic noise barriers in terms of noise control. The evaluation was carried out on a field study. I have organized the course in the following sections: introduction, methodology, design of PD and the alternatives, environmental noise model, evaluation of findings, and discussion and conclusion. The first point concerns the issue of air traffic noise. Although noise and energy in general do not have a direct relationship, the transportation sector is responsible for a major share of energy consumption. Additionally, transportation has many phases related to environmental pollution, such as air and noise pollution. As a result, noise control measures are needed in heavy traffic urban areas to mitigate the impacts of road traffic on energy and noise pollution. Noise barriers can be the best solution when no noise control measures are taken neither at the noise source nor at the receiver. Noise barriers are used as a structure for solar panels and installed noise barriers. These structures are applied in low area zones, such as roadside, provide both renewable energy generation and comfort for the residents. For large areas in the supply, which is the biggest disadvantage of solar energy application and the other kind of this technology. First of all, the factors affecting the performance of PV and these were investigated with the literature review. The results of the literature review are summarized in tables. Non-alterable features depend on the highway, environmental, and climate conditions. Alternative properties are related to design variables. The parameters affecting all three components indicators are highlighted with a red pen. Barrier height, barrier length, and the field of deflection edge are related to the barrier design. As a matter of the literature review, various barrier sections were designed with common criteria. To analyze the effects of barriers, evaluations were carried out on a field study. Within the case study, an existing residential settlement exposed to noise levels above the new barrier along the highway was considered. The case study area given in figures, the 21 meters wide highway is in the surface of the residential area. The intersection of the highway and the settlement where the PV&D was designed as an azimuth envelope there are 25 residential blocks with 5 and 9 floors. The closest this highway is 20 meters. The farthest block is 194 meters away. communication buildings for residents. The difference in the tremendous consider and work. No chart of the study consists of model and evaluation steps. The scope of the study is limited to noise country. The PV and the schematic sections and design variables are shown in Table 2. The barrier cut pitch has been 2 meters, 3 meters, 4 meters, and 5 meters. The wall height of the PV and the is considered 1 meter and 2 meters. These angles, the angle values, are periodically estimated for this region. Estimated angles for monthly, daily, annually were calculated via the optimization tool module of PV software. Tilt angles lower than 25 degrees, as you can see in graph, weren't included in the calculation as they increase the dark population on the panel and reducing bakery fat yet. Traffic flow characteristics of the highway are given in Table 4. The total number of people passing the highway is more than 24 million annually. The figure on left reveals the brief noise map of current situation where generated in country. In validation process, actual noise measurement and model outputs were compared. The difference between measurement and model results is within the acceptable range at least 4 measurement points. Diacritic noise is dominant. However, some points are above the limit range. We keep the noise sources that cannot be intervened and affect the background noise, such as border elements, student playground, and construction activities. Figure shows the noise levels on the facade in the daytime. As stated in the regulation, the noise level should not exceed 63 dBA during the daytime period. The evaluations are partly divided into 2 groups. All blocks in the southern expressed in all, blocks in the first row expressed in 1R in graphs. 24% of all facades in the southern one, 55% of the facades in the first row blocks are exposed to the noise level above the limit value. Finally, in the evaluation step, a general analysis was made first. Then, to examine in detail the effect of barrier variables and noise reduction in the southern one, the assessment has been discussed in 3 different groups: flows, distances to the barrier, and facade direction. Simulation outputs were evaluated according to the pillar point ratio above the limit noise level and generally were shown on the vertical axis in the graphs. Barrier design variables were demonstrated on the horizontal axis of graph. As you can see in the chart, shortly increasing the height of the barrier, width of the diffraction edge, and the inclination angle improves the performance of the noise level. Continue the noise analysis. One, to find out the effect of barrier alternatives on the floors, target of the borders belong to the highway were analyzed. 3 dBA difference in noise level can be detected by the human ear. In this context, 100% of the alternatives provided musical noise reduction on the first floor, 92% on the second floor, 41% on the third floor, and 1% on the fourth floor. When the noise levels on the fifth floor were examined, it was seen that no barrier alternative provided beneficial noise reduction. Then, the effects of the barrier alternatives are interpreted by considering for all facade floors in control blocks. The effects of the best and worst alternatives were compared. H equals 1 meter, T equals 2 meters, and 27 barrier reduced the number of receiver points exposed to noise above limit value by 65% on the first floor, 17% on the second floor. No improvement was observed in the third, fourth, and fifth floor. Barrier cut depth H equals 2 meters, E equals 5 meters, and 56 equals tilted one, provided 100% improvement on the first and second floor, 75% on the third floor, 46% on the fourth floor, and 17% on the fifth floor. To observe the effects of PV and the alternatives on blocks at different distances from the highway, the ratio of first floor blocks to the total number of receivers exposed to noise above the lead level was annual. Analysis results are shown in figure. In blocks with distances of 21 meters, 29 meters, 36 meters, and 41 meters to the barrier, in the base case, the percentages of receiver points above the mid level are 75%, 75%, 70%, and 60% respectively. With the barrier alternative providing maximum noise reduction, the rate of receiver points exposed to noise above the mid level are 32%, 35%, 25%, and 10% respectively. For evaluation according to facade direction, A1, A2, A3, and B1 blocks were considered. Analysis results are shown in figure. The southeast facade parallel to highway was exposed to maximum noise. Acoustic comfort was provided on the northwest facade of all blocks. Because of the receivers on the northwest facade were on acoustic shadow zone. To sum up, increasing the height of the barrier and width of the diffraction surface increases the noise. The information of the barrier edge is positively related with noise control. High-rise buildings should be located away from the highway. In this way, more population can be protected from noise. In the spatial planning step, noise-sensitive areas should be designed and put in the acoustic shadow zone. Towards the end, I'm hoping the study guides the designers in determining the most effective area alternative under different conditions. Thank you for listening.
Thank you. Following the program, the next presentation is environmental performance analysis of heat insulated glass fiber reinforced concrete facade panel.
Sorry, dear Maura, I see this YouTube. Which one we are going to continue with? Dr. Maurice.
The micro district, doctor.
Just the last one, I mean.
The micro district is, yes.
So is Mariam Iran Faris around, or Dr. Salar, would you please try by yourself one more time to see it is working? Dr. Salar is the
Doctor, I can share it. I opened the
please
file.
Thank you, Mariam.
Let Mariam to share first because mine is very weak.
Perfect. Thank you. Press the CC button and just full screen and play. There is no sound. Don't please, Mariam, unmute yourself. Otherwise, it will not unmute yourself, so we will be able to hear.
Hello, everyone. It is an honor.
I think there's a problem with the presentation or the sharing.
This conference. My name is Peja, and
So I'm going to play.
going
Is
to
it working
present for
now?
you our research of the smart.
No, it's delaying.
Micro. So what?
Hello. Hello.
Is the author is here with us on the platform?
Yes, I'm here.
Can you share from your side, Dr. Horakh?
Sorry.
The reason
Can I
that
share?
I'm not sharing is
Can you
that
share
I'm going to share, yeah.
by yourself?
Yes, sure.
Yes, please.
so Dr. Mariam, please stop your sharing.
Yeah, stopped. I stopped.
So in that case, Mariam,
Is it visible?
Did it stop the sharing?
You stop the sharing, Dr. Mariam. You stop the sharing.
I stopped the sharing.
Okay.
Yeah, it's okay. Can you hear the recording? Can you hear the video?
Still didn't show up for me.
It didn't show up.
So I'm going to, I don't know, we have to find a solution. So I'm going to share for this one as well, but please, dear valuable authors, stop your sharing. I'm playing the video.
Yes, sure.
For me to be part of this conference. My name is Peja, and I'm going to represent for you our
Is it
research of
working?
the smart sustainable vision in the
Yes.
architecture of the headquarter building, the micro district. So this is how we structured our research, which is the introduction and the background, the current situation that's happening within the headquarter building, the aims of this study, the method that we use, the literature review that is supporting our aims, and the case studies, and finally the discussion and the recommendation. So to begin with, a large part of how people define who they are by what they do. Work can be a key part of our social identity. We use our membership of a group, organization, or profession to build our sense of self and find meaning. Moving from this point to the point of employees spend 70 to 80% of their time in their workspace from the age of 21 until the age of retirement, as work, as we all know, usually do not provide a universally positive experience. The poorly designed workspaces, the challenging work environments, the lack of understanding of the human behavior, and so on, create the necessity of examining the employee's life, creating a better understanding of the application of this psychological aspect, that will lead to a better system, raising the satisfaction and productivity. So according to the workplace stress statistics from 2019, stress, anxiety, and depression are accounted for 55% of the US employees experiencing this kind of stress disorder in their workspaces. Similarly, statistics of MENA region shows that nearly 7 in 10 people, which is 69% of the employees, are suffering from stress disorder. And one of the main reasons are the built environment of the workspace. So the building design has the potential to cause stress and eventually affecting the human health. We all know that stress is a dynamic procedure that is caused by the individual itself. But however, understanding the physical environment that has a significant role in enhancing and decreasing the stress level in the workspace that will create a leap of change in the innovative workspaces and create a leap of change in the employee's life.
So this study is trying to look at the rigid headquarter workspaces and understand the way of designing a new building typology that enhances the work environment and maximizes productivity, creativity, and well-being. And followed by answering the question of how can a design of a sustainable headquarter workspace that allows employees to connect with co-workers, interact with the community around, live and enjoy while working. So the process by which this is done is to further address the design issues through observing the current existing situation in the workspace, the factor that is affecting the human behavior and the level of productivity, and reflecting the architectural implementation of the new innovative work spaces by the literature review, followed by case studies to give us more insights about this kind of places and how can we fix them and implement the good let us say, trends within our buildings, our new buildings design. So firstly, we have to understand the environmental effect on the human behavior, which is there are factors that affecting the employee's behavior, which is the internal forces and the external forces. The internal forces is the ability of the employees to participate, feel comfortable and energetic within the workspace, while for the external forces, it's including the collaborative workspaces, the interactions, the support of the leaders and the employees for themselves, and even the open team environment, all reflecting on the perception of the individual. The second thing is the emotion and the environment, which is the forgotten dimension. People always tend to forget about the emotion and how it reflects on the behavior positively and negatively. So the most important thing from this topic is the social capital, the way the employees interact with each other could promote a sense of trust and vitality, which will lead to sharing experiences and knowledge, generating new ideas, enhancing the level of creative thinking, and so on. This is all leading us to the work environment issues. The study has been conducted by the Ohio State University, tracking the stress level and the impact of the built environment on the workers and the employees. They divided the employees into two groups and into two buildings. The first building has poor lighting and color with low ceiling, lack of spatial organizations, and so on, while the second building was a new office building with an open plan layout, skylights, and colorful interior. The study showed that within 1 year and a half, the employees in the old building felt more stressed and have more anxiety from those in the newer building. This reflects the importance of the built environment and the appropriate organization of the interior on the people and their behavior and their stress and mental health. So after observing the workstations issues, contemporary trends have been emerged in order to influence the design of a workspace. Number one of the trends is the psychological effect of the openness. Is having a place that is open, have this kind of transparency, the glass between one space to another, will lead to create a mutual relationship and interaction between the individual and their work, sharing knowledge, creating this kind of happy place and stimulate the creativity. Going for the open plan layout of the floor plan affects the movement within the building, the visibility, the accessibility, and so on. And this all affects on the user perception and satisfaction. So a comparison has been conducted between two layouts of the open plan layout. Number one is the traditional open plan layout, while the second one is the organic open plan layout, as you can see in these slides. So the organic open plan layout had the circulation points to be more interactive and social engaging, while for the also for the organic open layout, an excellent visibility and accessibility is obtained within this kind of a layout. But we have to know that workspaces with open plan layouts has less control over privacy and security. So the noise is an issue where there is no barrier here. So according to the Harvard Business Review, 60% of the workers in the open plan layout cannot concentrate, while 13% cannot access the quiet place for them to have a quiet moment or to talk or even in the phone and so on. So the solution for this is to create a hybrid layout. The hybrid layout is a balance between the interactive and the private spaces in order to create a multi-zone workstation that meets the collaborative open spaces and the private concentration workspaces and serves everyone's needs and requests. This is one of the examples of the hybrid layout. We're having the flexible open plan layout, having the closed spaces, the glass wall that keeps the spaces open to each other, but having a degree of separation and so on. Also, the flexibility of the spaces. It allows rigid spaces to move and change at the moment of notice, while thinking through all aspects of spaces from, for example, applying movable walls, furniture, and other components that they create a flexibility within the design. One of the most important trends to have within the headquarter building is to develop a sense of community. Everyone that is engaged within a workspace is influenced by the design one way or another. So researchers found that creating a single-story building is better than having multi-story building for the interaction. Some strategies have been suggested to strengthen the social interaction, which is number one, the atrium that will reduce the barriers and create solutions for daylight penetration. While for the corridors, is to design the corridors in a way that encountered the right places and attracts people to have this kind of interaction within them. Then introducing elements of the nature and visual escape. The positive effects of the nature that can create an environment that will help to focus and reduces the stress levels for the workers and the employees, while creating sceneries of nature in the workspace invites us to take breaks from the surrounding and from the distraction and enhances the creativity and productivity. We have also to minimize the noise distraction. The noise pollution can have a significant effect of these challenges on the challenges of the employees' positive behavior. So having zones of concentration, locate noiser teams are part of the quieter teams using acoustical devices and spaces need to be well occupied with sound absorbing materials. These are all strategies that have to be considered while designing a workspace and a headquarters. In the previous topics, the 21st century needs the factors, approaches, open innovative work environment that would stimulate creativity and productivity is discussed. However, taking a closer look on the headquarters in Bahrain is an essential part to address the issues, pair them with the above research and treat for a final solution. So the main three headquarters is the Al Baraka headquarters, Architecture headquarters, and AXA corporate headquarters. So as you can see in the picture, the architecture and the form of the building has a basic form, either square or rectangular. They have weak indoor and outdoor relationship with the three headquarters. As you can see in the picture, these are the only indoor-outdoor relationship that is really not well designed to accommodate people and to interact with each other. So an open plan layout is the main approach of the interior, where most of the employees and workers are open and visible from one to another. Al Baraka and AXA headquarters has a range of workplaces such as interior clean corridors, closed spots, meeting areas, and so on. While Architecture has more typical office floors with floor-to-ceiling partitions wall for high privacy. So to reflect, it is clear that the quality of the headquarters in Bahrain is not enough advanced to suit the employees and the users' everyday needs. A workspace is not just a desk area with a computer that is dedicated to the individual, but on the contrary, it is a place for people to gather with different background, different knowledge, and different kind of ability in order to interact and share this kind of knowledge and benefit each other. Therefore, a headquarters should emerge social engagement, innovative thinking, and support the well-being of users by providing sufficient components and spaces and also spatial organizations. So finally, this research was undertaken to help establish answers to the research question, which is what are the aspects that will enhance the headquarter workspace in order to create more productive environments and enhance the well-being of the user. In terms of this aspect, the finding of this research argues for the need of creating a dialogue between the architecture and the user by understanding the human behavior and the factors that affect the environment. And then when a work environment is creatively designed, the ability to generate new ideas and stimulate creativity will emerge. So we have to know that in a workspace, people have different goals, different moods from one person to another. So some of them need quieter areas, and the other one need playful areas to interact with people around them and to get inspired. So creating diversity in spaces allow people to get inspired in different ways. Proper facilities is a must to have within the workplace and the headquarters, and creating interaction possibility is an important factor to consider. So as a conclusion and a recommendation, reflecting a district or a mini district within the headquarter building could lead to create an effective environment for people to have more work-life balance, because reflecting a mini living that supports the playfulness, the work, the liveliness, and the layers of the livability, the public engagement, and so on within the building could create this kind of daily life practice, and that reduces the stress and increases the productivity and creativity. So thank you so much for listening, and have a great day.
Thank you very much. I think that we don't have other contribution. We have, and it's correct, we don't have other contribution. So
hi there, thank you for joining us today.
Yes, we don't have.
Joining me, Ben, and I've got Stephen here with me as well.
Yes, I would like, of course, I invite the participant if we want to clarify some aspect of made question. Other side, I start with some conclusion after these other three presentation. I think that a reflection about the role of architecture and the relationship between architectural technology emerged from these three papers. The first two are focused on very original and a non-conventional aspect respect to the integration of renewable technology. And I think that these studies are necessary in order to make the renewable infrastructure as a common practice and a reliable system, not only in terms of energy production, but also in terms to resolve other problems such as noise or integration in our buildings. Instead, the last paper, I think that as I remember that technology is not only the application of sophisticated technological device, but our scope as an architect, as a designer in general, is to enhance the environmental quality of our life, our environmental, and improve the quality of our life. So if there is no question, I thank you for attending this conference. I invite all of you to follow the following section. And I don't know if Dr. Sala wants to add something.
Thank you very much, Doctor, to have you with us. If anyone from the audience have any questions, I have one question for Fatma. Is she with us still, Fatma?
Yes.
About the solar control?
I hear you.
Yes, I want to ask something. You have very good presentation. I like it, and I want to ask about you deal with the irradiance of the sun, but did you harmonize that with the natural ventilation? Did you do something regarding this issue, or you just focused on the solar radiation in your study? Because as I understood it from you, the percentage of the opening controlling the sun irradiance, while also it is affecting the natural ventilation. Is these buildings are permeable buildings, or it is allowed to be naturally ventilated, or it is not?
Yes, you are right. Thank you for your question. This study scopes limited just solar radiation, solar control, and sun exposure, but it's must had to evaluate the wind speed and natural ventilation. Because the direct related for the thermal comfort, but we just calculated the solar radiation and sun exposure view factor and related to solar control. But the next studies can be evaluated the natural ventilation.
Okay, thank you. Thank you, Fatma. And I have another question for Fajr. Is she with us?
Yes, I'm with you.
Yes, you have mentioned, I have one reflection about your work. You have mentioned the working environment, and you focused, I think, on the social issue. Okay, I agree 100% that the scenery, the interaction, it's all helping to reduce the stress and to increase the productivity in the work. But in the same time, as an architect, we have to think about the environmental issue. Especially, you had case studies in Bahrain, which is a hot and humid area. Open space, I think it will give extra burden on the loads in the building. We have to think, okay, as an architect, we have to find solution for both. I mean, environmental issue and social issue. What do you think about that?
Yes, I totally agree with you. The climate is really affecting the architecture, and how could we design a building that respects the architecture, respects the climate, and also respecting the social and the interaction within the building. So I totally agree with your reflection. Thank you so much.
Thank you very much. Professor Maurizio, I don't have anything else. Thank you for your wonderful management.
Thank you, Professor. There are other comments about this section. Other side, we can conclude. Thank you very much. Thank you very much for your time, for your effort, and for your scientific contribution to this conference. I hope that you have enjoyed with this time with us, and have a nice evening, and thank you very much. Bye, everyone.
Thank you, dear Dr.
Thank you very much,
I really appreciate that. And unfortunately, I think we haven't had time at the beginning to introduce our valuable authors. I would like to thank to Dr. George Bloomberg, also Dr. Irina Bulak, and Dr. Yenal Akun, which Dr. Yenal Akun has a specific structural suggestion that he proposed. It was very interesting, also in my mind. And I would also like to thank to Dr. Fatima and Dr. Nisha for their valuable presentations. And let's continue. And at the end, for Professor Dr. Mauro Sibila for organization of this session, I really appreciate that. We shall give the ground to Dr. Yasser Faragli if he is available. So he may take the session chairship from Mauri Sibila. Thank you, dear Dr. Mauri Sibila.
Thank you to you.
Thank you also, dear Professor Dr. George Bloomberg. If you want to add any specific comment to your study, also extra comments, it would also be great if you would like to add any.
Sure. Well, I think it's a great opportunity and interesting to discuss sort of a range of topics with a group of people. So I guess what makes me interested about the study of blockchains and the use of blockchains is it can resolve some of the bigger issues about data management in renewable energy networks. And this seems to be a sort of a stumbling block, is managing lots of different devices and systems. And the other thing is that it's community driven. In other words, it starts at the community or individual level and works upwards rather than being a top down or centralized system. So this kind of community-based data management and reconciliation system is very attractive for governments when it comes time to try to comply with our carbon reduction goals, our carbon reduction targets. So I think that the research is really motivated by the ability or by the opportunity to try and figure out easy ways to manage and reduce carbon using carbon trading techniques. And this way to sort of bit by bit in a small manner improve carbon emissions. So that's sort of the energy, the enthusiasm I have behind this particular research.
Perfect, perfect. Thank you very much. Very nice professional abstract and conclusion for your study. I really appreciate that. Dr. Yengal Akun, also, if you have any specific comments, also, it would be perfect to have your opinion about your study or conclusion, or if you think that anything is missing from your project. So if not,
are you asking me? Did you ask me that question?
No, sorry, Dr. Yengal Akun, our third presenter, the review of contemporary adaptive structure and future perspective. I think he left, Dr. Yengal. He was around, but now I can see that he's not in. So we shall, I think, give the floor to Dr. Yasser Farajli to start his own session of architecture and technology by focusing more on environmental studies with the session co-chairship of Dr. Mariam Iranfar. So if Yasser Farajli is around, if not, or Dr. Mariam, if you have anything to add to start, we shall go directly to the presentations, if you don't mind.
Sure, Doctor. This is the fourth round table in architecture and technology. The first presentation, it will be about the international between restorative environments and visual performance in university campus landscapes. Shall I start with the first presentation to share?
Yes, if you please, let's see whether if you could do
the
it.
author is here.
Perfect. If you can manage to share the video.
Okay. One minute, I will share the video.
So the presentation will be about Dr. Yasser Farajli, Dr. Nermin Alhani, and Dr. Yasmin Moussa, working on the interrelation between restorative environment and visual preferences in university campus landscape. So,
yes. Okay, I will share it. Is it, the sound is okay?
No, I don't think it's working.
Okay, I think I should also take the responsibility. If you
I think we have a problem with the connection. It is not very strong enough.
Yes. Please, Dr. Mariam, if you stop your sharing, I will share from here.
Hi, dear conference participants. Welcome to my presentation.
Dr. Mariam, I think you have to stop sharing.
Can you?
Doctor.
I'm going to search a different time.
Is it working, Salah?
Now I will stop to sharing. My connection is not good.
I have organized this course in the following section: introduction, methodology, design of 3D and the alternatives, environmental noise modeling, evaluation of findings, and discussion and conclusion. The first point concerns the issue of air traffic noise. Although noise and energy in general do not have a direct relationship, the transportation sector is responsible for a major share of energy consumption. Additionally, transportation has many phases related to environmental pollution, such as air and noise.
Something else is being shared. I don't think it's not the same paper.
Of air traffic on energy and noise pollution. Noise barriers can be the best solution when more noise control measures are taken either at
You mean that it's not sharing? I'm not. It is. I think it's working.
noise barriers are
This is not the presentation.
Dr. Huraksh, this is not the presentation.
No.
Second one.
Dr. Huraksh, if you hear me, this is not the presentation that we
I
should.
got it. I'm going to share a new design proposal. Am I right? So let me share this one. A new design proposal.
I am a doctorate student at Architecture and I am a research assistant at
No, we have seen this one, my dear.
Dr. Huraksh, should be the interrelationship between restorative environment and visual performance.
I think this one.
Preference.
Yeah, this one.
Yes, this one. Yes, thank you.
experiencing nature has become difficult disorders such as anxiety, stress, and depression. And statistics also show this, where stress is the main cause of 60% of all in university campuses. And most educational settings require high levels of attention and creativity and productivity. And this attention causes them to suffer such mental disorders. So the question is, how can designers create other restorative environments for such stressful settings? So the first point we'll be discussing is restorative environment. When a person perceives an outdoor setting, usually this perception is through sensory input. Studies show that more than 80% of humans receive input through vision. That's why environments are primarily visually perceived. However, visual perception requires preferences or is controlled by preferences. And people have specific landscape preferences, and that's why the second point we'll be discussing is visual landscape preferences. Finally, for a person to perceive outdoor campus setting, there are specific requirements for campuses. These considerations will also be studied through the literature. So this is the third point. However, there are no coherent frameworks which correlate with the mentioned.
of restorative environments, visual landscape preferences, and campus design considerations. Therefore, this study focuses on creating a comprehensive assessment tool through understanding the perceptual dimension and the physical dimension of restorative campus environments through a literature review. And finally, the perceptual dimension leads to the creation of the perceptual framework, and the physical dimension will lead to the creation of the physical framework, and finally, a comprehensive assessment tool to understand better how our campus landscapes outdoors restorative environments. First of all, the physical dimension, the perceptual dimension. Restorative environments are designed to create such feelings such as contemplation or healing effects for people. That's why they're important. And there have been two theories on restorative environments, ART and SRT. The ART states that restoration takes place when a person focuses when they direct their attention in an involuntary way. And it has 4 stages, and there are specific points or specific qualities that are required for this attention, which are being right, destination, extent, compatibility. However, the stress reduction theory developed by Roger Ulrich states that it's a rapid response to the total configurational properties of the scene, and they're based on preference judgments. So this takes us to the second point, preferences, visual landscape preferences. So if a person is stressed in the environment, they're more likely to become healed. There have been also 2 frameworks. The first is Roger Ulrich's model, and the second is a developed version of it by TVA. So this is mainly many different theories were studied using this framework, and they developed or created 9 visual landscape preference indicators. These indicators are complexity, coherence, disturbance, stewardship, imageability, visual scale, naturalness, and ephemeral. So this is a summary of the 9 visual concepts and their dimensions, definitions, landscape attributes, and potential indicators. Here's an example for stewardship, and here's another example for imageability. So, however, when we're talking about perception, there are specific variables that have to be considered, whether it's cultural, individual differences, or physical landscape. And these variables cannot be ignored as they might alter the response. So mainly most of the variables from the literature were grouped into this table, and they were accordingly classified into 4 different categories, with 4 different types: safety, activity, familiarity, and data accessibility. Second is the physical dimension. First, we'll be discussing the campus physical dimension in general, and then we'll go through the specific facts concerning the meso and the micro level constituents of restorative campus landscapes. The first level is the macro level, where studies have shown that campus morphology has major planning problems such as insufficient square footage, diminished quality of buildings, facilities, spacelessness, and so on. So really, campuses do need development. Meso level, there are different configurations, spatial configurations from meso levels and university campuses, such as the home base, front porch, front yard, backyard, and turf. And finally, the different types of landscape elements, which include soft landscape, hard landscape, water bodies, materials, and monument elements. So according to these classifications, we moved on to the restorative campus physical dimension. First is the meso level, based on campus outdoor spaces. General design recommendations were added using the framework. And according according to the micro-level constituents, there are different elements that, if are present in outdoor spaces, can enhance the restorative effects of health, as well as water features noted like vegetation, landmarks, balconies, street structures, as you can see here. So this table is hence developed with the 18 state constituents and then the restorative qualities and the design considerations. So, for example, this part, the sensory reading palette helps in the array of positive distraction, and the design considerations for it that it should have foliage that is in rooms to draw visual attention and inviting tactile qualities. Finally, this is the developed perceptual framework according to the restorative context, visual preferences, and spatial usage solutions or variables. And this is the physical framework according to the mother-level and macro-level constituents of campus landscapes. Finally, these two frameworks have been merged into a active assessment tool, and this tool shows the relationships between. For example, for being array, if there are water features, then it enhances the quality of being array. However, if there are no landmarks, identity or place-based relationships will be impacted. So this framework can be used to assess the shortcomings of practices and understand how restorative spaces are. The perceptual dimension requires individual opinions, while the physical dimension requires visual survey. So it doesn't need questionnaire, so it only needs professional opinions. And while using these two frameworks, one should consider the variables that can alter perceptions, including judgment, restoration, age, economics, and social experience. Finally, the notions of restorative environments and visual preferences can significantly improve people's lives, specifically in linguistic campuses where people are constantly stressed. This can also be used to provide information on shortcomings of landscape campuses and deliver guidelines on how to create better open spaces. However, further studies are required to implement it and prove its validity in different landscape settings. And further research is also required to develop a method for statistical analysis using the proposed tool.
Thank you very much. I can see that Dr. Yasser Farakli is here. Welcome, dear Dr. Yasser. How are you?
Hello, how are you?
Thank you very much. Sorry
I think this session started a bit earlier than the planned time, right?
Exactly. That's please accept my apologies.
No.
The platform is yours, and I just finished the first one, and you can have your introduction and share the authors and introduce the authors as you wish. So the platform is yours.
Okay.
Thank you.
Thank you very much to take over, and sorry for the delay, but actually, as you mentioned, we started a bit earlier than the planned time. So shall I proceed for the next paper, or
as you wish, you are the chair, as you wish. Yes, please.
Okay, thank you very much. Thank you very much, Professor Yasmin. I really appreciate your effort and your presentation. And now we'll start with the second paper entitled The Influence of Diverse Building Height and Building Coverage Ratio on Outdoor Thermal Performance in Hot Climates. The paper presented by Mariam Ashraf Adli and Omar Galal. So we'll start now with the second paper.
Hi, this is Mariam Ashraf, and today we'll discuss the paper titled by The Influence of Diverse Building Height and Building Coverage Ratio on Outdoor.
Just a moment.
Hi, this is Mariam Ashraf, and today we'll discuss the paper titled by The Influence of Diverse Building Height and Building Coverage Ratio on Outdoor Thermal Performance in Hot Climates, a review. So briefly starting with the introduction, although urban form can significantly affect outdoor climatic conditions, urban planners do not sufficiently consider such impact while designing new urban communities, and this problem highly appeared in Egypt while the government set its ambitious urban strategic plan to relocate its inhabitants from the highly dense populated Nile Valley into the uninhabited areas of the hot deserts, which is 94% of Egypt's lands. Unfortunately, most of these cities are featured by hot arid climate with relatively high temperatures. So in order to be eco-friendly, this urban development needs a special criteria from decision makers and urban planners to design in such climate, a harsh climate, which should passively ensure good ambient conditions. Usually studies that are interested in microclimate and the relation between microclimate and urban form are focused onto three morphological parameters that are aspect ratio, which is simply the relation between the height of the buildings overlooking the street with respect to the street width. Secondly, the sky view factor, which is the proportion of the sky that is exposed to a specific position within the urban environment. Thirdly, the orientation, which is not only the orientation of the streets, but as well as the orientation of the buildings as well. So the problem is that new cities are not compatible to their climate. All social housing in new urban communities such as New Cairo, New Okroudwer, and cities in Upper Egypt suffer from the following. First, by commitment to unify a prototype, which is ground plus 5 floors, for rapid execution and fixed cost without taking in consideration the street width or its orientation, which affects the quality of life for social housing residents. Secondly, high sky view factor values, which results into lower aspect ratios, as a result less shaded areas. Moreover, urban planners preferred curvilinear street network as an aesthetic scene, which no longer set up a leading orientations. Consequently, all of this had great influence on the microclimate and the pedestrian thermal comfort. Reviewing the prior literature, it can be classified into studies that dealt with urban canyon geometrical parameters such as aspect ratio, orientation, sky view factor, and manipulation of building heights, as well as urban form, shape, and size. Moreover, building typologies, whether it is attached or detached. All of these studies were analyzed to find gaps which can lead us to find a new approach. First, discussing the studies which focused on the influence of canyon orientation and aspect ratio on thermal comfort. Rodriguez 2016 in Cuba's Savannah climate used Rayman simulation model to investigate a symmetrical urban street canyon with 9-meter width and 380-meter long in a zigzag urban form, who tested different solar orientations under different aspect ratios from 0.5 to 5. The street canyon was subdivided into 5 equal sections with 1.5 meter apart. The results reveal that the north-south orientation is the best orientation for summer, with aspect ratios ranges between 2 to 5. Also, when point E is the best for north-south orientation. As for the east-west orientation, aspect ratio should be more than 0.5, and in summer it should reach 1 with the addition of trees. Also, a local study in New Cairo, hot arid climate, by Shafai 2018 reached to nearly similar results in an aligned urban form, that in summer the north-south orientation aspect ratio should be 3, not more or less, and with east-west orientations aspect ratio 1 is the most preferable for the east-west orientation. Moving forward, for the studies that focused on the impact of urban geometry, aspect ratio, orientation, and sky view factor on the urban microclimate, Borbia in 2010 in Constantine, a semi-arid climate, found that the surface and the air temperature increases when the sky view factor increases and the aspect ratio decreases. Another study focused on the impact of building typology on microclimate and thermal performance as well. Yahya and Johnson in 2013 in Damascus, Syria, modeled using MVMAP two residential zones in New Damascus, the attached building of 0.31 aspect ratio and 0.83, and compared it to the attached buildings in the Old Damascus of aspect ratio 2.95. The results emphasized that the highest PET values was found in the middle of the street in the New Damascus of 50 degrees Celsius at 2 p.m. in the modern zone, while the lowest was in the Old Damascus buildings with attached buildings. Recently, in 2020, Sharif and Abu Hajla studied the influence of manipulating building heights on outdoor thermal performance. First, he simulated the base case with uniform building height ground plus 5 floors, and the results indicated that the north-south orientation is surely the best, while the worst orientation is the northeast-southwest, with the difference between the previous orientation 1.84 degrees Celsius. Then he compared it to several cases in the whether in the short direction or the long direction. However, the results revealed that the short axis obtained better results due to the effective height variation than the gradual variation in the long direction. A local study focused on the impact of urban form on PET in new urban cities expansions. By Galal 2020, first, a quarter in New Aswan city with curvilinear urban form were selected and calibrated via MVMAT after taking measurements from New Aswan University. Next, compared to 4 quarters in Great Cairo regions with different urban forms were either irregular, zigzag, radial, or zigzag anyan, and the results appeared that the highest average PET values and air temperature were in New Aswan and the lowest in the Mohandesin quarter, with difference of 8.14 degrees Celsius. The research also recommended floor area ratio of 7.6 and enclosure fraction 90 for hot climates, with aspect ratio approximately 3 and orientation north-south or northeast-southwest. And this should lead us to a new approach in our research that focuses on urban blocks, standard deviation of building heights under different orientations, and floor area ratios and building coverage ratios as well. Quarter in New October, which is a result of 6 October city expansion, is taken to illustrate the idea more. Here are the suggested scenarios against the base case, which is characterized by ground and 5 floors, building coverage ratio 0.34 and floor area ratio 2.04. In the first scenario, the building heights were raised to ground and 8 floors for all the apartments, while in the second scenario, the front and the back of the urban block is raised in height for ground and 8 floors, while the middle of the urban block stayed the same. In the third scenarios, it is just the opposite of the second scenario. Here we can notice that the floor area ratio increased in these scenarios against the base case. Increase in
Well, thank you very much for your presentation. Well, thank you very much for your presentation. Actually, very interesting topics, including building heights, orientation, aspect ratio, thermal performance, are very important issues, especially with the new extensions witnessed by Egypt right now. So now we'll proceed for our next presentation. Okay, so the next presentation will be the development of aperture at residential buildings of Mediterranean climates for mitigation of carbon emissions. The paper will be presented by Dr. Mariam Iranfar, Dr. Salah Mohildin, and now we'll start this presentation.
Do you love Gantt charts? Here's how easily you can build one in ClickUp. Let's map out.
Hello, everybody. My name is Mariam Iranfar, PhD in architecture. The title of my article is The Development of Aperture and Residential Building of Mediterranean Climate for Mitigation of Carbon Emission in Kyrenia, Northern Cyprus, as a case study. Global warming, as we know, it is a significant threat for the countries which they are located beside the coastal areas, because each 10 centimeter rise in sea level will increase 10 meter square strips of the coastal area around the world. Carbon dioxide emission from the building increased by the using the fossil fuels or indirect using of fossil fuels through the electricity. The building sector consumes more than 40% of global energy and produces 24% of greenhouse gases. The current study tries to reduce the carbon dioxide emission in residential building in Kyrenia, Northern Cyprus, with understanding the effect of the aperture, physical characteristic of the aperture on the energy consumption. Mediterranean region is one of the distinguished climate change hotspot and most responsible region for global warming. Aperture is defined in this case study as a transparent opening, outer glazing area, and they are also important to adding aesthetic value to the building design. Kyrenia in Northern Cyprus has selected as a region for the case study for two reasons, which is unique topographical character, which includes the coastal area, inland area, and mountainous area. The study hypothesizes that understanding the physical characteristic of outer glazing areas with the respect of excellent view, mountain view, and sea view can develop the architectural environmental design criteria in Mediterranean climate. The aim of the study is to find, develop guidelines for aperture physical characteristics for lower carbon dioxide emission in the buildings, which assist the professional and government to legislate the new building rules. Two questions has been conducted in this research: how much the aperture physical characteristic in the residential building of Mediterranean climates affect building CO2 emission according to the limitation of the current study, and how much is proper to develop a model to calculate CO2 emission through resizing the glazing elements or the window wall ratio to reduce CO2 emission in residential building with excellent view as sea view and mountain view. The methodology case study samples selected in Kyrenia in northern Cyprus, 30 existing residential buildings with various topologies like detached houses, semi-detached houses, or apartment blocks in Kyrenia with different topographic characteristics of Kyrenia, such as coastal, inland, and mountainous areas has been selected. The height of the selected buildings is limited to 3 floors to neglect the different factors which is happening with the increasing of the height, like wind speed. The study will focus on the buildings with 2 main following orientation: northern orientation, sea view, and southern orientation, mountain view. This is the 30 case studies selected in different districts of Kyrenia, like Lapto, Alsancak, Karagloglu, Karaman, and the observation method. Direct observation method for collecting data is including the classify the types and materials of the aperture, glazing area, and frames for the existing building in coastal area, inland area, and mountainous area of the Kyrenia. Determining window to wall ratio, WWR, in the residential building in Kyrenia. Identification of the building envelopes type for the collected samples. Including non-transparent elements like roofs, outer walls, and floor. This is the 5 different frames and glasses in the case study samples. The most common and prevalent was the first one. Design builder simulation software. The model was developed based on existing data collected during the different fieldwork for the selected sample buildings. The first step in the design builder simulation was to create the eventual model regarding the selected sample buildings with floor area 10 by 10, 100 meters square. A single family unit is without basement and like cubic shape. The aim of the modeling is to simulate real condition according to initial indications. The climate condition of the sample building is simulated in the design builder. This is the one sample of eventual model for the study in summertime, in sea view, in morning, noon, and afternoon. This is the different tabs in design builder software, location tab, which is include the location details, time zone, weather simulation, wind speed, and direction, and site tab, which is belong to latitude, longitude, and height of the above the sea. How the location of the sample is defined by latitude, longitude, and elevation above the sea. And this is, I found it from the topographical map of Kyrenia in Google, which is for the coastal area between 0 to 10, for the innerland 10 to 60, and for the higher mountain between 60 and 300. The weather simulation has been applied according to 2 main seasons, summer, July and August, and in the winter, January and February. This is the activity tab, which is explaining the factor. Activity factor for men is 1, for women is 0.85, for children 0.75, and the householding intensity is 20%. This is the sample of roof material and U-value calculation with design builder software. According the construction material were selected based on the direct observation of the selected sample buildings according to 8 of plans and available CAD files. This is the glazing tab. which is identify the glass elements of the building. The focus of the study is with the windows and doors, glass windows and doors. Friend WWR and the dimension of glazing area on the eventual model, southern and northern ones. There are 3 different WWR applied in this research in order to understand the effects on the glazing size on CO2 emission in Kyrenia according to this climatic condition. This is the percentage in northern direction, southern direction, maximum WWR, average and standard, and the size of the windows. And type of glazing area on the eventual model. According to the observation for the window types in Kyrenia building, commonly one type of window glass prevalent, like double clear, and 3 different types have been suggested based on their cost and accessibility to apply in eventual model to compare them in the simulation result to find the optimum CO2 emission through the windows in both sea view and mountain view. This is double clear, double gray, and triple clear glass. The electricity consumption is considered as the analysis and findings. The electricity consumption is considered as a major factor for estimating CO2 emission in the selected building samples. The majority of the sample buildings uses active heating and cooling system to heat and cool their units. Passive heating and cooling system are used less frequently in sample buildings. This is the annual carbon dioxide emission in coastal area, sea view and mountain views with different WWR and glass material through design with estimation. This is the table with double clear glass, double gray, the triple gray in north and south, and this is the numbers for maximum WR, average WWR, and standard WWR. This is the same, but for the inner land region. And both regions, coastal area and inland area, have similar climatic characteristics and same solar radiation. During the simulation in design builder, ventilation and thermal bridge were not taken in consideration. The simulation focuses on the effect of window type, size and energy consumption and CO2 emission in selected sample buildings in Kyrenia region as a limitation of the study. This is this annual carbon dioxide emission in mountainous regions, sea and mountain view, with different WWR. This is the table for mountainous. And from the tables, this is the result analysis of sea view in coastal area buildings. The production of CO2 emission in summertime is more than winter time. Maximum WWR leads to consume more energy than standard and average WWR. Cooling system consumes more energy than heating system by 2 times. Triple clear glazing is the more proper than other types, means double gray and double clear. Maximum WWR produce more than standard and average WWR. This is the analysis of mountain view in coastal area buildings. Energy consumption and CO2 emission in summertime is more. Maximum WWR producing more CO2 than standard and average WWR. Cooling system is consuming more energy by 3 times of heating system. Triple clear glazing is the most proper. But double gray only for summertime is proper also in this direction. Cooling load is more than heating load in the comparison of heating and cooling load. Analysis of sea view in mountain area buildings. CO2 emission in summertime is more than winter time. Also, maximum WWR produce more than standard WWR. Cooling system is consuming more energy than heating system by 2 times, and triple clear glazing is more proper than other types. Also, this is analysis of mountain view in mountainous area building. CO2 emission in summertime is more than but lower than other region. Maximum WWR is producing more than average and standard. Cooling system is consuming more energy than heating system by more than 3 times. Triple clear glazing is the most proper glazing than others. Cooling load in mountain view more than sea view by 14% when WWR is bigger with double clear glazing. A relationship between WWR value and carbon dioxide emission in Kyrenia. A linear regression analysis has applied to determine the relationship between CO2 emission and WWR value in different topographical area in Kyrenia, with consideration 3 different glazing types. The relationship will help to evaluate the CO2 emission per year according to the increase of WWR value and vice versa. The result shows very strong correlation coefficient, which is equal to 1. This is the table that we got it from the linear correlation. Conclusion. The study showed that there is high energy consumption and CO2 emissions to maintain comfort in the residential buildings in Kyrenia. The study suggested different materials to help in the mitigation of CO2 emission according to the building view and the location within the 3 areas, coastal, inland, and mountainous. The study suggested a mathematical model based on linear regression formulas to help the professional to evaluate CO2 emission through the WWR value in each area with different views. This is also show that WWR CO2 emission production in Kyrenia become more. CO2 emission in sea view is more than mountain view, and also CO2 emission in coastal and inland region is more than mountainous region, and sea view building in mountainous region can have bigger WWR by 33% compared to other to achieve the same CO2 emission. This is the references. Thank you.
Well, thank you very much, Dr. Mariam. Actually, you really targeted many of the important topics and very in-depth studies related to building materials, opening ratios,
Good grammar and spelling are important, but if you want
also the glazing size in relation to carbon emissions. So thank you very much for your presentation and study. Now we'll proceed for the final presentation for this part, and we'll start some discussions related to questions and answers. So our last paper in this part will be sustainability in architecture, low-tech or high-tech. The paper will be presented by Dr. Seida Emikci, and I hope that I pronounced the name correctly.
Excuse me, Dr. Yasser, is the author is here?
So, can you hear me?
Professor at Untitled University. As you all know, the concept of sustainability has been becoming more and more important all over the world. It is an urgent need to make all processes sustainable in order to protect environment as well as human life. Many technological innovations are emerging to ensure sustainability. This rapid development, especially in architecture, make it increasingly difficult to distinguish the concept of sustainability and technological innovation from each other. Sustainability has started to take place in our life completely technology-oriented concept. This presentation is to seek an answer to the question of whether a concept of sustainability in architecture can be achieved with low technology through this article. This presentation also discusses which approach should adopt to ensure sustainability. Climate change is one of the biggest problems facing the world today. The vast majority of the research on climate shows that human activities can cause rapid change in climate. They cause serious environmental damage. Cities or urbanization are the main contributor to climate change. Although cities cover only 2% of the Earth's surface, they consume approximately 80% of global energy. They are responsible for more than 60% of greenhouse gas emission. If we break down by the sectors, more than a half of the energy consumption by cities comes from buildings. This means making buildings sustainable, one of the most fundamental things that can be done to fight climate change. So, what is sustainability? Sustainability, in its broadest definition, development that meets today's need without compromising the ability of future generations to meet their own needs. According to this definition, we are able to say that sustainability definition centered on humans and the environment. Along with the development of the technology, it started to evolve into a concept that centered on technology. Many studies state that sustainability should be taken together with technology. Sustainability in architecture start to be perceived as a technology-oriented concept. The effects of the climate change are increasingly felt. At the same time, it is recorded in technological developments. This triggers the trend towards high-tech solutions to reduce climate change effect. However, before the Industrial Revolution, architecture was vernacular, as local materials were used and built according to local climate conditions. Now this completely changed, but still many architects support architecture should be vernacular. And others argue that it is a good method to equip building with the technology. Vernacular architecture consists of the experience of people living in different climate conditions through trial and error. The vernacular architecture provides us not only saving energy but also living in healthy building. On the other hand, technology makes our life easier and more comfortable. In doing so, it aims to control and optimize resource usage. Technology makes buildings remotely monitored and accessible and controllable, and it can offer sensor and device to meet the needs of their inhabitants. Technology in architecture can take action to ensure energy efficiency and thermal comfort after these measurements. Some studies believe that technology will play an important role in the transition to low-carbon energy system. In addition to that, technology provides new services such as elderly care, child care, security, assisted living, health monitoring. And now, time to discuss and time to decide which approach is more sustainable. On the one hand, the vernacular architecture approach tends to favor the minimum energy and local material required to construct, repair, and operate a building. On the other hand, high-tech solution aims to improve the quality of life of the inhabitant by offering new services. Or, more efficient control and management of existing surface. Therefore, it is necessary to combine high-tech and low-tech solutions in order to eliminate the disadvantages caused by both approaches to make buildings sustainable. This presentation suggests appropriate technology, which means readoptions of traditional local architecture that really takes local condition and local needs into account without rejecting that technology has provided undeniable benefits. The concept of appropriate technology in architecture refers to the period from extraction of the building material to the end of the life of the building in new buildings. This process should be handled holistically with the help of both technology and vernacular architecture passed down through generation. Appropriate technology makes buildings not only vernacular but also the opportunity to be smart. Thank you for listening to me. Thank you for your patience.
Thank you very much, Dr. Saida. So close this. Thank you very much. And now we will start the round table for discussion. Actually, we have some more time than the planned because we started this section earlier than the planned time. So we still have more time than the planned for the roundtable discussion and answers. So would like to welcome any questions for the presenters. If you have any questions or discussions or comments for the presenters, that will be very interesting. So if anyone has any questions, you can raise hand on the participant panel. So we'll organize this discussion. Any questions?
I think Dr. Salar has a question.
Thank you. I couldn't catch up with all the presentations because I have problem with my internet, unfortunately, but I could see the presentation. I can't hear you. Do you hear me now? Hello?
Yes, I can hear you.
Oh, okay, okay. Yes, please.
Yes, I have a question regarding the first or the second presentation, the influence of diverse building height. I saw that the authors, the researchers had some dealing with the orientation of the streets and how much it will affect the thermal performance and such things. I want to ask, does the traffic movement of the traffic density should be involved in this process, or it is neglected? Because as we know, the traffic has a big role in as a heat source and the pollution source. Just I had this question, if you answer me.
Yes, thanks, Dr. Seller, for your inquiry. While this research focused on not only the orientation, but the rural and the heights and the floor area ratio and the building coverage ratio as well. Whether actually it was focused on social housing, and the anthropogenic heat from the traffic is not that much, so actually it wasn't the dominant factor in this research.
Okay, so was that clear, Dr. Salar?
I didn't hear the answer. I will prefer to write it to me if it is possible, because I am not hearing very well. Sorry, it is my problem, not the problem of
Yes, she
problem is
mentioned
not
that.
yours.
Yes, she
Just
do you hear
yes.
me? Would you like her to repeat what she said again, if you now hear, if you hear well now?
If it is possible, because I'm hearing now well, if it is possible.
Yes, sure.
Dr. Mariam, would you kindly
Yes,
repeat?
sure.
Yeah.
Okay.
Sorry for disturbance.
No problem. So I was saying that this research mainly focused on not only the building orientation, but the building footprints and the manipulation in building heights and floor area ratio. So as this was the gap in the previous research, so it was focused on social housing buildings where there isn't so much traffic there. So the effect of the anthropogenic heats is not that much, so it was neglected.
Thank you. Thank you very much.
I think this opened the opportunity for further research and future research that can study specifically your point in a specific paper. So
Yes.
this could be an extension.
Exactly, this is correct.
Yeah, sure.
Yeah. So maybe.
Thank you.
Okay, thank you very much.
Thank you very much.
Thank you. So also there was a question. Yes, Dr. Zainab Medjeldi is having a question to Dr. Saida. So Dr. Zainab? Dr. Zainab, are you available now? Okay, so until Dr. Zainab rejoin again. So she wrote this question for me. I can read her question to Dr. Saida. She is asking, please, which kind of technology can really help building to be smart? Give us some examples, please, and thank you. So, Dr. Saida? So can you hear me? Anyone can hear me right now?
Dr. Saida is muted.
Dr. Saida is not available now?
She is muted. She is muted. Please unmute Dr. Saida.
Okay. Okay. Okay. Okay. So.
Okay. So now it's okay.
Yes, Dr. Saida. Now you can. Dr. Saida? Hello, Dr. Saida? Okay. So she has connection.
Maybe her connection is very low.
Yes, yes. So if you can write your answer to Dr. Zainab Medjeldi, that will be thankful. She was asking about, she would like you to give her some examples of the smart technologies used in buildings. So she was asking exactly what kind of technology can really help building to be smart. Would you kindly send her some example for this, for your idea in this paper? So any other questions, please? Any other questions? Okay, so actually this session or this first half of the session was very rich in many topics, including building heights, orientation, aspect ratio, thermal performance, Mediterranean climate, also some issues related to landscape at the very beginning. And actually some of them followed the traditional approach, and some others followed building simulation using computer tools in order to have some weather and temperature data. So that was very helpful and very interesting field. Now we still have time for the beginning of the second half of this session. The second half of this session should start at 15:05. So would you like to proceed with the next papers, or?
Yes, sir. Sorry for intervention. If you are sure that the authors are available, so we can continue.
Okay.
What do you think?
Yes, we can continue definitely for the second half. I'm just wondering if any other would like to join at the scheduled time, so we'll let him join in the correct timing. But I have no problem. If you would like to proceed, that will be fine.
I think we can proceed if the authors are available.
So,
in order to present with their attendance, I mean.
Actually, we are the next one in the presentation. We are here with my co-author. We can continue if you.
Okay, so okay, so let's start with the second half of this session. The first paper on this second half will be Climate, Site and Light, Revisiting Critical Regionalism through the Works of Architects. This paper will be presented by PhD candidate Onku Azalp. I hope I pronounced the name correctly, and Dr. Saliha Aslan.
Thank you for your introduction.
Thank you very much.
For the presentation. Welcome everyone. Before the presentation, I, Öncü Özalp, and my co-author Saliha Aslan would like to thank the organization and scientific committee of the symposium, as well as the listeners for their contribution. Today we will talk about climate, site and light, revisiting critical regionalism through the works of architects. The emphasis on environmental aspects such as topography, climate and light were brought into consideration as critical responses to the placeless and universalist aesthetic of modernist designs through Kenneth Frampton's theoretical concept entitled Critical Regionalism. It not only emphasized the relevance of climate, topography, light, and site, but also provided a high sensitivity and thought-provoking discussions in approaching those concepts. In this presentation, we will revisit Frampton's concept of critical regionalism, elaborate the examples which were given by him, and shortly provide counter-arguments related to this concept. In this regard, we are also inspired from the article entitled Critical Regionalism by Tom Overmaid, Veronique Patiou, Lee Katerina Shitka, and Hans Tiders, which will be highlighted in the final section of this presentation.
Before elaborating his conceptualization of critical regionalism, Frampton notes his critical stance on modernism's universal validity and his position regarding populism or sentimental regionalism as, quote, a critical regard has to remove itself from both the optimization of advanced technology and ever-present tendency to regress into nostalgia nostalgic historicism or the glibly decorative. It's my contention that only an avant-garde has the capacity to cultivate a resistant, identity-giving culture, while at the same time having discrete recourse to universal technique, unquote.
On the articulation of the concept critical regionalism, he notes, quote, the fundamental strategy of critical regionalism is to mediate the impact of universal civilization with elements derived directly from the peculiarities of a particular place. It's clear from the above that critical regionalism depends upon maintaining a high level of critical self-consciousness. It may find its governing inspiration in such things as range and quality of the local light, or in a tectonic derived from a peculiar structural mode, or in the topography of a given site. In elaborating Altos Saynatsalo Town Hall, Frampton gives particular emphasis to the sensory experience of the building. For instance, the stairs of the public circulation in the building and its finishing material suggest a friction which reflects on the visitors as a distinctive kinesthetic experience. For Frampton, the significance of tactile is highly related with the notion of physical experience, and the tactile qualities arouse a poetic consciousness for the architects which is related with forming place form. As he puts, quote, the tactile and the tectonic jointly have the capacity to transcend the mere appearance of the technical in much the same way as the place form has the potential to withstand the relentless onslaught of global modernization. Unquote.
Also, how to approach a site becomes very important in the articulations of Frampton with respect to the distinctive qualities of place form. In his own words, bulldozing of an irregular topography into a flat site suggests placelessness. However, thinking about the idea of terracing site into a stepped form recalls cultivating the site. The second way of thinking can generally be critical regionalist. In Frampton, a hypersensitivity is displayed in Siza's architectural approach, which encourages the configuration of topography with respect to the specificities of both site and locality. With a high consideration of local material, craftwork, and light, the architect transcends rational form and modern technique. Embedding the buildings into topography and increasing tectonic values in architecture can be observed in the works of Siza, which were topographically structured buildings instead of visually and graphically designed buildings.
For Frampton, the particular emphasis on design reveals the existence of site in Raymond Abraham's project. This imaginary project demonstrates the material existence of architecture as observed through its tectonic form. It transforms the Earth's surface while proposing an interrelated tectonic form with the ground. Following Frampton, Bottas houses display a relationship between buildings and topography as well as insight into landscape. Inspiring from traditional agricultural barn-like structures, Bottas houses can easily be recognized in the landscape, and their configuration relates to the topography with respect to the idea of building the site or cultivating the site instead of aligning with the existing contours of the site.
So far, we have observed Frampton's notes on the architectural examples and how he frames architects as critical regionalists via their approaches and internalization of topography, climate, and site. Although those examples are influential in observing architects from the critical standpoint of an architecture critic, we need to elaborate criticism toward the term for a broader understanding of it. In Keith Eganer's inspiring article, Placing Resistance, a critic of critical regionalism, we observe the writer's critical stance on the term and how the concept becomes insufficient in explaining complex, intricate, and interrelatedness of inherent discourses which emerged in different cultures. For Igner, similar to the post-colonialist discourses, critical regionalism tends to develop its arguments upon twofold oppositions, such as East-West, modern traditional, and natural cultural. A similarity can be drawn from the notes of Ignacio de Solamorale, which emphasizes his theoretical thinking as a dialectical and thus less monist, less self-enclosed approach, and as a proposal for looking at current architectural scene from a rather dualist version.
The OASI Journal 103 focuses particularly on the concept of critical regionalism. The editors of the journal, Tom Overmaid, Veronique Patiou, Lee Catherine Schatzka, and Hans Teeders, provide a comprehensive study on Frampton, which is entitled Revisiting Critical Regionalism. For the writers, critical regionalism enlarged Western European and North American architectural history to a certain extent by introducing the works of architects from Latin America, Portugal, Finland, and Spain. Also, with its critical positions towards universality and universalization, critical regionalism contributed to the existing paradigms in the practice of design. For the writers, the specific importance of critical regionalism stems from its relevancy in both design practice and architecture theory. Besides, thanks to critical regionalism, architects in different geographies could have a reference point to comprehend the practice from a larger perspective.
In addition to those arguments for a closer perspective towards the conceptualization of Frampton on the notion of place and space, we can also refer to Charles Holland's article, Building Writing History. As the writer notes, quote, using Heidegger's metaphysics as a source, Frampton distinguishes between the supposed authentic properties of place and the abstractions of architectural and universal space. While place can be experienced physically via physical, haptic, and tactile qualities, space is part of capitalism's abstract systems of value. The cultivation of the physical properties of the site is then, for Frampton, a meaningful way to resist the forces of globalized capitalism. Unquote.
As a concluding remark, we can elaborate that although Frampton's theoretical framework develops upon restricted bipolarities, it pointed out important dimensions of architecture making in evaluating and bringing forward the tactile, phenomenological dimensions, and provided thought-provoking discussions in articulating architects' work in relation to site, light, and climate. We believe the relevancy of those strains related to sensory experience become increasingly important in critical thinking of the destructive impact of capitalism and its infiltration into architecture. Thank you for your concern.
Thank you.
Well, thank you very much. Thank you very much, Dr. Unku Uzalp and Dr. Aslan for the nice presentation. Actually, presentation for studying the correlation between the architect's work and climate, sites, and light. So now, thank you very much.
Thank you.
So we'll proceed to our next paper. We are lucky to have Dr. Miriam Iramfar for the second time in this session with another paper. So we'll start the second paper entitled The Synthesis of Ethics and Aesthetics in Modern Movement of Architecture. The paper will be presented by Dr. Miriam Iramfar and Dr. Horaksh Ahmadinia. Sorry
Dr. Yasser, Dr. Horaksh.
The names.
Sorry, Dr. Horaksh Ahmadinia.
We'll start the second presentation.
Hello, everybody. My name is Mariam Iranfar. My paper title is The Synthesis of Ethics and Aesthetic in... Hello, everybody. My name is Mariam Iranfar. My paper title is The Synthesis of Ethics and Aesthetic in Modern Movement of Architecture Through Theory as an Assessment Tool. Significance of the study. The modern movement of architecture represents a dramatic movement in the building design to create a different, functional, and new architecture. There are debates about the beauty, aesthetic, and functionality ethics in the architecture of early modern movement, which is the concern of this paper. Problems of the study. Architecture has entered the 20th century with an inner conflict between its aesthetic, which claims full independence, and amoral, involved in a social purpose. There is a debate about the priority of beauty, like aesthetic and functionality ethics in this architectural style, and leads to ambiguity in evaluating ethics and aesthetic. This study hypothesizes that there is a significant relationship between ethical and aesthetical values through the functionality of modern architecture. There is two questions. Is there any credible tool to assess both ethics and aesthetic in architecture? And to what extent ethics and aesthetics have presented in modern architecture? The aim of this paper is to reach an understanding of the relationship between ethics and aesthetic in modern architecture. The three main objectives is to understanding the main characteristic of modern architecture is an important issue. Having a critical understanding and identification of the two main concepts, ethics and aesthetic, and how could they interact with each other is an important issue too. The theory of truth has been investigated to be applied as a tool to evaluate the two main concepts of ethic and aesthetic in architecture. This is the figure that shows the interaction between these three objectives. The scope of the study tries to propose a conceptual model to be applied in future studies on different case studies. This is through assessment tools to evaluate the presence of ethics and aesthetic in modern architectural style. Review of the literature. The first one is ethics. What means ethics? The term moral or ethics refers to the ensemble of the rules governing human actions and values and which function as the norm is in society. Ethics as a branch of philosophy has been firmly ensured since Aristotle. The main goal of ethics is to put the human at the priority of care and seek his greatest good. What means aesthetic? The term aesthetic is a Greek word. Means the things perceptible to the sense, or anything could have an aesthetic effect simply when being sensed or perceived. It can be defined as the study of beauty and taste. To understand aesthetic, it is necessary to define the concept of beauty. The word beauty means the things that are giving pleasure to the sense, to the imagination, or to the understanding. Plato said that the beauty incorporates proportion, harmony, and unity among their parts. Also said beauty is the eye of the beholder. Socrates clarified that the aesthetic attitude was a derivative of the practical, useful value of an object. Aesthetic values related to human perceptions and experience and environmental surrounding them. Theory of truth. Truth is characteristic of being in accordance with reality or fact. There is 4 factors for the truth: congruence, consistency, coherence, usefulness. The four factors can be guidelines, indicator to evaluate the presence of truth in any issue. Theory of truth has four factors. Now we can understand what means the meaning of each one. A true theory is congruent with the observation which is reflecting reality. About the congruence. Consistency characterizes a true theory. It contains no contradictions and fits together elegantly. Coherence. A true theory is coherent with other things else believed to be true. Usefulness. A true theory is functional and useful, and the actions are successful when it is acting on the basis of a true theory or explanation. The relation between ethics and aesthetic in architecture. John Ruskin has a crucial step in coalition of ethics and aesthetics. The quasi-identity of these two essential values to a third, which is truth, according to medieval thinkers, constitutes the third member in a set of three transcendental concepts reinforced the link between what is beautiful and what is good. The characteristic of any modern architecture. There is 5 points that characterize the modern architecture according to Mongatta. The supports, pillars, the free facade because of the structural support pillars, rectangular and ribbon opening in the facade, the ability to freely design for the walls, the roof garden. Methodology. The study tries to assess both ethics and aesthetic in modern architecture through the validity of truth factors. As we see, aesthetic, ethic, truth, there is 4 factors for the truth and how they are interacting together to have modern architecture characteristics. Therefore, the descriptive analytical methodology has been approached in this study through reviewing the knowledge. The correlation between truth theory and early modern architecture. The figure shows the type of connection among the factors of truth and the features of modern architecture style. According to the analysis of the relation among the elements of modern architecture and truth factors. This is the truth factors, and this is the modern architectural characteristics, horizontal windows, the supports, the roof gardens, and the free wall designs, how they are interacting together with each factor of the truth. Empirical method to apply to the model. The main aim of the proposed model is to evaluate ethics and aesthetic in modern architecture depend on truth as a tool. There is 3 factors: input, analytical, and result. Here in this figure, we see the first stage, input, the characteristic of the modernist architecture in the selected case study. The second stage, analytical, the correlations of the previous stage with the 4 factors of truth based on the statistical approaches. The third stage, output, the weight of each factor of the truth and collect the outcome to be evaluated by percentage, which considers the presence of ethics and aesthetic in the selected case study. Conclusion. The tool of assessment for ethics and aesthetic in the modern movement of architecture that was used in this paper, according to the knowledge review, was the theory of truth. Strong relations among the factors of truth and features of modern architecture have been found. The study has revealed that there is a multi-level of relations among the factors of truth as a tool for the ethic and aesthetic and modern architecture characteristics. The most correlated factor of truth was usefulness, which demonstrates the interaction with all the features of the modern movement of architecture. This is because of the core philosophical characteristic of functionality in the modern architectural movement. Congruence as the second intercorrelated factor of the theory of truth has shown a very good correlation with the features of modern architecture. The reason goes back to the international and standard character of the modern movement in architecture, which demonstrates similarity in the principles of the design, regardless of the location, climate, culture, and etc. In the same context, the consistency and coherence also have demonstrated good correlation. The model also provides useful insight for a comprehensive understanding of the aesthetic and ethical assessment in modern architecture and helps reduce the rigid controversy in this area. This is the complete evaluation model of ethics and aesthetic in the modern movement of architecture through the truth tool, including all the assessment factors and features. The aesthetic ethics theory of truth with the 4 factors of truth, how they are interacting with the modern architecture characteristic, and finally modern movement architecture final evaluation. Thank you.
Thank you very much, Dr. Miriam. Actually, a very nice presentation. A very nice presentation studying a review for ethics and aesthetics in modern architecture, studying the role of truth and its factors between ethics and aesthetics in modern architecture. So, thank you very much, Dr. Miriam. And now we proceed for the last presentation in this session. The last presentation will be, yes. So the last presentation is mobility practice. What solutions to ensure the safety of the surroundings of schools? A case study in Tariq Ibn Ziyad School, Guelma. The paper will be presented by PhD candidate Miriam Lamari and Dr. Yusuf Lazri. So we'll start now with the final presentation in this session, and we'll have quite enough time for discussions and questions and answers after this session immediately.
Hello, I hope everyone is doing well. So let me introduce myself. I am Lamari Mariam, doctoral student in sustainable architecture. Hello, I hope everyone is doing well. So let me introduce myself. I am Lamari Mariam, doctoral student in sustainable architecture and urban project at the University of Guelma in Algeria, affiliated to the Laboratory of Civil and Hydraulic Engineering and supervised by Dr. Lazri Yusuf. Today, I am going to talk to you about a very important subject that affects school population, which is the core of society. The subject is mobility practice. What solution to ensure safety of the surrounding of schools? Case study, Tariq Ibn Ziyad School in Guelma City. This work is organized according to IMRAD model, which includes 3 sections: introduction and problematic, scientific methodology, results, and discussion. What to say at first? There are strong expectations that road safety should be taken into account around schools and on the home school journey. In Algeria, many schools have road access and bring together various road users, pedestrians, cyclists, public transport, and motorists. In the current context, motorized traffic continues to increase. As a result, the urban environment has become a source of insecurity for students and parents. This tendency leads us into a vicious circle from which it becomes more and more difficult to escape. We can consider the home school journey of primary school pupils as a special experience, as a specific space-time that engages individuals in a special practice, which consists of distance, places, limitations, and crossing. It is therefore an experience that mobilizes many spatial skills. In the field of planning and urbanism, child place in the city is often associated with school mobility, mainly from the point of view of safety. Given this logic of child mobility and mobility practices, the question that arises is how to ensure safety around schools. We can consider the homeschool journey of primary school pupils as a special experience, as a specific space-time that engages individual in a special practice, which consists of distance, places, limitations, and crossing. Our study was conducted in the city of Gelma, located in northeastern Algeria. The study focused on the school of Taq ibn Ziyad because of its important geographical location near the main traffic arteries of Gelma city. It is therefore space of enormous potential conflicts between vehicle and vehicle pedestrians, and therefore presents itself as a privileged accident-prone place. On the pictures, we see pupils facing dangerous situations. The objectives of this work are multiple. It's a step whose role is to inform and educate public actors, all bodies, to the various problems posed by increased traffic to the school chosen in Gelma. Then, to strengthen the mitigation measure by implementing specific programs to improve road safety, and this in order to increase sense of improvement of road safety and protection of pedestrians in general and pupils in particular. In order to properly address the issue, the survey diagnosis must be conducted around school and its surrounding to cover topic completely and comprehensively. This information gathering can take the form of a simple data collection based on direct observation, a school survey by questionnaire with the student and their parents, semi-directed interviews with different actors as source of qualitative information. According to synthesis or revised study of new traffic plan of Gelma city and based on the idea that intersection, which is generally assimilated to main bottlenecks of urban network, it's therefore the space of enormous potential conflicts between vehicle and vehicle pedestrians, and it's therefore a privileged accident-prone place. For this reason, special attention was paid to this intersection, which were selected and investigated with technical services of Transport Directorate of Gelma. A few meters from the selected school, we find the intersection Debsuk, which is characterized by a huge motorized flow that exceeds 17,868 vehicles, an unbalanced and unchanneled pedestrian flow on the different branch of intersection instantly generated mixed conflicts. 379 pedestrians crossing the 1st November axis for 928 pedestrians crossing Kibruti Ben Sheikh axis, 37 pedestrians crossing the street of Gehdur Tahar for 693 pedestrians crossing the street leading to Shumanever, anarchic parking inside the intersection, in existence of no parking scenes, in existence of crosswalk, in even side resulting in reduced visibility of access to intersection. Therefore, it's recommended to improve the existing condition to ensure safety of passengers, including children. The aspect of road safety in vicinity of schools requires for all infrastructure in school to be the subject of an expertise in the development of spaces to be preserved to ensure the best possible safety of school population in the immediate vicinity of primary school located in the various respective area of Gelma cities. Primary schools in Gelma represent 69% of schools with a total of 58,430 pupils who often travel to and from school on short and long distances that are unfortunately still not sufficiently safe. In 2019, local authorities have launched a vast program to rehabilitate a total of 250 primary schools in Gelma region. These renovation actions include imported and varied works according to the need of each school, which will improve condition of schooling for pupils. Unfortunately, the rehabilitation only covered the interior and exterior architectural aspect. In this regard, the exterior installation guaranteeing safety of school population were not taken into account. As a result, schools built in the city of Gelma in general and Tariq Ibn Ziyad schools in particular are characterized by huge deficiency in terms of security installation, particularly at peak hours. To the testimony of the school director who plays the role of managing the school and educational activities, and at the same time he was a member of an association in collaboration with parents of people to improve problems faced daily by their children. The association's activity has ceased on 2011 because the majority of parents are not aware enough to be involved in collaborative activities, and they do not know their assigned missions. It means the problem experienced daily by them and their children, which cause conflicts between members of association. These associations used filed beyond its scope. In summary, there is difficulty of answering collaborative solutions in an environment that is not sufficiently trained and aware to welcome the concept of participation as actor. According to an architect's testimony who has participated in many tenders in field of educational institutions, he mentioned that there is not a school construction guide in Algeria, and the function of architect is framed by a predetermined schedule of conditions, which makes no margin for creativity and freedom. It means there are very limited choices. Jury members are not specialists in architecture and urbanism field. They do not take into consideration safety of users and their comfort. The user is only a receiver. Reviewers require an exclusive entrance on the main facade where traffic cannot be marginalized. As a result, urban environment has become a source of insecurity for the majority of pupils and their parents. We conducted a questionnaire survey at the Tariq Ibn Ziyad school during 1 week with pupils and their parents on mobility practices around the school. More specifically, we wanted to have a view on the problems experienced by school population. Our objective is to select the deficiencies in terms of outdoor design in order to improve and guarantee safety of users and our children in particular. The sample consists of 137 respondents. It means 54.8% of students and parents. The questionnaire is provided with schematic illustration to easily convey the idea to the pupil's mind. On this diapositive, we see many results of questionnaire survey. The majority of pupils live near the urban primary school because it is located in heart of residential areas. Parents live with anxiety because of the insecurity of their children. As a result, 86% of these parents always accompany their children on their way to school. This affects both urban mobility and child mobility. 40.8% of parents participate to the densification of motorized mobility. The series of problems is linked to form a vicious circle from which it is difficult to escape. The primary school concerned by this study is located on the main arteries of Gelma city. The Bebsouk crossroad characterized by a very dense traffic that cannot be marginalized. This makes the school population face the danger. According to the observation in city, the majority of urban transport buses and university transport cross the school. This problem constitutes the point which makes parents leave the anxiety and gives rise to other problems. The main reason that prevent parents from allowing their children to go to school alone is there is road insecurity, with 71.5% of parents mentioning this reason before other reasons, like age of child or distance school home or social insecurity. 86.1% of students are accompanied by a family member, which confirms that there is no cooperation between families to limit children's mobility to school. Despite the fact that the school population lives close to their school, 31.3%, only 5 minutes away, 86.1% of the pupils are accompanied by a family member. This confirms that there is a feeling of insecurity in the vicinity of the school. Concerning deficiency around school among parents with vehicle, 60% of respondents felt that they had difficulties accompanying their children to school by car. 57.6% confirmed that there is no parking. 68.6% have difficulties related to the exciting flow around the school. 78.8% indicate that there is no enough space near the school for parking. 78.8% of parents surveyed indicated that one of hazards around the school is bus density. 3 bus stops right near to the school. There is a great deficiency in terms of exterior landscaping that guarantees safety of our school population. 40.1% report that there is a lack of road signs. 45.9% indicate that there is only almost invisible crosswalk, sidewalk, parking entrance. So this modest work focuses primarily on situation in the vicinity of primary school. This problem also affects middle school and high schools. A situation of particular concern that requires to follow a detailed guide for the construction of educational equipment, to work in partnership with all the parties concerned to provide sustainable solutions to this recurring problem. All stakeholders must act as a central pivot in this collaborative process, as they are in a better position to know safety needs of school children. As a key player in the development of the local transportation plan, he may be called upon to conduct consultation to identify all issues or concerns related to the safety of students in an active transportation context. Because of his or her position, school director is the best able to respond and raise awareness of this issue at various levels of governance. And thanks for your attention.
Thank you very much, Dr. Miriam. Thank you very much for your presentation. Actually, the topic of safety is one of the very important topics. Just a moment, I would like to stop this.
We were just getting so swamped. We couldn't see a word.
Okay, so thank you very much for your presentation, Dr. Miriam. Very important topic. Always the topics related to safety are very important topics, especially when you are talking about schools. So it's very, very important to discuss these issues and to study academically how to handle these problems. So now we are having time for the roundtable, for the fifth roundtable for today. And now we still have time for questions and answers. So I would like to welcome all your questions. So I think, so I have a question from Dr. Riham Nadi.
Hello, everyone. Do you hear me?
Dr. Riham?
Hello, everyone. Do you hear me?
Yes, I can hear you now.
Okay. Well, I have a question for the second paper by Dr. Miriam.
Yes.
I would like to congratulate her for her very nice paper and very nice topic too. But I had a question, which is there any application or any example that achieved her final matrix? And I expected that at the end of the paper, I would see an example for a modern architecture that achieved all the characteristics that she talked about in the paper. I don't know if she have searched for something like this or not. Thank you.
Thank you, Dr. Riham. So, Dr. Miriam, would you like to elaborate on that? So, Dr. Miriam sent me a message that he has connection problems and related to a weak connection. So, could you please send Dr. Riham your answer, if even in text, if you would like? You can text her or send her your answer if you don't have a proper connection for the time being. Okay. So, any other questions? Dr. Miriam Yanfar, she asked to, if Dr. Riham, would you please write her your question in text?
Dr. Yasser, my connection is
Yes.
good now. Can I have only repeat the question, please?
So, Dr. Riham, would you kindly repeat your question again to Dr. Miriam?
Okay. I was asking about if you have searched for an example or an application that achieved the final matrix of the characteristics of modern architecture and how to apply all the points of coherence and so and so and so, or this is you conducted or concluded this matrix and then it will be in another research that you can apply these points. Thank you.
Yes, doctor, exactly. It is, I did this limitation for my study. The sample will be for future studies. It is the complete full methodology paper.
Mm-hmm.
Did you hear me?
Yes, I hear you. I think if you have an application or an example, it will be a very nice topic and to the point, because it is very organized and you have a very good literature review. So I think if there is an application, it will strengthen this topic. Thank you so much.
Thank you, Dr. Riham.
Thank you so much, Doctor. Yes, it will be for the future studies in the plan to apply the modern characteristic applied in the future study.
Okay, thank you.
Okay, welcome.
So Dr. Miria is having an extension for her paper for the future study.
Yes, another study. It will be.
Forward for this extension. Okay, so having another question from Dr. Salah.
Yes, Dr. Yasser, do you hear me?
Yes, I can hear you very well.
Yes, I have a question for Dr. Mariam Iranfar. I want to ask if this model that she presented, it's possible to be applied to another type of or another styles of architecture. I mean, if we use the methodology that she offered us, based on the theory of truth, can we apply this on other type of other styles or of architecture?
Dr. Salar, yes, this is the methodology can be following with another parameters, but there is some changes for sure. This paper has the characteristic of modern architecture. So in another paper, we can have the characteristic in another style if we choose in our methodology. Means this is only focusing in the modern architecture characteristic. Is it enough?
Doctor. Thank you.
Welcome.
Thank you. Thank you very much. Thank you.
Thank you.
Thank you.
So thank you, Dr. Salar and Dr. Maria. Any other questions, please? Anyone else would like to have to discuss any, is having any question or any comments for the previous papers? Okay. Okay. Well, I would like to thank you all. Thank you very much for the very interesting presentation. Actually, this session was very rich of very important papers and very diverse papers. This session entitled Environmental Studies brought together presentations at different levels and scopes, including landscape perspectives, building height ratio, Mediterranean climate, and many other interesting topics. Also, in the second half of this session, we had many topics related to modern architecture, architects' work analysis, and modern architecture and safety issues. Actually, we had great diversity of topics and fields related to this session. So would like to thank you all. I was really happy to be a part of this session. And thank you very much for your rich contribution in your research and your presentations. Actually, it was very rich and enriched this session. We'll be continuing the second session in this today will be about building sustainability. So we are continuing on the environmental theme, and we're having a complete new session about building sustainability, and we will continue with Dr. Haider Ali. So if you are interested in this topic, just stay connected, and thank you again for your presentation.
Thank you, Dr. Yasser. If Dr. Haider is there, he can take the platform and he can start if he is available.
So, Dr. Haider.
Okay, yes.
Dr. Haider.
I'm available here.
Yes.
Thank you very much. You can
yes.
take the floor and manage based on the availability of the authors. Thank you very much.
Okay, so shall we start right now?
Yes, you can start, but let us first to check if the authors are available for the first round and second round. For the first round, the first three papers, if they are available. First is yours, I think.
Yeah, first is my keynote speech. So it will be after that there will be another two papers. I think the paper is Muhammad Ariful Furqan. Is available here.
Muhammad Ariful
Furqan.
Ariful is ready, sir. I am co-author with this paper. Maybe he want to go toilet a little bit. Thank you.
Okay. Borju, what about Dr. Borju?
Yes, we are here.
Okay, so good. Okay.
Yes, okay, Doctor, you can start, then we can catch up with others.
Okay, so very beginning again, welcome to all today and good afternoon to everybody to today's international very prestigious forum. And due to the pandemic, we are very much restricted to our house, so we are meeting virtually. So this is very nice to meet you all virtually. So this session actually architecture and technology, that means building sustainability. So the previous session we already observed many very good interesting topics regarding sustainability already presented in this session, and also this session we have very good papers, and I would like to first thank all the authors and co-authors and even the participants from across the globe to attending this international forum. Actually, our beautiful planet, we are facing a very devastating threats due to global warming, and due to global warming, climate change is a very natural phenomena we are observing now. Especially some countries are very much under risk. One of the most vulnerable countries like Bangladesh. So global warming, that is the climate change issue, is not now a prediction no more. It is actually the reality. So many adverse effects of climate change, including variability and extreme, are already visible. And we already know that the Intergovernmental Panel of Climate Change estimates if the present trends of this global issue, that is climate greenhouse gas emissions, continues, our world would be 3.3 degrees Celsius warmer at the end of this century. So this is a very alarming situation right now. And even Bangladesh, I am talking about some critical consequence of Bangladesh as well. Bangladesh is the most vulnerable country all over the globe. And it is estimated that climate change could affect more than 70 million people in Bangladesh due to its geographical location, low elevation, high population density, poor infrastructure, high level of poverty, and high dependency on natural resources. Especially our coastal area, like the southwestern region, including Khulna city and the Khulna division, and the very close the mangrove forest, the world very largest mangrove forest, Sundarban in Bangladesh, are very much risky and prone for the climate change threat. So under this basis, actually, we are very much conscious about gaining the sustainability, especially for the building construction, so that the global warming can be reduced significantly and the climate change can be reduced, maximize our future generation for a sustainable life and achieving the sustainable goal by 2030. So what is actually the sustainability and the sustainable building? We actually call this sustainability building or sustainable building is like the green building plan. The green building actually can maintain the quality of life and harmonize within the local climate, the environmental, conserve the energy resource and recycling the materials, reduce the amount of hazardous substances to which the human and other organisms may be exposed, especially reducing the building impacts on human health and the environment during the building's life cycle through a better setting, design, construction, operation, and maintenance. So sustainability can be achieved in different ways. Like now, our urban planner, our architect should come forward for the sustainable design of our buildings, especially for the new buildings and the old buildings for the renovation, remodeling the existing buildings. So this is a very important to fight, to combat the threats of climate change for our next generation. So all the things, I will discuss a mathematical model, because I already discussed that I am a mathematician, but I work a diversified application in mathematical modeling, in ecology management, climate change, and our, due to the climate change, there is a lot of emerging infectious disease. So all the issues, actually, I work and my research team work on that issues in for the global scale. So I think this would be a little bit a different flavor, because the topics will be mostly mathematical perspective, but is the application in real situation, how mathematics can be applied to describe this, the changing phenomena, and to interconnected our building construction, our natural climate change issues, and even our human community. So how can we connect it together using differential equation in terms of the time, over the time. So just now I am going to play my keynote speech first, and then sequentially I would like to call the authors to present or to play the video here. So now, just now I am going to share my video, and I think, thank you everybody for listening and joining us. Then we will share the question and answer session. So thank you. And are you seeing the video? I am audible?
Yes.
Okay.
Doctor, there is no voice in the video. I cannot hear anything.
Oh, the voice is not there?
No. I think you have to do it in 100. The sound should be in 100%.
The sound actually it is put in 100.
But we cannot hear the voice.
You cannot hear again?
No, we cannot hear.
So
Dr. Salar, I think, has the problem in internet, so he is not here. If you want, I will try to share the.
Okay. You can share that one, please.
Okay. Can you please just unshare? I will share it.
Okay. So I will stop sharing.
Yes. I will share to see if there is.
Yeah. Sure. Please share.
Okay. Can you hear the voice when I share?
No. The voice is not.
The voice is not there?
No. The voice is not. Sound is not clear.
I am also making 100 now.
No sound, no sound.
No sound again?
No.
I think I shared also, there is no voice again in the...
Yeah, there is no voice again in the same problem. So shall I try again?
Yes, please, if you try it again to see if there is voice.
Dr. Haider, the voice of your YouTube, maybe it is low. So please check out this also. Thank you.
No, my YouTube voice is very loud here. I am. Did you hear?
Still, the voice is very low. In the YouTube, the voice is full.
Yeah, the voice is 100 here also.
Yes.
So do you understand? Do you hear this one?
It is possible you represent online, means not through the YouTube, with the PowerPoint, if you can present it.
Yeah, it is possible. So shall I do that right now? Or
yes, if you can present it through your PowerPoint, share your PowerPoint and online present it, because there is no any voice in YouTube when we share.
So is it visible right now?
Yes, it is visible.
Okay. Can you see the full screen right now?
Yes, doctor, we can see the full screen right now.
Okay, so thank you everybody, and sorry for the interruption about the video. I don't know if the video is clear from here, but I don't know why the sound is
Dear
not there.
Professor, it is ready. Sorry, I have just realized. I apologize. If you let me, I will share your video from here.
Okay, yeah, please do that.
I'm really sorry that I have just realized.
Okay, so I can stop here. So, okay, sure.
Of course, thank you. Dear Professor, yes, we have the link. Copy the link, and I'm sharing. If you stop this your screen.
Yeah, I already stopped.
So I'm going to
I already stopped.
Perfect.
Welcome to all participants attending from different parts of the world. Hope you all are safe and well during this critical time of this global pandemic. It's my pleasure to express my deepest gratitude to the chair of this conference, Professor Aisha Mia, for inviting me to this prestigious event. I am Professor Haidar Ali Vishwas from Khulna University, Bangladesh. I am a mathematician, but my research topics includes dynamic optimization techniques applied to biological models. Particularly, I work on diverse applications of mathematical modeling in ecology, environment and climate science, and again, emerging infectious disease. Hope this conference will bring and open a unique forum and opportunity to work together and make a connection, international networking for collaborative research on the global issues. So thank you everybody and thank you to all. Okay, thank you everybody. Welcome to my presentation. The topic of my talk is the mental model applied to green building process for sustainable cities under climate change. The basic outline of my talk is motivation, global warming and climate change, some brief history on the green building concept, and then we formulate a mathematical model for green building, and finally concluding remarks. Motivation. Harmful effect of global warming and climate change is no longer a prediction, it's just a reality now. The developed countries are the main responsible for this global warming, but the main victims are the middle and low income countries like Bangladesh. By 2050, with a projection of 50 centimeter rising in the sea level, and Bangladesh may lose approximately 11% of its land, affecting an estimated 50 million people living in the local coastal region. Almost 80% of the total area is prone to flooding. So this is the very basic information about the effect of global warming and climate change effect in Bangladesh. The global warming, actually, what is the fact behind that? Global warming is the unusual rapid increase of Earth's average temperature. It happens due to the excess greenhouse gases in the atmosphere, and it results in rising Earth's air and ocean temperature for heavy heat waves, rising sea level or the melting snow, disappearing glaciers, disruption of habitats, and outbreaks of several emerging invasive infectious disease. The last official initiative of climate affairs, it was conducted by United Nations, which is called Paris Agreement, where it is seen that the total amount of the emission of carbon dioxide, including all greenhouse gases, and the biggest responsible for this on the United States, then second on China, and sequentially EU, and Russia, India, Japan, Brazil, and Germany. So this is the country, different countries trying to reduce this emission at least half of their emission each year. And very recently, it is more alarming that in In 2019, China emitted 27% of the global total carbon dioxide, that is greenhouse gas emission. And even in 2020, China is again the most highest emitter of these greenhouse gases. So all this indicates that this huge amount of greenhouse gases increases our temperature, global temperature, every year. So this is the day by day decades average temperature rising rapidly. You can see from 1950 to 2020, the temperature is rising very surprisingly, and it results in the global warming and even the climate change. So what is the step should be taken now? According to the Paris Agreement, almost 197 countries signed to keep global warming below 2 degrees Celsius, and if possible even 1.5 degrees Celsius. So now it is a challenge to meet the sustainable development goal by 2030. Since cities are the most greenhouse gas emitter, so to reduce these emissions, it is crucial to take a smart city plan. By a smart city, it means the less carbon emitter city with maximum green infrastructure. And it is predicted that cities could get 44 degrees Celsius more hotter by the end of this century. So this is the best and even the important technological way to build this green building concept, green building idea for sustainable cities for our future generation. And we know that in sustainable development goals, there are 17 goals. But one goal is related to these sustainable cities and communities, like the goal number 11. It is only alone about sustainable cities and communities. And these sustainable cities and communities include a lot of targets fulfilling by 2030. And towards meeting this sustainable goal, green building is our main idea to construct and renovate all the buildings in the urban areas. So what is the green building? Green building actually can reduce water and energy consumption, use eco-friendly building to minimize greenhouse gases, finish the renewable mitigation, and reduce indoor and outdoor heat waves, promote solar energy, and develop the environment with trees and roof gardening. So there is a best warriors against climate change in different ways. Firstly, performing energy efficiency, and secondly, promoting green communities. Here is the symbol, here is the example in green building and non-green building concept. You can see the difference between green building and the non-green building concept. And what is the advantage of green building? A non-green building is responsible to consume 35 to 40% of total energy. But green building actually reduce this 30 to 40% energy. For 1/3 of the greenhouse gas.
The sound again though not audible, right?
Yes.
It is not audible now.
So Professor Nia. I don't know the problem. I think from the uploading the video I got. From here it is clear. So what should we do?
Professor, maybe you can go on the presentation.
Okay, so
Lively.
yeah, I could go, but I don't know, Professor Raksha.
I think because this is sharing through the house, the voice again come back. There is there is audio now.
Okay. So I'm sorry, I don't know what is the problem.
But again, there is no voice.
They redesign the new buildings for the sustainable city. So we consider here 4 state variables, considering 4 components in different states. Actually, the first one is the green building. So we need to maximize our green buildings in the urban area or the sustainable city. For the sustainable cities, we look, the main idea is to reduce the greenhouse gases. And then our human community should get benefit from this green building. And also, green building can produce several energetic ingredients. So we consider here 4 components in terms of differential equation we formulate with nonlinear mathematical modeling. And our idea is number of green buildings to denote is G, amount of greenhouse gas emission is C, ingredients is like I, and the human communities of a certain area is A. There are several other parameters and some growth rate for constructing this type of model in this study. So here, considering all these above things, our basic assumption actually to describe the probable change in the greenhouse emission rate after observing by the green buildings. That discuss the impact of the green buildings on greenhouse absorption of our human community and establish the green buildings against greenhouse gas emission reduction. So all the things will be analytically proved and then it will be verified numerically to show the effectiveness of this green building idea. All these variables can be reconstructed in terms of differential equation like these 4 differential equations, number 1, 2, 3, and 4. You can see this is actually the time derivative. With respect to time, over the time, we can make a dynamic equation. This is a very simple differential equation. And it is very uniquely described how mathematics can play a role to describe our everyday dynamical problem in our real life. So this mathematical problem should be verified analytically because every equation should have a unique solution and solution should be exist and it should be unique. So this is called the existence and uniqueness. And this is actually the well-posedness of the model. So all the well-posedness have been verified using positivity test, equilibrium points analysis, and stability analysis by analytically. Then analytical results have been verified using the numerical simulation. And the simulation parameters have been actually taken from the recent updated data from different organizations. Even the World Economic Forum, we can take the data and make this parameter calculated for the numerical simulation. Now here you can see the numerical simulation of the proposed model is very clear from the figure that if we take in together all the components together, you can see by absorbing greenhouse gases, the green building produce amount of energetic ingredients. That is, green building is increasing, and also the emission, the greenhouse gas is increasing, and the growth rate of the ingredients, it is actually decreasing. And our human community is increasing because human community is taking benefit from this greenhouse, green building idea, renovation of the green building idea. Now, from this figure, it will be more clear how it affects in reducing the greenhouse gases or reducing the global temperature from the green buildings. You can see from the simulation and in figure A that greenhouse gases absorption by green building, when green building absorbs less greenhouse gases, then green building rate is very low and greenhouse gases is very high, and it is vice versa. Because when the absorption rate is higher or green building is higher, because it depends on the green building. When green building is renovated, much more green building all in the city area, then it will absorb much greenhouse gases, and then greenhouse gases emission will be reduced. So this is the fundamental idea. And another figure here you can see, if the green building absorbs low greenhouse gases, it generally produces less ingredients. And in the similar way, it shows that human community, if the human community increases, then the green building gives more ingredient to the human community by absorbing more greenhouse gases. So this is very important, and it is shown that if we can increase the green building all in the city or the sustainable cities, our greenhouse gases can be reduced significantly, and which can reduce the global warming for the sustainable development goals and for the sustainable cities for our human communities. So our findings tell that mathematical model is actually very interesting fundamental tool to describe the time-varying dynamical behavior of our real system. So this model suggests that human activities, especially building technology, is responsible for increasing greenhouse gas emissions. As a result, the Earth's climate as well as atmospheric temperature are rapidly changed. The amount of greenhouse gas is proportionally decreases with the increase of green building. The production of ingredients and absorption of greenhouse proportionally depends on the number of green buildings. So green buildings can enhance the ingredients and human communities by absorbing more greenhouse gases, and it will help for the sustainable development of our cities, and it will save our future life for our future generations. So this is the basic summary of our talk. Thank you, everybody. Thank you for your patience, and thank you, organizer, for giving an opportunity to share my research with these fundamental and the renowned scientists among global participants. Yeah.
Thank you very much, dear Professor Dr. Haider, and sorry for interruption. You may continue, and I'm going to.
Okay, thank you, Professor. I think we may have some several questions, but we can discuss the questions in our roundtable session.
Yes.
So I would like to call our next speaker, our next presentation, the graph database modeling on Malay architecture IFC data. Here, Muhammad Ariful Furqan or Gun Faisal. So I would like to play the video. I think the video is here, is okay. I don't know, it will be played clearly. I am playing the video and then see what happens there. So. The sound is clear?
Dr. Haydar, again, there is an audio problem, I think.
Again, the problem same.
Again, the same. There is no.
I think the problem by the time that you are playing the video, please don't mute yourself because it is connected to your microphone.
No, but I don't mute myself.
So in that case,
Dr. Horakh, can you play it from your side? Maybe it is better.
So please,
of course,
Dr. Horakh, please could you please open the video from there?
Of course, I'm doing now.
Okay, then it will be better.
Yes, Dr. Haydar, can you stop playing?
Yeah, I already stopped this playing.
Perfect, thank you. Let me find the file.
Alongside with Mr. Gun Faisal and Mrs. Tina Fadila Najwa from Indonesia. I would like to present our research paper about graph database modeling on Malay architecture IFC data for ICC AUA 2021. In this paper, we mainly discuss about the Malay Indonesian architecture. Indonesia is a country in the Southeast Asia, which is the fourth most populous country in the world. And one of the population is Malay Indonesians. They are ethnic Malays living throughout Indonesia. They are considered one of the indigenous people of the country. And the Malay Indonesian society mainly live in Sumatra Island. This is Indonesian map, and Sumatra Island is this part, and a small part of Borneo or Kalimantan Island, like that. And its society has a unique Malay architecture, and one of the example is Datuk Jolanco Malay Trap Pagodangan House and Rokan Forkoto Malay House. This is the example of Malay architecture. There are many others Malay architecture, but the example is Datuk Jolanco and Rokan Forkoto Malay House, like that. And based our previous study, the decreasing of Malay house existence, which part of Malay architecture, indicates that the artifacts of Malay culture were diminishing. The assessment of technology and new materials resulted in the erasure of Malay architecture as part of the culture. The effort to preserve Malay architecture was carried out by documenting which in general can be used as learning material for the next generation. And this effort will be better if it is supported by a good information technology. Talk about good information technology, the example is graph database. So what is graph database? Graph database is a latest database technology which used by most companies in the world, like Facebook, WhatsApp, and many others. And a graph database itself is closely related to data interconnection, and which has many data relations. So there are relationships between data to another data, like that. And it's very useful for representing and describing the relationship between building components and the data in the building information modeling, or BIM. The graph database schema can be useful for building semantic information, for extracting, analyzing, and displaying topological relationships in the form of 3D objects and process the queries very quickly. This is a benefit of graph database modeling. And therefore, we conduct a research paper. The purpose is to model graph database on Malay architecture IFC data. The modeling process was conducted by extracting IFC data to create a graph model using Neo4j. And the expected result of this research is a graph database modeling, which will be developed further by defining the queries to solve various problems of Malay architectural models. And this is our method to conduct our research. First, we design a host model from BIM and generate the EFC data from BIM. And next is parse the EFC data into GSON format. And next is IFC metadata modeling. And the last is IFC graph modeling. This is our method for conducting our research. And this is the design of Malay Rokan for photo host. We use Google SketchUp Pro 2015 to design Malay Rokan for photo host. This is the original photograph of Rokan for photo Malay host. And this is our design of Rokan for photo host. This is the view from front side, and this is the view from side and rear view, like that. And based on host modeling, then we export the data into the IFC data format. And IFC itself is a file format that has been standardized with ISO 1030321 as a digital description of a built and environment, including buildings and civil infrastructure. And this is the content of the IFC file, which is has a script in that file. So there are some information about our design model based on the Google SketchUp, like that. So this is the IFC data code or script, like that. And after we get the IFC data, we pass it into JSON format. And after we pass it, then we model it into a graph database. First, we model the metadata and then model the graph database or graph model itself. And this is the result of the graph model. So there are three fundamental entities in the graph database. First is the objects or a node. This is the object or a node, Rokan for photo IFC. And this is the properties. And last is this is the relations, and last is the properties, like that. So this is our graph model of Rokan for photo IFC. IFC is a standard file format that defines the building object model. Some relationships can be described in a structured manner between components at IFC. The IFC data schema has three fundamental entities, namely object, relations, and properties. However, the IFC data cannot be implemented directly into the graph database modeling. So it is necessary to parse the EFC file into JSON format, since it is simple and easy to understand. The IFC metadata graph model is used to create and examine the relationship between IFC entities and validate the IFC model. And the final step is graph modeling, was converting the IFC model into an IFC object graph. So like that. This is the our model. And the use of graph database modeling helps the building preservation process. Graph database modeling creates more accurate information both in terms of the form and space of the building, as well as the location of the building and other supporting data. The data knowledge can be passed down from generation to generation without worrying about losing them. Apart from being a conservation effort, this data can also be used as other reference material. And hopefully the use of graph database will have a positive impact in effort to preserve building, especially Malay architecture. And this is our conclusion for our research paper. And our future work, the future research opportunity is the validation of this graph database model so that the knowledge extracted is truly valid. And a query testing can also be done to obtain accurate knowledge from a graph database. And last, make comparison of different IFC models so that the new knowledge insight can be obtained. So this is our presentation about our research paper. Thank you for attention. And this is my contact. This is my phone and email. Thank you.
Thank you, Ariful. Thank you for your nice presentation. I think it's a very interesting topics, especially for
several times.
Hello, Raksha.
Yes, dear Dr. Haider, sorry. It's YouTube again.
Okay, so thank you for these very good and interesting topics. Actually, the topics is very much related for the algorithm development, I think. So there should be some discussion. I think we could discuss in our roundtable discussion. So next, I would like to ask our next presenter, our labor productivity on construction sites, a case study of biological wastewater treatment plant construction. So Dr. Bursuba Okten or some other co-authors, I think Professor Ahmed Nia, could you please?
Hello, I am Anwar Aksot. This study has been prepared for my master thesis, Labor Productivity on Construction Sites, a case study of biological wastewater treatment plant construction. Problem: the production efficiency of labor on construction sites is an important factor for the success of projects. Skills, experience, and training are among the critical factors affecting labor productivity on construction sites, especially in construction sites where a new construction technique is used. The team's efficiency is affected by the learning process. Laborers' unfamiliarity with the new technique causes time delays and accordingly cost overruns. Research methodology. This research examines laborers' challenges in building and unfamiliar structure at construction sites through a case study. Researchers conducted field work at a wastewater treatment plant construction site in Istanbul, Turkey. One of the researchers working as a controller on behalf of the main contractor in these construction projects. The research data were obtained from the daily reports of the construction site and the observations of the researcher working in the field as a controller. In this research, the relationship between the workers' productivity in the construction of the egg-shaped digestion tower structures produced on the construction site and the learning processes was determined by field observations. Learning processes on construction sites. The nature of the projects in the construction sector made it difficult to transfer the experiences gained in different projects to the field. Learning from mistakes and learning from past experiences issues are essential in improving the process in the construction sector. The studies indicate that there is a gap between the information people need in the files and the information obtained through pieces of training. According to that information, it can be thought that work-based learning is an important learning method for the construction sector. The efficiency of construction projects is directly proportional to experience and skill. Workers must have experience and knowledge of the field in which they will work. Workers who lack experience on the construction site should be teamed up with experienced workers who have expertise. In addition, after a worker learns a production and repeats it repeatedly, the learning curve will increase over time. The time to finish the job will be shortened and the number of manufacturers will increase. Therefore, if workers do the same work with the same team, it will positively affect the workforce productivity. Labor productivity on construction sites. Labor productivity in construction projects can be defined as the amount of work done per person hour. In other words, it refers to the working time of the worker in hours for one unit of production. Labor productivity should not be confused with the concept of worker performance. Worker performance is the ratio of predicted workforce productivity to the resulting workforce productivity. In order to increase labor productivity, factors affecting labor productivity should be determined, and the extent to which these factors can be applied in the construction site environment should be determined. Therefore, the determining factors should be followed and measured throughout the production process. These measurements can also be made by mathematical modeling or various indexing methods. All input and output relationships should be measured and analyzed. With labor productivity measurement, correct and consistent answers to questions such as where the project is and how to reach better levels can be obtained. Casas et al. Found that physical factors as for working at similar activities, design complexity and error tolerance were the three most influential motivators in their research. Case study. İstibalta Limanı Biological Wastewater Treatment Plant Construction. The group started the construction of the İstibalta Limanı Biological Wastewater Treatment Plant on October 2017 to transform the existing pre-treatment plant into a biological wastewater treatment plant with a capacity of 1,296,000 cubic meters per day. The existing wastewater treatment plant will be converted into a biological wastewater treatment plant, and the resulting sludge will be burned in sludge digesters to obtain biogas, and the biogas obtained will be used to some of the electricity of the facility. The wastewater coming from the Castle intersection tunnel minus 11.94 meters and the Gendere tunnel minus 7.70 meters will pass through the pre-treatment units. The units in Its facility, stone separator, push screen, 11 pump unit, line sintering unit, sand and oil holding unit, porphyry screen unit, a process tools, final settling tanks, sludge dispersal units, biogas production and processing units. Built on an area of 270,000 square meters, the facility will treat wastewater from a population of 3 million. Findings: working at similar activities. In the construction of the treatment plant, there are 6 X-shaped reinforced concrete digestion tanks constructed for the first time in Turkey. Reinforced concrete digestion tanks with a height of 42 meters and a diameter of 25.30 meters and a thickness of 45 centimeters are cast in different 15 stages. For each concrete casting, special cutwood field reinforcement is made by the project founder plant. Concrete casting is made with 26 inner and other founder models. Findings: working as similar activities. Labor productivity declines were occurring for workers who did not have such experience before. Since each casting was made using a different formwork model at different angles, the learning curve of the workers did not increase as desired. During the process, workers gain practice in constructing this different form, which they are not used to, and production processes accelerated. In this project, complex structure formwork cause slow learning processes. Such projects need skilled workers. These types of projects need experienced teams. However, the learning time of even experienced teams will take longer in the construction of structures which are not produced continuously compared to the structures that are continually manufactured. Great care should be taken to ensure that the design and composition of the products facilitate the production and accelerate the production flow during the project phase. In addition, the complete communication of the technical personnel with the workers must be correct and complete. Workers should be given adequate training and information. The same workers should be assigned the same tasks so that they gain experience and skills. New inexperienced workers should be employed together with experienced workers to gain experience. Thank you for listening.
Thank you.
Thank you, Anil. Actually, we are now at the stage of a roundtable discussion, but we are.
Good afternoon across the world. I'm absolutely delighted to.
Hello.
Yes, dear Dr. Haidar, you may continue. Sorry, again, the YouTube automatically.
Oh, okay. So we are very short of time now, but yet we have the discussion table, round table now. So I open the floor now. So please ask questions and raise your hands and ask questions. So Dr. Shalar, Professor Shalar, you can conduct the questions.
Yes. Thank you, Dr. Haider. I have one question regarding the Muhammad Ariful presentation regarding the graph data based modeling. I wonder if he can tell us how much it is possible to be this model that he present compatible or adaptable with the simulation programs like Revit, 3D Max, or sophisticated programs like Energy Plus, etc. He mentioned that it is working with Google SketchUp. Am I right?
Yes, we're working with Google SketchUp, Dr. Salar.
Do you have idea how much this can be successful with another types or not?
If we conducted the research, we implement the IFC. So the IFC itself is generated from the BIM modeling like Google SketchUp, Revit 3D, and etc.
Archicad, and etc.
Like that, Mr. Salar.
Okay.
So it's possible to generate the IFC data using another tools. So like that for my answer.
May I can some opinion, sir? I think
Yes,
AFC
sure.
data is the basic language for the transport to the another software. We talk about the software like BIM software, Archicad and Revit for the BIM. It is same data, but to use in the sketch, to use in the Archicad or to use in the Revit, we have some general data. And I'm in Indonesia using Revit, Autodesk Revit, and you using the Archicad. We must do the same the EFC data to can open another software. I think it's used for the IFC data. So another software if the same level of the language like AFC data, graph data, database model, it can use another software. Thank you.
So actually, what about the error tolerance? That is the efficacy of your results. How can you confirm the efficacy of your results or the tolerance? Did you test the tolerance of what is the error estimation, like error estimation from your results?
Yes, sir.
Okay, thank you. So do you have other questions from
Dr. Haider, do you hear me?
Yes, sure. I'm hearing.
If there is no any other question, I have one question for the last presentation.
Okay, so please.
I want to ask the presenter. He mentioned that the work, of course, in a treatment plant project, it's very delicate and sophisticated project and need very good expert people to do the work. I agree with that. But what about if we hybrid or mix the skilled people with the unskilled people in order to train them, and for example with not more or 15% or whatever. Did he think about this process or not? Thank you.
Hi, I would like to answer this question.
Yeah, sure, please.
Anil is he was a controller on this site, and his master thesis about this subject. So in this site, in the very beginning of the construction, the labor on the site, they were skilled labor at the very beginning, but of course they were not skilled on this egg form structures. They were skilled with the this industrial form, but not for the egg structure form. But they had time for learning in the process, but the structure is changed during the construction because of the egg-shaped. And also every time they had to change the angles according to this form. So during this construction, we couldn't see this learning process like the multi-story multi-story buildings, because in the area, the research on this learning processes in the construction, the multi-story buildings, we can see that the skilled labor could learn quickly according to next story of the buildings. But in this shape, because of the shape is changing and also the level of the construction is getting higher, the labor, it was like the learning from the very beginning, not very beginning, but they all in the process, it was very hard for them to go on this process in production. So it was not only the learning, it was because of the structure of this egg-shaped form. We also search for other research in the area. We could only find one research about these egg-shaped form structures from United States. It was also from the 2020, and also they had similar problems in this construction because, you know, in United States, there are much more construction about these forms, but they had also similar problems. But in Turkey, this was the first construction for this form and structure, so it was more difficult for us. I hope it was answer for your question.
Yeah, it is clear for me now. Thank you very much. Thank you.
So thank you for your good answer. And do we have any other questions on the previous 3 lectures? So if there is no other questions, I think you can go forward for the next presentation.
So if Dr. Horakh is there, he can start.
Dr. Mariam, you want to share it if you can. Dr. Mariam, I think she found the solution of the problem of sharing.
I will share now. Another.
Okay.
The hint is that by the time that you are clicking on the green button, page will come. On the down left side of that page, there is an icon that share the voice of that reference. So after putting that, clicking on that box, automatically you will be able to, by the time that you manage to play the YouTube, the sound will come from laptop, not from your microphone. So it will be solved, the solution. So Mariam, would you please try it? If not?
Yes, yes, Dr. Sure. Now I will share the screen.
Okay, so our next presenter is bioclimatic analysis as an urban and architectural design support tools, a case of Guelma City, Algeria. So the Bautnia Sayad,
Dr. Haider, Buthena is with you. Buthena Sayed from University of Galma is with you. I would like to share my presentation myself because I did some modifications.
Okay.
If possible. Okay.
Yeah. Yeah. Sure.
Okay. Just a minute.
Let's check the sound of this one. I think Mariam may have a problem. So I'm checking.
Shall I share?
No, it was late. Next time, my dear. Just stop here.
Here today to share with you a presentation about the role
of climatic analysis in urban and architectural design process. As a city specialist, our common goal is to design and build sustainable and resilient cities. In the current context of climate change and its effects in urban areas, adaptive strategies that combine technological innovation with locally adapted and climate-appropriate solutions is the key solution to long-term environmental problems. However, taking into account the climate parameters is the first step to save energy and achieve the human comfort. Climatic design is the process that takes into account the climate and the environmental conditions when designing for optimal comfort with minimum outside energy use. Key works recognized throughout history have approached bioclimatic studies, namely Design with Climate, Bioclimatic Approach to Architectural Regionalism by the Brothers Audier, Man, Climate and Architecture by Gifoni, Traité d'Architecture et d'Urbanisme Bioclimatique by Leibard and Hurt. As often mentioned, the main aim of our study is to highlight the role of bioclimatic analysis and design operations at both urban and architectural scale, of which Galma's agglomeration is our case of study. As shown in the graph, our study is organized in two main steps. The first is to draw up an updated climatic report for Galma's agglomeration based on the evolution of the mentioned climatic parameters: air temperature, rainfall, insolation, and winds. The second step is to conduct the bioclimatic analysis. We have to define the bioclimatic stage to which belongs the city of Galma, as well as the climate periods and the thermal zones. Results and discussion. The first thing to be discussed in our presentation is the general weather of Galma. Indicates that there are two climate seasons. A hot season, characterized by higher temperatures, minimal precipitation, and intense insolation. It requires a strong cooling, generally achieved by air conditioning systems indoors, and natural cooling by natural elements outdoors. And a cold and rainful season, generally with moderate to low temperatures, requires natural and artificial heating. As a primary recommendation, the city of Galma must strive with energy saving and the comfort of its inhabitants. This could be achieved if ever the city takes into account the context of place to build, rebuild, or perfect the building by seeking the balance between the urban environment, the climate, the building, and the inhabitants' needs. Design with Gelman's climate. In order to provide a precise analysis of the climate conditions in Gelma over the decade from 2008 to 2017, we have used several methods and few climatic tools. Each one consists of presenting and following the crossing of the parameter or several parameters with respect to time. The first tool used is the climate floor. The climate floor consists of situating the climate to which Gelman city belongs in relation to the different climates having the same features and at different degrees. We have calculated the degree of aridity in Gelma using two methods based on precipitation and annual temperatures. The first one is the method of De Martin, of which the results are shown in the graph. For the mentioned decade, the year 2008 and 2013 have a higher aridity, while the year 2009 and 2011 and 2015 have a minimum aridity caused by the higher precipitation that exceeds 600 millimeters. However, the climate is qualified of subhumid for these years. The sum for the 10 years calculated is 18.8, ranging between 10 and 20, corresponding to the arid climate in upper states. The next method is the one of Aperture. The results of applying this method to the city of Gelma are shown in the diagram. The rainfall quotient for the 10 years from 2008 to 2017 is 61.5, with a cold annual temperature of 2.4 degrees Celsius. As a result, the climate in Gelma is included in semi-arid climate stage with cold winter. The next tool is the ambrothermal diagram. The application for Gelma city was done for the decade 2008 to 2017. The results show an alternation of two periods. The first is wet, spanning 5 months, January, February, March, November, and December. The second period is dry, affecting the remaining 7 months, from April to October. In sum, 202 is the precise number of the hard days in Gelma city. The next tool is the climate periods. The extrapolation of the psychometric diagram of Zucolite applied to the city of Gelma provides information on 6 climate periods as shown in the graph. A very cold period affects a small part of the month, January, February, March, and December. The use of an active solar heating system is necessary in this period. The cold period includes the winter months, January, February, March, April, December, and November. This requires a passive solar heating system. Natural period largely affects the months of autumn and spring. It requires no change. Comfortable period. It covers 6 months of the year from March to October, but the comfort range offers different.
Thank you for your nice presentation. Thank you for Saad. I think this topic is interesting. Actually, the architectural design for the urban planning. So climatic and bioclimatic perspective. So we should have several questions. I think in the next roundtable session, we will discuss several questions. So next one, I will ask our next presenter an investigation on natural window ventilation, improving indoor air quality and energy efficiency in an office building. So this presenter may be Emin Esen. So I think Professor Maria, Dr. Maria, could you please?
Yes, doctor. I am trying to share the next presentation.
Okay, sure. Thank you.
Hello all. I'm so sorry. I have internet problem. Oh my God.
Dr. Haydar, can you please just share the next presentation? Just when you are sharing the next presentation, there is a one option that sharing the voice also, because I think my internet has problem.
Okay, so
just there is an option that share the voice also. You can active that and it will come with the voice.
Okay, so I am trying because I have the PDF for the program schedule.
This maybe you can search in this corner, left corner, sir. If you share the tumble screen, an option is in the bottom corner in the left. Share sound like this. Thank you.
Is it okay?
Doctor, did you active that share sound in the YouTube when you are sharing the screen?
Yeah, the YouTube.
No, not in the YouTube. When you are sharing the screen, there is a share sound. There is an option named share sound. If you active that, I think you can. We can have it with the voice.
Yeah, I shared the active. I shared the my sharing screen from the sharing screen. From this sharing option, right?
Yes.
And then I also do the same thing. I share the screen and
Dr. Haydar, there is a box in the left, down left, the lower corner in the left. It is written shared sound. You can click there, then you share. It will work better.
So you're talking about from my Zoom and then sharing.
When you share, the screen is coming. There is in the bottom
share sound. Share sound, right?
Share sound, yes. Click on that.
Okay.
Yes.
Okay, right. Okay. Let's see what happened.
Click. But by the way, I think Saida didn't finish her. Busaina didn't finish her presentation. That's why we asked her to come back.
I'm so sorry for the internet problems. My connection is very poor, unfortunately.
Okay, so it is now okay, right?
We all have this.
It is now okay, right?
If you don't mind, I will share my presentation again and I'll start it from the point I finished.
No, presentation is running now. It is okay now?
Yeah, okay.
Before we get started on the research subject more deeply, the current situation, future future challenges and their impact on human health should be understood to be able to demonstrate the importance of indoor air quality.
Dr. Haider, you can stop your sharing.
The current situation of the world building right now is overall consequences of human actions and implicitly
Stop
the
your
climate
sharing,
change.
Dr. Haider. Dr. Mariam, if you have any sharing, stop it, please.
Okay, so
Busaina, you can start sharing.
Okay, so I stop my sharing.
Okay, thank you very much. I'm so sorry for the problem.
Never mind. Continue. Thank you.
Okay, thank you very much. Okay.
So you can share now.
Are you having me now?
Yes.
Yes.
Okay, thank you.
Spreads over 3 code months: January, February, March, November, and December. With a temperature between 5 degrees Celsius and 10 degrees Celsius. The coldest period is February, with temperature is situated in February with a temperature of 5.1 degrees Celsius. Cold and heating zone located between the 10 degrees Celsius and 15 degrees Celsius curves. Includes the winter months March, April, May, November, and October. The sensation of cold is localized in the period from 10 p.m. to 6 a.m. Comfort zone between 15 degrees Celsius and 20 degrees Celsius corresponds to the season of spring and of summer, of which the feeling of comfort differs from month to another. Heating zone represents an increase in daily temperatures from 8 a.m. to 6 p.m. located between 20 degrees and 25 degrees Celsius and spread over the months of May, June, and September. Our heating zone characterized by higher temperatures exceeding 30 degrees Celsius. It covers the period between 10 a.m. and 6 p.m. on hot and sunny summer days of June, July, and August. Conclusions. In this study, we have confirmed that the semi-arid climate of Galma City undergone 2 climate seasons, and it must design with the climate to save energy and provide comfort for users. Thus, the main recommendations and requirements for urban and architectural climatic design in Galma City could be summarized in the following points. Cold season in Galma City. Most colds happen during winter, beginning in the late November or earlier December. The cold rate increases slowly to reach its higher values in February for 1 week and 3 months moderate until March, when it goes down. In short, the cold season in Galma is moderate to cold with the possibility of spending the daytime out facilities. The requirements and the corrections to be made are as follows. South orientation with thermal bridge and absence of shade. Use of passive solar. High performance glazing and window frames. Next, heat recovery from the outgoing air. Energy saving household appliance. Highly efficient switch gear. Passive air heating optional. Promote maximum exposure to the sun by adopting suitable type of trees in outdoor spaces. Hot season. Hot season is the longest season beginning in May and remains until later October. The closer we get to July, temperatures get higher and higher. The hottest days of the year usually come between July and mid-August. In summer, the climate in Galma becomes very hard to support and it carries repetitive heat waves. 2 main solutions are recommended to achieve thermal comfort and to minimize the energy consumption: controlling the solar radiation and provide natural cooling. The indoor requirements are the following. Use materials with high thermal inertia ensure phase shift of temperatures, provide strong thermal insulation, use of double glazing on the facades, provide fixed and mobile foam protection on the facades, use of high albedo materials at exterior walls and roofs. The outdoor requirements consists of protecting from solar radiation and cooling down air temperatures in urban areas through the four famous cooling strategies, namely urban vegetation strategy, urban geometry, reflective surfaces and high albedo materials, water bodies, and wet surfaces. Thank you.
Okay, thank you.
Okay.
Thank you, Syed. Thank you for your nice presentation.
You're welcome, sir.
So
I'm so sorry again for.
Okay, so no problem. Just we have some interruption in the meantime. So I think that we will discuss details in our question and answer session. So I will ask our next presenter, like an investigation on natural window ventilation, improving indoor air quality and energy efficiency in an office building. So the presenter may be Emini Sen.
Yes.
Okay, so I would like to Maria to share, or I could share it from here.
You can share, doctor. You can share by
Okay,
yourself.
so
Yes.
Okay, okay, please. I am sharing that on.
Your share screen soon is active now.
Sure.
Hi everyone, this is Mitigation, and I will be presenting the research paper called An Investigation on Natural Window Ventilation, Improving Indoor Air Quality and Energy Efficiency in an Office Building. Before we get started on the research subject more deeply, the current situation, future challenges, and their impact on human health should be understood to be able to demonstrate the importance of indoor air quality, energy efficiency, and why they should be improved accordingly. The current situation of the world dealing right now is overall consequences of human actions and implicitly the climate change. Some of the results of these are rising temperatures, insufficient resources, and primarily air pollution, as we will get into more detail as this research main problem is. Available research and statistics, as can be seen from the graphs also, show that the air pollution has a substantial and adverse effects on human health and comfort, causing deaths, which is increasing by each year. Along with the air pollution situation, there is another challenge, which is reducing the energy consumption, since it is also rising by each year under the new developments happening in the world. Building sectors share a much more significant responsibility in this case, since it takes up 40% of this total consumption, also almost 30% of greenhouse gas emissions. And why is indoor air quality important? Air pollution is not a recent problem. However, it has been newly recognized over the last 50 years, since organizations such as European Union, World Health Organization acted upon this concern by raising their strategies. The recent scientific findings show that the indoor air within the residential, commercial, or other buildings is possibly more polluted than the outdoor air in even most developed cities, causing health risks due to the exposure to pollutants. Due to the recent changes in developing world, the time spent indoors increased also, and the quality of the indoor environment on human health has become a priority more than ever. Increment in time spent at indoors, including all kinds of work and entertainment activities, culminates as a more prolonged contact and contingence with the pollutants and pathogen substances in the air, which emphasize the importance of significant determinant as of the indoor air quality. The EAQ is highly related with chemical and physical factors.
Dr. Haider, you can full the screen, please.
Temperature, darkness, radiation,
you can full the screen from the down right side. The square.
Circumstances,
Full the screen, yes,
please. Strategy
okay?
to improve EAQ.
Yes, thank you.
Also, building owners often do not consider improving EAQ as a means of keeping the running cost lower and rather invest only in immediate maintenance and operation. Choosing between different available strategies while delivering outdoor air to the inside by ventilation, the climatic and cultural aspects should be taken into consideration since the EAQ parameters are highly dependent on the physical conditions of the building environment and preferences of occupants. Natural ventilation and energy efficient building design can be taken as suitable solutions for both of these concerns of air pollution and energy consumption. Natural ventilation can be considered if the climatic conditions are suitable and the ventilation rate is controllable. While considering current demands and climatic conditions of a building, ventilated window configurations, window operation, occupants' preferences can be simultaneously investigated to improve EAQ levels with controlled clean air intake, providing satisfactory indoor air ventilation and reduced energy use. In this study, qualitative and quantitative research methods have been used as of the personal observation along with the building modeling using simulation data acquired from the design building modeling and questionnaires with close-end questions with the building occupants. Also, review of available related literature have been investigated to correlate all collected data in natural window ventilation and its relationship with EAQ and energy efficiency measures. The significant determinants of natural window ventilation are determined as building design, window configuration, window operation, window opening patterns, climatic conditions, and user preferences, while the parameters to be examined are determined as clear air intake levels and energy use of mechanical systems. The case study building is located on a university campus in Gebze, Kocaeli. The building is a 3-story faculty building that was built by an architectural team in 2015 and includes a materials laboratory, model studio, library, conference halls, architectural studios, academic and administrative offices. And the top 2 floors are occupied with the offices and the ground floor is occupied with architectural studios. The building is surrounded by 2 other low-story university buildings and dense cedar trees. The design intent of the building was in a fragmentary manner, which tries to respect the physical and natural environment by considering approaching distances to existing surrounding cedar trees. And the case study building has arguably good design decisions as using one main axis that managed engaged user circulation and balance occupancy between spaces. Also, there is another consideration and this on the same axis using cross ventilation strategies of the building openings between building openings. In this research, the existing window configuration and operable or non-operable openings as windows, atriums, or other openings are investigated under the consideration of clear air intake rates in the simulation, along with the occupant's preference. The results show that and demonstrate that if adequate class optimizing the indoor air quality levels, accordingly comfort levels of occupants and energy use levels. Thank you for listening, and this is
for very nice presentation.
The next presentation, sir, because we are a little bit late. Thank you.
Sorry for the YouTube link. I don't see. So I think we have very good presentation enjoyed, and actually the air quality ventilation is very important for the sustainable buildings, for the green buildings, and for the sustainable development goal actually. So we have some questions. I think we will discuss in the roundtable session. So I will ask our next presenter, C&D waste management model for deconstruction, a demolition of buildings, a case of Istanbul in Turkey. So I think the presenter would be Dr. Semih Sherkan. So just I will sharing the video.
Doctor, can you share the video?
Yeah, yes, I'm sharing.
Okay, thank you.
The sound is okay?
Doctor, I think again you have to activate the that option in the share screen.
So that option was active. So I am stopping.
Yes.
And then.
If you can activate the option again.
Okay, so let's see. The sound option is okay here. The sharing sound option is active here. So the sound is not okay, right?
No, there is no any audio. There is no sound.
So I think someone can help, because from here is sound option is active. It says active, but I don't know if the sound is not clear.
Dr. Haider, is the presenter Dr. Semih is there? It's available or not?
Yes, we are here.
Can you?
Okay.
Dr. Semih,
can you present here?
Can you represent from your side if it is possible?
Yes, we can share.
Okay, so please share your PPT.
Sorry. Hi, my name is Semih Serkan Ustaoğlu. Today I will present to you a paper at the conference on the city waste management model for the construction demolition of buildings, a case of Istanbul in Turkey, which we prepared with Associate Professor Dr. Sevgili Limoncu. City waste is a type of solid waste product. It includes construction and construction site products contained within buildings and infrastructures that are generated as a result of activities such as construction rehabilitation, deconstruction, demolition, and disaster works, and may also include other waste varieties. Throughout the overall lifespan of the buildings, most city waste is generated during the construction demolition process, where the entire buildings becomes waste. For that reason, generated city waste must be managed, for it has a negative effect on the environment by utilizing correct methods through various stages in an environmental conscious manner. However, existing city waste management legal and administrative legislation remains far from adequate regarding the process of the construction and demolition of buildings. In particular, due to intensified urban renewal efforts subsequent to the enactment of the law of transformation of areas under disaster risk may 212, significantly larger quantities of CD waste has been generated, and Turkey's burden of managing large quantities together with existing problems of CD waste management has risen. The lack of comprehensive CD waste management model appropriate to the conditions prevailing in Turkey, as well as the absence of the related legislation and relative indifference of public and private enterprises regarding CD waste has resulted in generated wastes not being assessed properly, and the bulk of the such waste being destroyed at the CD waste storage yards. In this context, as a sustainable CD waste management method for the deconstruction demolition of buildings in Turkey, enabling a proper assessment of waste generated gains importance. In this study, CD waste management in Turkey, building deconstruction demolition works are and implementations of CD waste management in those works have been analyzed. As the case study at location Istanbul Kadıköy district was selected, where the majority of urban renewal efforts in Turkey are concentrated. A survey evaluating the construction demolition process was conducted with 30 of the 45 firms undertaking the construction demolition work in the chosen for study. This study was conducted with the face-to-face interviews. It consists of 5 sections and 34 questions. Many countries have already established regulations, conducted scientific studies, and prepared roadmaps for CD waste management. As for Turkey, despite the control of regulation of the excavation soil, construction and demolition waste law in effect, which is a general law solely deregulating the control of the CD waste in regards to CD waste management. It remains insufficient considering prevailing conditions in Turkey. While CD waste management, CD waste related methods utilized in developed countries are assessed at levels reaching up to 90%, since CD waste management is not a method applied productively. Turkey waste is assessed with existing traditional methods shown in Table 1. Within the scope of this case study and with a survey conducted with the reachable 30 of 45 excavation firms doing the construction demolition works in the Kadıköy district, the construction demolition works and CD waste management awareness during the construction demolition process have been identified. In the case study, the operations of the firms are given in Figure 1. When the Figure 2 of the survey study is examined, it is observed that only 3 firms from a total of 30 incorporate an architect within. The reason for low numbers architects employed in this field demonstrates the level of significance of architectural works in the construction demolition. Insufficiency of significance given to the architectural works causes CD waste not being properly managed. When the Figure 3 of the survey results is examined, given the ineffectiveness in the contents of the existing planning of the environmental prevention measures in Turkey, and additionally, since these measures were implemented by the firms merely to fulfill obligations, to the emerging results are not sensitive to the reality, but to the contrary, may even be said to pose a threat to the environment. When Figure 4, namely the survey results of the sections regarding demolition, the methods utilized by firms is examined, it is seen that manual demolition with impact, and demolition by high-reaching excavator methods frequently used, as well as demolition using grapples and shears. While manual demolition is a positive method for recycling CD waste, other methods have a negative effect. Generally, stairs and facades are not deconstructed, while roofs and wood products are often deconstructed. Consequently, CD wastes first and foremost should be managed without causing a health risk, environmental safety. A CD waste management methodology appropriate to the conditions prevailing in Turkey should be developed for CD waste produced in large quantities as a result of the construction demolition works, especially given the recent increase due to the numerous factors. CD waste management during the construction demolition of buildings is approached in 3 stages: pre-application, post-deconstruction demolition stage. Pre-deconstruction demolition stage, the construction demolition decision, determining the contractor and teams, environmental impact and surrounding analysis, building analysis, CD waste management planning and scheduling, the construction demolition permit, the construction demolition building, processing CD waste storage, transportation of CD waste, cleaning the work site. The building analysis is structural system analysis. In the structural system evaluation process of the building, the type of structural system, whether it damaged or not during any previous disaster, if the structural system has any association to the neighboring buildings, whether there are damage and or deformation on the columns, foundation, flooring, or beams, integrity of the system, current conditions of the wall, structural system elements to be used in the construction demolition methods should be decided and evaluated. Architectural evaluation, this action step should be evaluated with works such as for buildings without construction plans, manifestation of the current situation of the building by redrawing plans from statistical service showing their original state, for building with construction plans, comparison with the current state of the building and historical identification of the change, spatial analysis performance, determining of work areas which might be risky for the workers, specification of the building whether it has historical or monumental value or not, classification or CD waste particles which might fall or fly uncomfortably during the construction demolition work, detection of the possible dust, noise, and vibration conditions. Source reduction, prevention, assessment methods, source reduction, prevention, reuse, recycle, disposal. The construction demolition, application of the construction demolition stage, the construction demolition permission process, the construction demolition works of a building, processing CD waste, storage of CD waste. Preparation of the post-construction demolition stage, preparation for this assessment, to clean the arrange of work site, to store reusable building products, the conversion of the site into the green area if the building products are not used. Conclusion. It is necessary to manage CD waste in order to reduce amount of raw materials and energy used producing new building and building products, to avoid negative impact of the hazardous material used in the past, and to retain control over them without negatively impacting the environment. For the CD waste to be managed, it's also crucial to manage process where CD waste is generated in the construction demolition of buildings. With these suggestions, it is considered that the impact of the CD waste from the works on the close vicinity of the building and the broader environment will be minimized. Appropriate solution will be developed by accurately determining the magnitude of work. Appropriate the construction or demolition methods will be utilized by taking CD waste into consideration. Significantly, high quantities of CD waste will be recycled. New raw materials used and energy consumption required in product new building materials will be reduced to minimum levels. The amount of CD waste storage underground and destroyed will be decreased. Works will be conducted and under more controlled and safer conditions. Thank you for listening to us.
Thank you, Dr. Semi Sherkan, for your very nice presentation. Actually, the C&D waste management model is very important for the building construction. So we'll discuss in our next roundtable discussion questions. So I would like to invite our last presenter. The topic is vertical farm, an approach for controlling the regions of the urban heat islands. So I will share.
Is Dr. Islam is there, or Noura maybe?
Yes. Hello, it's Noura.
Okay, so
Noura, can you share yours to see maybe the sound, the voice is better?
Okay, we'll try now.
Okay, let's see. Our video is active or not. If not, then we can in that case.
Is it shared?
Yeah.
Can you hear?
Okay, it is fine.
Today I'll be talking about the vertical approach as a sustainable solution for controlling the incompleted island and improving the metropolitan quality. The world is passing through a continuous matters that contribute concern to humanity. In many terms as high population, urbanization, and the most important climate change. And according to the Intergovernmental Panel on Climate Change, the current practice food system, which is the traditional farming, causes 1/3 of global emission, which has a serious bad impact on the environment and the natural life cycle. Agriculture is not a natural practice.
Excuse me, I think to share is open because the sounds is mixing.
So the sound, sound is not here. I think the sound is from the presenter.
And this behavior
Yes. Can you, one of you, can you share the screen?
Who's sharing the natural landscape and the natural inhabitants. So this chart is showing the decreasing stocks of purple lands among the years from 1990 to 2050 in relation with the swiftly growing population, which is projected to reach 9.7 billion by 2050. Yes. It makes a huge challenge for humanity to find ways and alternative solutions to feed the swiftly growing population. So a vertical farm will stand as a great solution to overcome these issues as the climate change, high population, and decreasing stocks of arable lands. And a vertical farm in the simplest term is a multi-story building that cultivates food under a controlled condition. And the vertical farm approach aims to increase productivity and reduce the environmental footprint. And according to Dixon Spellmeyer, the father of vertical farms, the benefits and advantages of vertical farm listed as year-round harvested production, no weather-related crop failure, no agricultural runoff, no use of chemicals in the soil, ecosystem restoration, and uses 70 to 95 less water, as well as greatly decreased food miles, more control on food security, new job opportunities, recycling water, secure food system, revival of the natural inhabitant. And now we're having a comparison between soil-based farming, which is the traditional farming, and a vertical farm. So for land use, traditional farms use 80% of the suitable land for farming on the planet, while vertical farm use 0.4% of the land. For protection, we almost lose half of the product in traditional farming, while 90% of the product are harvested in vertical farms. For water, 70% of the global fish water are used in traditional, while the farm use water in cultivation process. How vertical farm works. It needs 4 basic elements: the physical layout, lighting, growing medium, and sustainability features. Physical layout, which means the cultivation process occurs in a vertical stacked layer. For lighting, the perfect lighting level, the right amount of natural and artificial lighting. For growing medium, the soil cultivation, aeroponics, sustainability features, renewable energy, advanced techniques to offset the energy cost of farming. The vertical farms focus on the opposite practice of traditional farming in terms of environmental conditions, water, energy consumption, and energy generating methods. The vertical have the World Food Building. In New York, we have the vertical farm, and in France, we have the Living Tower. In fact, there's just one built vertical farm, and the others are just a proposal for a vertical farm project. Like the Living Tower in France. The Living Tower is a self-sufficient structure as it generates needed electricity from natural resources like solar energy and wind energy. The World Food Building in Sweden, the first vertical farm ever built. This project will save a total of 1,100 tons of CO2 emission and 13 million liters of water each year. The building is divided into two sections, the office area and the farm area. And there is an exchanging process between these two sections in the CO2 and oxygen. This building shows the chances and opportunities to integrate vertical farms within any city skyscraper. A project such as a vertical farm positively affects the citizens, climate, and the overall atmosphere where it will be placed. Vertical farms add environmental, social, economical, and sustainable values. And it offers solutions to an existing difficulties within the food protection system. Manama, the capital of Bahrain. This map is showing a study across all Manama, showing the high rate of urban heat island phenomena in Manama. So if we have a vertical farm in this place, it will help and refurbish urban atmosphere that will lead to the controlling of global warming and maintaining the urban heat island resources. At the end, just to remind you with the benefit each city will gain from having a vertical farm project within its fabric. A secure food system. The COVID-19 pandemic has contributed to an increase in the demand for local food systems that are never affected by global issues as poor food supplement and sudden situations. Agricultural development involving Bahrain and each country in a global contribution in the field of agriculture and food protection. Local production. Reduce imported food quantity, cost, and energy. Recovered environment, heat and CO2 reduction in urban areas and crowded cities as Manama. Land use, the fully indoor farming will limit issues related to traditional farming. A vertical farm will add sustainable values to the city as these projects integrate water and waste recycling systems. And also a vertical farm combined and natural energy resources to operate the farm. This all will lead to have a healthier neighborhoods as a vertical farm provides a great amount of oxygen that will be exchanged with the outdoor CO2 that will enhance.
Thank you, Nur Ali. This is a very nice presentation. Okay, so thank you. I think Dr. Noura is still sharing your screen.
Noura, if it is possible, you stop your close your sharing.
Is it closed now?
Okay.
It is closed, but
Dr. Haider, maybe yours.
Huh?
You are sharing.
Not I'm sharing.
I think this is from Noura.
It is from Noura. Yeah, please.
Noura, can you stop the sharing?
Well, I click the button, but I don't know it's not going.
Okay, you go out and come again to the group.
Okay.
That's good. Okay, fine. Okay, fine, Nurali. But it is very nice and very important topics actually. If you remember in my talk, Actually, we are talking about such type of sustainable building design, because a lot of option is here for the green building for the sustainable cities. So this is very interesting topics. I think now we are on the stage of our roundtable discussion. So the floor is open now, so we can ask questions. So please, Dr. Shalar, could you please open the session and just conduct the session?
Any questions regarding the presented papers from the audience and other authors, please? If there is no any questions, we can go ahead with the next session, because we are already in time with the next.
We are already.
Yeah. Any questions? Okay, no questions. Thank you very much. Thank you, Dr. Haider. It is our honor to have you with us.
Thank you. Thank you so much.
Now we can go to the next part of architecture and technology, thermal aspects. Dr. Mariam, Dr. Shahira is here.
Yeah, and myself as Mustafa Alwan.
Mustafa, Dr.
I am
Mustafa.
Here, Mustafa Alwan as a co-author. Yes, sir. Yes, sir.
Thank you very much. Can you share your presentation from your side?
Dr. Salar, I can share it if you wish. If I think...
Okay, let us to let Dr. Horakh do that instead of us. Thank you, Dr. Horakh.
Okay.
You came in time.
Sometimes I'm coming, I'm checking, and I'm going to other sessions. That's why since I'm here, I shall do it. Facebook and sound share, this important button that I was always forgetting to put it. And now let's go with the...
Hi, everybody. It's a pleasure to have the opportunity to perform and present my paper titled Retrofitting Campus Outdoor Space Based on Thermal Performance, the case studies Verbe University campus at Tanta City. University campus meant to provide open and green spaces for students to create and excel. The campus outdoor space, COS, of the College of Engineering in Tanta is a central square overlooked by the college buildings, which exposed to excessive solar radiation without shaded seating areas or convenient passes. As a result, social contact and comfort environmental retrofitting were the main pillars of the design decision. The retrofitting process began with a general examination of the COS to determine main obstacles. After that, suggesting and analyzing appropriate solutions. Finally, comparing COS before and after implementation of the design elements and guidelines. The campus open space can be indicated by 8 sides or an octagonal shaped plaza. The total area of the plaza is almost 2,333 meters. The main COS in front of the building was designed almost like the Islamic Mafruka shape, embracing greenery and pedestrian buses. The main target of the design was to protect COS users from excessive solar radiation and high temperature by setting up semi-arched buses surrounded by trees and shrubs and establishing shaded seating areas like pergola. Moreover, pedestrian buses were defined by different floor finishing materials. Wooden material and the Islamic design of seating were arranged on both sides of the entrance, in the middle of the seating areas in front of the main building entrance. Some occasional land use can be observed, such as exceptions and student center services. In the middle of the square, 4 wooden pergolas were added to create semi-closed social activity shaded areas. Also, 2 fountains were installed for noise depletion, reinforcing a stress-free atmosphere. Besides, its cooling effect decreasing surrounding temperature. As we see here, the vegetation and planting, cool materials, shading methods, water elements, and building heights variation. First, field measurements were appraised by Nova Linux Weather Station and investigating weather data files through the Climate Consultant Program. Investigations revealed excessive solar radiation and high temperature, hampering using overlooked spaces between buildings. The data was investigated on 21 September at 2 p.m. through the study period due to momentary weather changes. The selected COS was divided with 20 monitoring points distributing in grid distribution with grid different sizes. The result due to implementation design were showing a remarkable decrease in air temperature and radiated heat flux after design modification. The main advantage of using CFD is for swiftly predicting future design scenarios based on solid-based input data and analyzing the environmental performance of the implemented design. The 5 main methods of ANSYS fluent simulation begin with creating a geometrical model using available data and drawings. We used AutoCAD program in the current study to build a 3-dimensional model. Secondly, the grid cell generation process. The third stage was focused on setting up the surrounding boundary conditions which identify the surrounding buildings, surface and needed measurement point. Fourthly, the iteration process using energy equation, radiation, Roseland model, solar radiation, solar loading, and the turbulence kinetic energy K epsilon method. According to ASHRAE Handbook 2005, people dressed in normal winter clothes. The confident temperature is 20 degrees Celsius to 23.3 Celsius at relative humidity 50%, which could be up in with lightweight clothes 2 degrees 0.8 Celsius. And ASHRAE also indicated if the global horizontal radiation value exceeded 315 watt per meter square, there is a need for shading devices. The result here shows before implementation and after implementation our design. Before implementation, the surface could be up to surface temperature could be up to 70 Celsius. After implementation, it decreased to 44 Celsius. Air temperature was 50 Celsius, decreased to 35 Celsius. Global horizontal radiation was 650 watt per meter square. It decreases to 150 watt per meter square. These results are important as they reveal the new methods to assess the retrofitting design of campus outer spaces, which took into consideration environmental conditions and surrounding boundaries. The obtained results also support retrofitting design decision, either in greenery or installing pergolas or use surface finishes material or water element installed. Monitoring the environmental performance of the COS by means of measurements or using simulation programs led to emergence of problem that hinder the use of COS spaces. The surface temperature was 70 degrees and the air up to 50 degrees, which was very difficult to go through buildings. We can see here this comparison of absorbed infrared solar flux, which decreases from 290 watt per meter square to 87 watt per meter square. Also, infrared solar flux reflected. It was 71 watt per meter square, decreased to 21 watt per meter square. Using the simulation program and systematically evaluating the new design enable us to make a more profound analysis of many factors affecting the environmental performance. Contours of visible solar flux, it is decreased from 480 watt per meter square to 180 watt per meter square. Conclusion: the importance of the environmental approach in the proposed retrofit of the COS was authenticated through the assessment of the design decisions technically. This research specified a successful design strategies for campus outdoor spaces to achieve optimum use of space and to create a healthy, vibrant, and sustainable environment. Also, it represents technical ways of qualitative evaluation of the renovating proposals. Thank you, and forgive me for my hurry. It is because of the limited time which I don't want to exceed 10 minutes. Thank you very much.
Dr. Hurash, are you here to stop share screen?
Yes, I'm going to open the second authors. I would like to thank Dr. Shahira, Professor, and also Dr. Mustafa Elvan.
Thank you, sir. Thank you, Dr.
Analytical study.
Dr. Hurash, I think I can open the sharing. Let me try because here there is nobody. Maybe my net is better now.
Perfect.
I will try and we will see if I could. 1 minute. It is
Thank you, Dr. Mustafa. I think I have a problem with my internet, but it is very interesting work for you and Dr. Shahira. We will talk about that later. Thank you.
Thank you very much. Thank you very much.
Dr. Mariam, can you share the next presentation?
Yes, I will share it now.
Implementation of value engineering in Iraq as opportunities and obstacles.
Do you have the voice?
Case study.
Perfect. Thank you.
I will give a general overview.
My internet now is better.
Literature review.
I also put the CC button. Everyone will be
followed in this research and the case study and the results obtained from it, and the references. As a background to understand the basic issue, which is the engineering management back there in Iraq. Generally, we have a poor engineering management, and that started from the planning phase to the implementation. For example, in the planning phase for the creative and the innovation, limited level in the planning phase, and in the implementation by bad implementation, or either by the old or limited using of modern technologies. The second one is the lack of decision-making technique as a comprehensive decision-making technique that cover all the needed sides as a structural point of view, material point of view, even economic point of view. And number three, which is the repetitive projects. The majority of the projects are just repetitive. And I'm not talking about highway or something as a construction. I'm talking about building construction for two sides, the housing, residential, and the commercial or administrative or even educational buildings are just repetitive projects. And the other issue, which is the limited application. We have a quite high amount of research for many aspects in engineering management or other aspects of management and engineering in particular, but the application is very limited. Here are some examples for the repetitive projects. We can see both the residential and the commercial, administrative, and educational building. As a main objective of my research, I will try to examine value engineering as a tool of construction management in Iraq, whether is it applicable or not, and as a decision-making technique, a comprehensive one to see whether it's meet to the functions there for the users and for the engineering society. Number 3, as a case study, an application approach by examine it and see the opportunities and obstacles. So as a literature review, we should understand the value engineering. Value engineering is a concept that deal mainly with the value of an alternative. For example, the highest value for an alternative comes with the best quality and meet our function to the lowest cost. And by understanding this relation between the functioning quality and cost on the phases, which is the value engineering phases, starting by gathering an information for the site, for the general situation, then the function analysis by the users or for the engineers. What are the functions to meet by giving the decision, even in the planning or after that in the implementation phase. Then the creative by giving the alternative and try to meet the function. And then the evaluation between these alternatives by using the value analysis and to try to make a development whether we can achieve a better alternative or not. If not, the best solution will have the presentation to the stakeholders. Here are some basic and traditional technologies in Iraq, and I'm talking here basically on the repetitive projects as a housing or as a educational, administrative, local buildings in Iraq. My methodology will be about giving a literature review first for the base information about construction management and value engineering, then give the needed information to implement the value analysis, and then suggest alternative to our case and evaluate them using value analysis to come up with the best solution.
Dr. Maria, the video is not moving.
Evaluate these results and giving the recommendations and to note the obstacles and the opportunities by implementing this strategy.
Excuse me, Abdullah.
Which is a 3 stories.
Do you hear me?
Yes, I hear you. I'm here with
Province. It was constructing 5 years earlier.
What is the problem with the video?
I think you opened another tab. This is another tab. Go back.
He's sharing another video.
Yes, exactly. You are sharing another one.
And to take the feedback.
The previous one is opened. Above. It's above. You can see it above. No, close this one. Stop it.
Is widely available.
Open. Yes, this one up. You can see 2 tabs of YouTube. 2 tabs of YouTube.
Is it okay now?
No. Open the previous tab of YouTube. There is 2 tabs.
Disadvantages by bad.
Shall I stop sharing?
Mariam, do you?
For the building.
I stop sharing.
Stop sharing to don't make the yes. So, is there another sharing of video?
No, share again now, please. I think.
I have to share again.
Yeah. I can share.
But there is another video is going now.
So close, Doctor. Is there any other sharing of video? Maybe Dr. Horaksh?
Actually, no, I'm not sharing any. Just let me open the one. So I'm going to open Dr.
So, Dr. Mariam, please shut down your YouTube in order to listen to one only.
I'm going to open Dr. Salah Haji Ismail. Am I right?
No, wait.
Yes, I am here instead of him.
Yes. Exactly.
I can share instead if you like.
No. I want to be sure that
the
program that has been sent to all of them is correct. Or maybe Mariam selected the wrong one to share. That's why I'm trying to play it again to be sure that it is working. Then I will share my screen with you. So now I can see that again the same one came. Let's check with each other.
The implementation of value, yes.
this the implementation of value. So please check this one to be confirmed. Is it the same one, dear Abdullah Muhammad?
Yes, it is. Yeah.
My professors, my
perfect,
colleagues, ladies and
It's
gentlemen,
perfect
I will
now.
use my presentation. My name is Abdullah Muhammad Al-Hamdani, and I will explain the implementation of value engineering in Iraq as opportunities and obstacles on a case study. In my presentation, I will give a general overview and a basic literature review, and of course explain the methodology followed in this research, and the case study and the results obtained from it, and the references. As a background to understand the basic issue, which is the engineering management back there in Iraq. Generally, we have a poor engineering management, and that started from the planning phase to the implementation. For example, in the planning phase for the creative and the innovation, limited level in the planning phase, and in the implementation by bad implementation, or either by the old or limited using of modern technologies. The second one is the lack of decision-making technique as a comprehensive decision-making technique that cover all the needed sides as a structural point of view, material point of view, even economic point of view. And number three, which is the repetitive projects. The majority of the projects are just repetitive. And I'm not talking about highway or something as a construction. I'm talking about building construction for two sides, the housing, residential, and the commercial or administrative or even educational buildings are just repetitive projects. And the other issue, which is the limited application. We have a quite high amount of research for many aspects in engineering management or other aspects of management and engineering in particular, but the application is very limited. Here are some examples for the repetitive projects. We can see both the residential and the commercial, administrative, and educational building. As a main objective of my research, I will try to examine value engineering as a tool of construction management in Iraq, whether it is applicable or not, and as a decision-making technique, a comprehensive one to see whether it's meet to the functions there for the users and for the engineering society. Number three, as a case study, an application approach by examine it and see the opportunities and obstacles. So as a literature review, we should understand the value engineering. Value engineering is a concept that deal mainly with the value of an alternative. For example, the highest value for an alternative comes with the best quality and meet our function to the lowest cost. And by understanding this relation between the functioning quality and cost on the phases, which is the value engineering phases, starting by gathering an information for the site, for the general situation, then the function analysis by the users or for the engineers. What are the functions to meet by giving the decision, even in the planning or after that in the implementation phase. Then the creative by giving the alternative and try to meet the function, and then the evaluation between these alternatives by using the value analysis and to try to make a development whether we can achieve a better alternative or not. If not, the best solution will have the presentation to the stakeholders. Here are some basic and traditional technologies in Iraq, and I'm talking here basically on the repetitive projects as a housing or as a educational, administrative, local buildings in Iraq. My methodology will be about giving a literature review first for the base information about construction management and value engineering, then give the needed information to implement the value analysis, and then suggest alternative to our case and evaluate them using value analysis to come up with the best solution, and then to evaluate these results and giving the recommendations and to note the obstacles and the opportunities by implementing this strategy. As a case study, I will define my project, the building that I used, which is a 3 stories educational building, a part of University of Fallujah in Al-Anbar province. It was constructing 5 years earlier, and the structural system used is the skeleton cast inside system. Starting firstly by asking the users and engineers enrolled there about the building and the whole situation, and to take the feedback. As advantages, we note that the architectural design was okay since it meets the purpose as educational building. Then the material used is widely available as a RC, and the skeleton system was okay, which is give us the ability to modify since there is almost no constant function for our buildings. We change it by time. Also, we have some issues as disadvantages by bad thermal and sound isolation, and also the bad implementation for the building and the wasting in time. So by understanding this issue and understand what are the problems to solve and what are the issues that we want to improve, we give up the criteria for our value analysis. Firstly, the enhancing for rigidity, then environment compatibility, repairing easily, modifying ability, thermal and sound isolation, code compatibility, and fast build. Also, we give our alternatives to the one that is already used as a steel structure, precast concrete, and a load-bearing walls. So starting by modeling and quantities for our alternatives that we suggest, and the alternative and the existed one, the structural system, by using Revit program and calculate the quantity for every structural element to give more accurate calculation. And that will be used in the cost analysis, of course, to see the price, the life cycle price for each alternative. This life cycle cost consider the surface life, and the surface life is taken in this study as a 50 years for educational building based on the European code, and the maintenance cost is a percentage from the initial cost as it's used to be in the Iraqi society. So value engineering, as we mentioned before, the best functioning quality to the lowest cost, and a weighted evaluation was obtained by the help of 11 different engineers, experts in the field, and after analyze their feedbacks and to the cost that we obtained, we found that the best solution was the precast concrete than the steel structure. As an evaluation approach for our results, we get back to the structural studies, and we found that the advantages of precast concrete facing the on-site concrete, that firstly it enhanced the rigidity, which was one of our criteria by the research, experimental research by Noack, for example. He found the mean strength and specified strength for the precast concrete is much higher. Number two, the time consuming by VS and also experimental study found that the precast concrete minimized the time by 35% for using the precast concrete. Number three, which is the cost decreasing by Touré and Wagner, they found that the payback period for precast concrete is 2.5 years, whether it's for on-site, it's almost for 3.8 years. Based on Iraqi standards, they show that the precast concrete has a percentage of wasting only 2%, where the on-site concrete has almost 7% of its quantities as a wasted materials. Another issue, which is the reinforcement ratio. Based on the ACI standards, we found the precast concrete for both longitudinal and transverse reinforcement as a steel amount in the RC, in the concrete, it's less than the on-site concrete. Also, the transportation time will be less. As achievement and obstacles to this study, the achievements that we obtained the essential criteria for decision-making in such cases. Also, we found that the value engineering is an applicable strategy in Iraq, and we could obtain the better alternative to our case. Some obstacles were due to the cost estimation as a unit price issue and the old standards and the lack of information. To come up with a conclusion, and we recommend to train the engineering society, especially for value engineering, and to update the unit price by having a unit price standards monthly, annually, to give more accurate and to give a better decisions by the engineers. Also to update the standards, the structural standards, the engineering standards regarding the new system, the new technologies, and try to spread the precast culture in the society and have at least one company of precast concrete in each city. Try to obtain also and have the Iraqi branch, Iraqi Value Engineering Society for as a branch for any international society, and try to include the value engineering in the contracting process, in the contracting by adding some trophies, for example, for using it, or at least just teach people, notify them about the advantage of using value engineering. These were my references, and I will be glad to hear your comments and answer your questions, if any. Thank you a lot.
Thank you, Mr. Abdullah. It is very, very important issue. We will talk later about it, especially in countries like Iraq and developing countries, low developing countries. The next will be minimize the carbon footprint by using round earth technique.
I'm going to, maybe Dr. Mariam would like to share.
I will share now.
Also, our other presenter, Mr. Mohammed Emin Shishman, I think they don't have presentations, so we will have enough time, hopefully, to be on time for the next roundtable.
Know that the climate change affect hardly all around the world, caused several natural disasters, and maybe sometimes lead to
Is it
war.
okay?
Unfortunately, the result of that to destroyed our city. And after that, we really think about how we can reconstruct our city. And the reconstruction process
Is it
itself,
okay?
it's more difficult than the normal construction because we need to deal with the rubble, we need to deal with the waste. And the construction sector itself has consumed a lot of energy in different stage. First one, when we need to produce a material, we need to consume a lot of energy. After that, we think about the transportation, transit this material from the producer to the consumer. The other things is it's the construction process itself. After that, we need to think about the life cycle of our building because we need to consume energy. As a result, the construction sector causes more than 20% of carbon dioxide. So, I start ask how we can minimize the carbon footprint in reconstruction process. I found that we need to deal with material. Material, it has a major impact. We need to find sustainable environmental material, which don't need a lot of energy and don't produce high of carbon dioxide. Another things about the technique which we need to use during the construction process and thinking about the consumption of energy after the building finish. So my solution, it was using rammed earth. What is the rammed earth? Rammed earth is a technology for construction foundation, floors, and wall using natural materials such as soil, chalk, silt, lime, or grass. In rammed earth, we are concerned about some material like gravel, sand, silt, and clay, which is inside the soil. There are two mechanisms make rammed earth hold together. We are looked about two features in the soil itself. The first one is the boundary between the material. The second one is the clay. There are some features we need to look at between the boundary between the material, the volume of the material, and the quality of the clay. Not all the soil can be used in the rammed earth. For this reason, we have two types of rammed earth. Unstabilized and stabilized rammed earth. The first one, it's use raw material, just soil without adding any blending material. The second one, which is stabilized, we need to add some blending material like cement. To determine that, we need to make some simple tests And sometimes we need to make some control tests. This test help us to define if the soil need to adding some blending material or not. For this reason, I start to look about some research about different type of soil. And I found a study in San Luis Obispo, which used 3 different type of soil, which is the clay sand, dark yellow brown, and sandy clay. This type of soil needed to add some cement. It's about 7%. And the result, as I mentioned, it's not acceptable for all the soil. Some of them it's get required good, another it doesn't. After that, I start asking myself, can we use another material? Can we add organic material in stabilized or unstabilized rammed earth? And I find the study talk about that. They made different mixture with adding cement and without adding cement, stabilized and unstabilized. And sometimes they use organic material like dung. And the result from this mixture, the best one is the A, which use it stabilized rammed earth with adding some cement. Another thing or another concern in my study was about the rubble. Can we use the rubble in reconstruction process? Actually, we can use the rubble, but we need to design our soil by ourselves, because when we use the normal soil with the rubble, we don't get a high result. But when we use with the designed soil, which we are call it energetic soil, the result is acceptable. After that, I start asking about the waste. Can we use the plastic waste in this process? Actually, yes, we can use it, and it gets a high result than the normal soil or than adding the cement itself. We can using the fiber, and it will get us a high result. So when we look about the rammed earth, actually we look about the thermal behavior of this building. And I want to make a comparison between the rammed earth itself and between the concrete building. And we found that the rammed earth is better than concrete building, according to the study which made in Morocco. And I found that rammed earth doesn't lose head, and it's better than the concrete building according to the design. And there's some factor go inside this study, but we are focused just about the material, and we found it's better than concrete. Another thing we are start asking ourselves, can we use the isolated material with rammed earth? I found a study talk about the normal rammed earth without isolated material and other without with isolated material. And I found, yes, we can use it, and sometimes we have to use it in some condition. So my conclusion of this study, we can reduce carbon emission in reconstruction stage, and we can use rubble and waste material in reconstruction process. And sometimes we need to think about the isolated material in rammed earth itself. Actually, it's better than concrete, but sometimes we need to add isolated material. Thank you for listening.
Thank you very much.
Dr. Mariam is, we are waiting for her to.
Dr. Mariam, if it is possible to.
I think they share the sessions, the last author of this session, which is supposed to present the research on multi-story timber building in the construction industry.
It's not available here?
No, they are not available, so you can conclude the session there.
So, okay, thank you very much, Dr. Horash. If there is any questions, please, the floor is yours, all audience and authors. If they have, and if there is any questions regarding the three previous papers, you can raise your hand if you have any questions. If personally, I have some questions. If there is no any questions, I will start to ask. Any questions? Okay, I will start with the first with Dr. Mustafa. Dr. Mustafa is here.
Yes, sir. Yes.
Dr. Mustafa, it is very interesting work that you did. I want to ask you, okay, I appreciate 100% what you did, and it is a professional work with very good results, as we see, 650 become 150 irradiation, I think. But I want to ask you your personal opinion. How much we can trust simulation programs? As an architect, we have to involve some, let us say, human feeling in our work. So how much you can trust simulation program, despite the good results that it is giving you? This is only the question I'd like to reflect.
Okay, sir. First, I want to say some points. There are too many simulation programs, which varies from accuracy. ANSYS Fluent, I think it is not for architect. It is something professional branches of engineering. Like if we can say when he calculate natural ventilation, it is not that easy that design builder could do. He uses the mathematics and equations in this field, which you can choose like epsilon or linear or laminar or which is very sophisticated to an architect, which I had difficult in the beginning. ANSYS as a program special is the most, I think, is the most accurate simulation used in other branches than architect. But as you said, sir, I am not using simulation to figure out a precision value. I am looking for the direction of this result. I mean, this simulation is only just a second. It's a stationary reveal. 1 second, in the whole year, but it shows a high decrease. This is I am looking for. Also, there are something I can't do without this simulation, like he can split several kind of radiation, like infrared, or he can split visible electromagnetic waves than not. So I use it to analyze and detect, and I am going into to the right direction. So that we used Nova Linux weather station to validate or to be sure that this is the right reflect on this design or retrofit? Sorry if I long.
No, it is very clear. What I was thinking, if we can mix let us say this is objective way of study. If we could mix the objective way with the subjective way, opinion of the people or the feeling of the people, maybe we can get better results. Do you think that?
يعني I want to say some kind of measurement like the opinion or like when we measure or indicate thermal comfort by fungus index. يعني I don't depend on this because sorry if I said I am fat and I don't feel cold so much. I don't feel cold so much. When I am very, very satisfied with weather, some people say they are freezing. So I went to the.
So you will not be the one that should be asked.
Yes, yes, I am. I have a very far answer or very excessive answer. So I went to the ASHRAE. ASHRAE say 315 watt per meter square. Okay, this is the reference I will take. Also, I think we can add this objective of people to figure out what is happening. Could be. But I have a question for you, sir. If the two methods get the same answer, what should we do?
The same two methods get the same answer means, what do you mean by that? You mean
means if I asked people, they said no, it is not okay, and the physical measurement says it is okay. What should we do then?
I believe there is. I don't think the result will come in such way that people says no and the measurements say yes. But for sure there is some harmony or distance between both of them. You can test this distance in order to make like correlation between them and do this correlation like a standard for yourself in order to measure again the condition and to see the result is correct or not, it's valid or not valid. This is what I think. I don't think there is radical answer between both, unless you ask somebody like yourself about the thermal comfort.
I think I should focus on some picture which indicate in this area there is no one can afford to stand, and after that busy area and very had too many equipment of student. Okay. Yes, sir. I think I could focus on this.
Thank you.
Thank you, sir.
Thank you, Dr. Mustafa. Thank you very much. If Abdullah is here, I want to ask him something also. I reflect on his important presentation. Abdullah, are you here?
Yes, I'm with you.
Thank you very much for your presentation. We know all the value engineering is very important, especially for engineers, and in the countries that are witnessing construction blooms like Iraq, for example. But the problem is the obstacles everywhere is, we can say there is a standard obstacles that you mentioned them. This could be everywhere, but in Iraq, I think there are different type of obstacles. For example, in Iraq, the budget means the project should fit the budget, not the budget fit the project. Do you understand what I mean? Exactly. For example, in your governorate, Anbar, for example, they are they have budget for, let us say, $2 billion. They are asking the authorities to make projects with this money. They are not asking them oppositely. I think this is one of the problems about the value engineering in Iraq. What do you think?
You are totally true. This is one of the main aspects. Generally, the limit should be something, let's say, from engineering perspective. For example, I wanted, for example, to be has a capacity. If you are talking about educational building, a capacity of that much rooms, a capacity of that much students, etc. These should be the limits where I come. And
this is the planning.
Can,
what I want to tell in
exactly.
The end of the day, it's a planning, a lack of planning for the project. And I agree with you 100% for the precast concrete, because it is also eco-friendly and environmental solution. I hope to see this kind of project in Iraq.
We all hope, but the issue is there is no time for creative time in the planning. Yeah, you know that.
Let us to be optimistic.
You know
Let
that.
us
Thank
to
you.
be optimistic. Thank you very much.
I hope. Thank you
very much.
Thank you. It's my pleasure.
The last Ramid Earth. Ramid Earth is.
Yes, Professor.
Sorry?
Actually, I'm here.
You are here? Okay,
yes.
Thank you very much. For sure, Ramid Earth construction, it's very important for the environment and cutting the carbon footprint, because you are reducing the cement the cement content in the construction. And I think you are using 5% as far as I understand this, right?
Yes. Actually, it's dependent on the type of the soil and the quality of the clay.
Yes, exactly. This experience, I saw this type of construction in India. They have this type of technique, and but the point is, I want to ask you if we use this in rainy and humid places. What about the erosion? Do you know the durability of this kind of rammed earth?
Yes, actually, in the, as you mentioned, in the rainy places, we need to build the foundation in concrete. We need to deal with another solution like the stone and something like that. Not every time. Yeah, as you said. Not everywhere we can just use this rammed earth without using another type of foundation. It's dependent on the climate. Yes. It's dependent on the place.
That's great. Thank you very much.
Thank you, Professor.
Thank you very much. Dr. Hurash, if you are, we can
go. I'm around. We shall continue. If Dr. Mariam may take.
Yes, let us to start with a comparative study on the responsive facade system. It is very interesting subject. Can we start?
Yes.
Dr. Mariam, are you?
Yes, I will share it now.
Thank you very much.
As all we know, the life has been changing.
Is it okay?
Depending on constantly changing
now,
which affects including the architecture.
Yes.
As the activities of movement society transforms, the concept of movement has become a part of architectural design. Since the existing buildings or building components cannot respond to the change it needs, the design process of the buildings has been started to be questioned. New solutions have been sought even in the facade design in order to adapt to the change using the concept of movement. When the existing literature on the responsive facades has been investigated, it has been seen that the facade systems are generally reviewed based on their system types or materials. There is a lack of clear definition in element types, movements, and control systems. In this study, the aim is to propose a new comparison matrix to review and analyze the existing examples of the responsive facade. A comparison matrix has been created based on the movement of the responsive facade systems, since the movement is the main parameter which can be used to identify for different facade systems. 5 movements have been defined in the comparison matrix. In addition, there are 6 other parameters in the matrix, which are the type of system, the type of control system, the control type of elements, the function of the facade, the response time of the elements in the system, and also visibility of the facade system. Type of system indicates whether the system is active or passive. Type of movement defines the motion of the elements in the responsive facade systems. The movement type have been examined under 5 main headings: rotation, deforming, folding, sliding, and hybrid. Type of control system indicates the factor that provides the movement of the system. The responsive facades have been classified into 2 systems, as hand-operated control or central control. For control type of the elements, unlike the previous category, the focus is on the control of the elements to investigate whether the elements in the system can move individually or not. Function of the facade. In this category, the functional purpose of the facade system has been defined, such as daylight control, thermal control, or airflow. The response time refers to the time required for the facade elements in the responsive facade system to perform their actions. The facade and its elements affect not only the outer appearance of the building, but also the interior. 23 facade applications selected within the scope of the study were converted into a table according to the determined matrix. Thus, comparisons and examinations were easily completed with the help of this table. Among those 18 active systems, the facade systems that have folding movement are the Kiefer Technic Showroom, the Al-Bahar Towers, the Open Cafe Restaurant, and also Wood Culture Museum. Having hexagonal panels and linear actuators, the responsive facades of the Al-Bahar Towers are controlled by Central Building Management System. The system operates in real time and mainly provides daylight and thermal control. In the Kiefer Technic Showroom consists of folding panels that are controlled by engines. The facade system serves the daylight and thermal control as the previous example. On the other hand, the Open Cafe Restaurant has a glazed facade on which each element can move independently by means of a motor. It allows cross ventilation when the windows are folded. The panels on the facade of the Wood Culture Museum consist of a hexagonal leaves connected in pairs on a black metal profile. An engine controls the movement of the leaves that perform a folding movement in minutes. The main function of the facade is the daylight control. While the visibility is high in Kiefer Technic Showroom and also Open Cafe Restaurant, it's at medium level in the Al-Bahar Towers, since the frames of the hexagonal modules somehow block the view, even in fully opened configuration. It's at low level in the Wood Culture Museum. There are 8 facade systems examined in the rotational movement category. Composed of stainless steel feather-like elements, the facade of the ThyssenKrupp headquarters changes its shape according to the movement of the sun throughout the day. Completing its movement in seconds, this facade system not only provides a regulation of the light entering the interior, but also prevents unwanted solar heat gains. Likewise, the facade elements of the several headquarters are made of metal panels that can be opened independently. Each panel makes a rotational movement around the vertical axis placed on the long edge of the elements. The main purpose of using these elements are to protect the structure from overheating and to reduce cooling load of the building. In both examples, the visibility is at the medium level. On the other hand, there are also other examples which the visibility level is high. In the Pavilion 2014, the panel metal elements on the facade move independently, which can be opened or closed to create different configurations. The panels can be opened in few minutes up to 90 degrees with the help of the hinge located on the short sides. In the other example, Belle Mechanique, the facade elements are multifunctional in such a way that they create new spaces for the users when unfolded and serve as shading roof elements. The facade has been formed by rounded triangular-shaped panels that are placed horizontally and vertically. While the vertical panels can provide privacy, the horizontal panels not only serve for shading purposes but also became balconies. Controlled by hydraulic cylinders, the facade elements provide thermal and daylight controls. The west facade of the Council House 2 building is covered with blinds made of recycled wood. It was built to protect the offices from the sun in the afternoon and to utilize the daylight as much as possible when the sun is in east direction. The west facade of the Council House 2 building is covered with blinds made of recycled wood. It was built to protect the offices from the sun in the afternoon and to utilize the daylight as much as possible when the sun is in east direction. Composed of a large pivoting window, the facade of the Chicken Point cabin building has a movable system that maximizes the user's visibility as opening the main living space to the landscape. In another example, dancing pavilion, there are round mirror elements that make full rotation in horizontal direction. There are sensors inside of the building which capture the music and the movement of the dancing people. Since the building was constructed for a temporary usage, there is no functional objective of the facade like thermal control or daylight control as the previous system. The Livraria da Villa is a bookstore in Brazil. 5 rotating bookcases are located on the main facade, which are attached to the floor and ceiling along the middle axis to create spatial entrance and provide the airflow. The other type of movement presented in the comparison matrix is sliding movement. The facade of the California Gallery is similar to the design of the Chicken Point cabin building. It can open in seconds and the system allows natural airflow as creating a main entrance. Another example of the category is a restaurant in London. The building has a retractable curved glass facade that enables not only to open the main space to the public but also to ventilate the space naturally throughout the year. Although there are many realized examples of the responsive facade having folding, rotating, or sliding moments, the example of deforming category are limited. The One Ocean Pavilion Expo in 2012 is one of the examples of deforming category. The facade elements are flexible lamels that move according to the daylight. As the lamels move one by one on the structure, they can create different patterns on the facade. The other system in the deforming category are based on smart material. Unlike the previous example, the homostatic facade system is a passive system that regulates itself according to the environmental factors such as daylight and temperature. Apart from the previous examples, there is also a facade system that has hybrid movements such as rotation and translation. Inspired from the Islamic pattern Mashrabiyya, the Institute du Monde Arabe Saud facade consists of camera-like diaphragms. The diaphragms open at low altitude levels while they close in opposite direction when the sun shines brighter. The expansion and contraction mechanism of these diaphragms are regulated by the sliders to automatically control the amount of light entering the building. Apart from the active systems, there are also passive facade systems which can move without requiring an actuator, motor, or sensor. 6 samples have been examined in the passive responsive system category, which designed as a second facade skin in the Pittsburgh Children's Museum. The facade elements move slightly with wind pressure without the need of energy or additional support. These elements, which create a light and bright effect on the facade, are located on the aluminum facade frame structure. Likewise, the facade of the Wind Arbor has same design principles and goals as in the first example, but the elements are positioned on a thin cable net. In this example, consisting of aluminum fins, the system covering the glass facade of the hotel lobby shades the interior, blocks the sunlight and heat entering the building. On the other hand, the panels positioned in the breadbox pavilion are reflective modules that strengthen the wave effect as reflecting the sea based on the light during the day. Having similar movement behaviors in the elements, the Latvia pavilion composed of colored and transparent plastic elements that are positioned to represent the nature. The south facade of the museum consists of wind indicators and brown panels that are free to move independently according to the wind and remain at their initial configurations when there is no wind. All the aforementioned facade elements sway in wind and move independently. Various configurations can be seen on the facade in a short time. In this paper, as a systematic review has been conducted for the responsive facade systems using the proposed comparison matrix. Based on the matrix, it can be said that the most of the applied examples of the responsive facades have active systems. Passive ones are usually used for pavilion or exhibition structures. Among the 23 examples of the responsive facades, only 3 of them are based on hand operation, whereas the rest of them controlled centrally. 12 of the systems complete their movements in seconds and 11 of them in minutes. Since the responsive facade systems are generally composed of modules that have capability of moving individually, the elements in such a systems are free to move. That means each can be controlled separately. The elements participants in the reviewed 18 examples have this capability. When the types of movement are examined, it seems that 14 of the responses movement and one has hybrid movement. On the other hand, the rates are the low, medium, and high visibility categories are almost equal. It can be said that this study provides a simple and understandable guide to examine and analyze the facade system. And also, these are our references that we used for our study. And thank you for your attention.
Thank you very much.
We shall continue with the second geometric approach for adaptive buildings. Dr. Mariam, if you would share it, and it would also...
Yes. Yes, doctor. Now I will share the
next presentation.
Yes, please. And also considering the quality speed of your internet, you can decrease the quality of YouTube video by the time that you are playing, so it will not affect the sound. It seems that in our previous presentation there was a little bit problem.
Participant in this conference. And
is it okay?
Also, I would like to thank all.
Yes, it is okay.
It's okay.
My name is Riham Nadi Faragallah. I'm an associate professor at the Department of Architectural Engineering, Faculty of Engineering, Faros University in Alexandria, Egypt. My research paper is talking about biomimetic approaches for adaptive building envelope, applications and design considerations. At the beginning, I would like to introduce the topic that in the past decade, the evolution of biomimicry architecture was considered as an important issue for achieving adaptation strategies and principles to cope with different climatic aspects and provide thermal comfort. Building envelope is recognized as a key factor that affects the energy consumption of a building through design variables and inputs provided by the context. Thus, there is a growing concern to enhance energy performance and promote indoor thermal comfort through new concepts, materials, and technologies which encourage the design for adaptive building envelopes. The research will be discussed into three parts. The first part is the literature review, which deals with the concepts, terms, dimensions, levels of biomimicry, and adaptable building envelopes. The second part is the analysis of applications, which deals with biomimetic applications on adaptive building envelopes, especially or particularly in hot, arid climates. The third part is the proposed biomimicry design matrix for adaptive building envelopes, which concludes the design considerations and strategies for adaptive building envelopes to be adopted in hot climate regions. The main problem in the paper is that the current existing buildings in the Egyptian context have weak building envelopes, which are inefficiently sealed, making them exposed to heat loss and heat gain. There are several goals or objectives for the paper, such as presenting theoretical fundamentals about the significance of biomimicry, its approaches and levels, discussing the development of building envelopes and exploring its design measures and considerations, analyzing different biomimicry applications through adaptive building envelopes in several terms, such as heat, air, water, light, building materials, and so on, proposing a design matrix for adaptive building envelopes that could be adopted by architects and designers, especially in hot, arid climates. At the beginning, we need to have an overview about the concept of biomimicry. The term biomimicry comes from the Greek word bio, which means life or nature, and mimesis, which means imitation or imitating nature. Nature has a large database of adaptation approaches that can be used in the design process in general and in the design of building envelopes in particular. There are several scientists and biologists who have given different descriptions and different definitions for biomimicry, such as Benioff in 1998, Guber 2005, Pedersen 2007, Scott and Var 2012, Lippold 2019. And from these definitions, it was observed that first, it was considered as a mere study of nature's ideas and imitating its design and process to solve a problem. Then it became an important feature and technique in the design. And lately, biomimicry became a creative, sustainable solution for environmental problems using innovative design strategies. Biomimicry has two main approaches, the direct approach or design to biology, and the indirect approach, which is biology to design. In the direct approach, biology, design to biology, there is total mimicry, partial mimicry, mechanics of context, and function physics, which tries to imitate the organisms, its behavior and ecosystem. This was achieved in Daimler-Chrysler bionic car, which was imitating the fish box. The indirect approach, biology to design, there is abstraction and inspiration, but on the organism level only, such as lotus flower that emerges from the swampy waters, which gave influence after that for self-cleaning materials. There are also 5 additional biomimicry measurements, such as the form of the building materials, the construction, the process, and the function. Building envelope and its adaptation in nature. Buildings have developed from simple shelters to complex structures that adapt to their surroundings to raise comfort and quality of life. Also here, there are several definitions for building envelopes, like Rankuhi, who described building envelope as the boundary from which buildings communicate with the environment, or Hooven, who defined building envelope as a shell or a fabric or a skin of the structure or the barrier between the interior and the exterior of the building. There are 3 means of adaptations: physiological or functional, which relates to the organism's chemical process; morphological or structural, which relates to an organism's shape, size, pattern, or structure; behavioral adaptation, which relates to how an organism acts. Applications of biomimicry on building envelope. The first application is Eastgate Center in Zimbabwe. It is a mid-rise shopping center and office block. It was designed to cool itself by natural means that was inspired by self-cooling mounds of the African termites. And to keep the temperature mild, heat gain was reduced using thick walls, building mass, limiting glazing, and deep overhangs. The second application is Al-Bahr Tower, Abu Dhabi. It presents the cultural elements of Abu Dhabi to provide comfortable spaces in harsh temperatures. Double skin and intelligent automatic shading systems were allowed for adaptability and flexibility in response to changing solar altitude angles during the day. The third application is the Ministry of Municipal Affairs and Agriculture office in Qatar, which has been designed with energy efficiency and sunshades on the windows that can be open and closed depending on the weather and mimicking the behavior of a cactus. The fourth application is the Council House 2 in Melbourne. The building is inspired by the bark of a tree based on linking the structure to its surrounding environment and living organisms. The use of biomimicry is evident throughout the building because the west facade resembles the epidermis of a tree that would moderate the external climate, while the north and south facades were influenced by the branching of a tree. After analyzing the four examples or the four applications from the design concept and how they were inspired from nature, their approaches, it was observed that all of them were designed to biology, adopted design to biology approach, the level, if it's mimicking organism or the behavior of the organism or an ecosystem. Also, there was a comparison in the sub-approach in terms of form, material, construction, process, function, and the design consideration concerning heat, air, lighting, water, materials, and visual comfort, which led to establishing a biomimicry design matrix for building envelopes that was divided into three phases or three stages. The first stage is the problem, dealing with the challenges, objectives and goals and limitations of the design problem. The second stage is the nature,
Sorry,
the
there is
function, what
some
does
voice.
nature do and its process, how it is carried out. And finally, the third stage is the solution, which is the main stage. Through design looking to biology, it adapted 6 morphological features and its design considerations, such as heat and how to provide thermal comfort and reduce energy demand through building form, orientation, massive walls, passive cooling, air by supplying air and natural ventilation and improving indoor air quality through adaptable windows and cross ventilation, water conservation through gray water recycling, reuse of rainwater, light like controlling solar radiation through balanced illumination, and this could be achieved through orientation of windows, type of glazing, deep overhangs, and adaptable sunshades. Visual comfort, enhancing visual comfort of the exterior of the building through the form, the concept, and the suitable openings, and also building materials, promoting thermal comfort and quality of space through local building materials found inside and materials that reflect solar radiation. All these physical features and design considerations could be adopted in the design of building envelope to achieve a sustainable built environment in hot, arid climates. Conclusion and future directions. The research tries to encourage the use of biomimicry in the design envelopes. Biomimicry has proven to be an eco-friendly method for creating energy-efficient building envelopes through problem-solving techniques. Also, the research has analyzed different applications with different adaptation methods in hot climates. It concluded a biomimetic design matrix for adaptive building envelopes that could be used by designers in the design process of buildings, especially in hot, arid climates. The matrix suggested to define the human needs and environmental problems, stating goals, objectives, limitations, and constraints. It deals with nature through the function and process and how they are applied and carried out. It concentrates on 6 morphological features with their solutions, such as heat, air, water, light, visual comfort, and building materials. After applying all these previous adaptive physical characteristics of living organisms, and taking into consideration the design of building envelope, this may save materials, energy, achieve more functional, sustainable solutions, lower costs, and increase performance and durability. And also it will serve as a tool to achieve a sustainable built envelope to develop the innovation engine in the Egyptian context. Thanks for your attention.
Thank you very much. Thank you very much, Dr. Reham. The last paper, it's the evaluation of the effect of mass housing facades on comfort condition, the example of Atakwe. Dr. Mariam?
Yes, now I am sharing.
Can you share?
Yes, yes.
Thank you.
Migration from rural areas to cities has been increasing with increasing population, increased nation use in agriculture and industrialization. These effects increase in urban population. Housing problems caused by increasing internal migration and fast urbanization, and it have been attempted to be solved with different housing
I think there is a small noise in the video. Am I right, dear Salah?
Unfortunately, I am not hearing the
noise,
the
the sound
YouTube very well because of the interruption of
since
my.
it is the last one, if you don't mind, Dr. Mariam, you stop sharing. I will share from here to be in safe side.
Yes,
yes, it will be much better.
Okay.
With the high quality.
So, Dr. Mariam, please stop sharing.
I stopped the sharing.
Perfect, thank you. Let me share with
Thank you.
Second. Perfect. We will go with the last one, which should be the high quality.
Hello everyone, I'm Seda Yüksel Dicle, and today I'm going to talk about assessment of the effects of mass housing facades on interior comfort conditions based on the example of Ataköy. Migration from rural areas to cities has been increasing with increasing population, increased nation use in agriculture and industrialization. These effects increase in urban population. Housing problems caused by increasing internal migration and fast urbanization, and it have been attempted to be solved with different housing policies in different periods. One of these solutions is mass housing projects, which refer to a high number of residential building production in a shorter time and with less investments. Houses are space in which occupants spend long hours and expect to have the right comfort conditions, thermal, visual, and acoustic. Environmental and economic problems as a result of increased fossil fuel consumption, limited energy resource, and negative effects of increasing environmental noises underlines the importance of architectural design decisions. And these decisions for mass housing became more important than single houses. Fast population growth, advance in technologies, changing consumption habits with urbanization and industrialization, increase energy demand worldwide. Regarding the distribution of energy consumption among industries, residential buildings have a major share in the total energy consumption. In Turkey, residential buildings are responsible for 40% of total energy consumption, and a majority of the energy is consumed by heating and cooling systems to achieve thermal comfort conditions. Another important environmental problem as a result of increased urban population and intense urbanization today is noise. Control of noise is getting more important with increased number of noise sources. Residential areas are exposed increasingly more to environmental noises as a result of fast urbanization and industrialization. Increasing energy consumption, limited energy resource, the damage of their use of the environment, and negative effects of environmental noises on people increase the importance of architectural design decisions. Building facades are one of the most effective design decisions. It controls outdoor environment conditions and affects energy consumption caused by heat losses and gains, and noise reduction value for outdoor environmental noise. Within the scope of this study, mass housing settlements that build in the same region in Turkey in different periods and have different facade systems and materials are evaluated in terms of their thermal and acoustic performance, also the amount of energy they consume to provide thermal comfort conditions. For thermal comfort, operative temperature and solar gains of the units and energy loss were calculated. And for acoustic comfort, noise reduction values of building facades of the units were calculated. Design Builder and KS simulation programs were used in study. Design Builder was used in the thermal performance calculation, and KS was used to calculate noise reduction values of the facades. The placement of the blocks was shown in figure 2, and residential buildings included in this study are in Ataköy region in Istanbul. It has temperate humid climate conditions. Phase 1 D block were built in 1950. Phase 5 were built in 1980s. In both blocks have similar orientation and outdoor noise levels. Buildings in the phases 1 and 5 different building form. In order to compare energy loss of the buildings, energy loss were calculated for per square meter. In the study, the living room and bedroom volumes where comfort conditions are more important were selected. Building envelope properties are shown in chart 1, and blocks have different facade systems. Block D in phase 1 has brick facades, and block A in phase 5 has concrete facades. And transparency ratio of buildings are shown in chart 2. For thermal comfort conditions in study, operative temperature and solar radiation gains in units were calculated for January and July 21st. In energy consumption calculation, indoor comfort temperature was set at 20 Celsius degree for heating period and 26 Celsius degree for the cooling period in the residential buildings. For acoustic comfort conditions, noise map were used for outdoor noise level, and the level of noise that the building facades were exposed was set at 70 decibel. Regulation and protection of buildings from noise were used for facade noise reduction, the limit values, and noise maps of the region are shown in figure. In study, building envelope details, which change depending on the construction year of the buildings, were comparatively assessed. Information on the living room and bedroom units are shown in the figure, and in study, calculation results for buildings are evaluated in separate tables for living room and bedroom units. When the study results are assessed, thermal comfort for living room units, daily average operative temperature and overall solar radiation gain values in living room on January-July 21st were higher in block D than block A. The difference between minimum and maximum values of daily average operative temperatures was higher in block D than block A due to the increased building transparency ratio. While heating loads were lower and cooling loads were higher in Block D, which was built in 1950, than Block A, which was built in 1980, due to the solar radiation gain and thermal mass. Cooling loads were higher. None of the buildings meet the minimum requirements for total heat transfer coefficient recommended by the standard. Under these conditions, annual overall energy load was higher in Block A than Block D, and there was a 35% increase in overall energy load consumption. When acoustical comfort for living room units, noise reduction value of the opaque component was higher in Block A due to the building's facade properties, mass of the structural element, and the presence of airspace between it. The noise reduction value of the composite envelope was higher in Block A with lower transparency ratio and higher opaque components. The noise reduction value of facade was higher in Block A due to the noise reduction values of the opaque component and transparent component ratio. And although they were built before the regulation, the buildings were found to meet the minimum acoustic performance class D requirements. When the thermal comfort for bedroom units, daily average operative temperature and overall solar radiation gain values in bedroom on January and July were higher in Block D than Block A. The difference between minimum and maximum values of daily average operative temperatures January and July was higher in Block D than Block A due to the increased building transparency ratio. While heating loads were lower and cooling loads were higher in Block D, which was built in 1950s, than Block A, which was built in 1980s, due to the solar radiation gain, none of the buildings meet the minimum requirements for total heat transfer coefficient recommended by the standard. Under these conditions, annual overall energy loads was higher in Block A than Block D, and there was 22 increase in overall energy load consumption. When the acoustical comfort for bedroom units, noise reduction value of the opaque components was higher in Block A due to the building's facade properties, mass of the structural element, and presence of airspace between it. The noise reduction values of the composite envelope, which includes both opaque and transparent components, was higher in Block A with lower transparency ratio and higher opaque components. The noise reduction value of facade was higher in Block A due to the opaque component and transparent component ratio. Blocks built before the regulation were not found to meet the minimum acoustic performance class requirements, and they provide the E acoustic performance class. Regarding the thermal performance and energy consumption, buildings didn't meet the limit values determined by the thermal insulation regulation. The transparency ratio in Block D and Block A, which were built before 1980s, had an effect on solar radiation gains and therefore on overall energy loss. Due to the increase in the ratio of transparent components on building facades in the living room oriented to south, heating loads decrease and cooling loads increase. Based on the simulation results, Block D compared to Block A for living room, 99% increase in heating loads, 219% decrease in cooling loads, and 34% decrease in overall energy loads. Block D compared to Block A for bedroom, 54% increase in heating loads, 183% decrease in cooling loads, and 22% decrease in overall energy loads. Change in the facade systems and transparent component ratio between blocks don't meet the requirements of standards had more effect on cooling loads. Regarding operative temperature values, the value which is closest to comfort temperature value set for January 21st, was achieved in Block D, and the value which is the closest the comfort temperature set for July 21st was achieved in Block A. In this case, less energy was consumed for heating systems in Block D and for cooling system in Block A, in which values closest to the required comfort temperature were achieved. According to the acoustic performance assessments, noise reduction value of the opaque components was higher in Block A due to the mass and material properties of the building facades. Regarding the composite envelope, because of transparent component properties were the same, noise reduction value changed depending on the noise reduction of the opaque component and transparent components. Despite high outdoor noise, the buildings that were built before the regulation on protection of building from noise became effective in 2017, meet the requirements of minimum acoustic performance class for a living room in existing buildings. However, facade properties were insufficient for bedrooms, which have a high sensitivity to noise. And this study found that decisions about materials, layering and transparency ratio for the facades of mass housing buildings built with different facade systems in the same district had an impact on thermal and acoustic comfort conditions and energy consumption. Design decision in mass housing systems in which many residential buildings are built simultaneously have more important role than they have for single buildings construction. In the new housing project, mass housing buildings are manufactured in accordance with current laws and regulation, and that will provide comfort conditions with minimum energy. However, the necessary measures should be taken in all the mass housing buildings, which are numerous today and cannot meet the requirements of today's regulation. And these are references, and thank you for listening.
Thank you very much. Thank you very much. Dr. Uraksh.
Thank you.
Should I leave the platform for you for the last presentation, or what do you think?
Actually, yes, if you want to...
Sayın Rektörüm, ekranları başında bizleri izleyen Ege Üniversitesi ailesi.
Yes, sorry. If you want to conclude the first two, then I will also conclude officially the conference to close. If you want.
Yes. First, let us to see if there is any question. There are any questions regarding the wonderful presentations. I
have question
in love with envelopes. That's why I don't like to leave the session without questions. I hope somebody asks something.
From Dr. Mariam, would like to ask.
Yes, I have one question.
Yes.
For the first presentation in comparative study on responsive facade system from Dr. Junior, I don't know, Professor Perry Madden, if she is here.
Yes, sure, I'm here. I'm listening.
Yes. Yes, I have a question. As we know, the movable type of facade is more expensive than a static or fixed one. So I want to know your opinion. If we, do you think if the initial cost can cover by the payback of the facade through the time, means through the more efficient result by the time, then fixed facade, more than fixed facade or a static facade means it can be cover the cost, initial cost, if through the time to be more efficient?
Thank you for your question. Actually, as we know, due to the constantly changing needs and the inadequacy to static systems cannot respond to requests as the changing request, the interest is increasing, and obviously they are a solution for many design parameters, but we should consider also the analysis. We cannot directly answer this question. I think we should consider the type of system, we should consider the environmental change and so on. That's why I think it depends on the analysis. We should consider all the parameters, and actually this is in the scope of our study it's a classification proposal. That's why we didn't analyze any changing environmental factors. That's why I cannot give any specific answer for it. As I told you before, it can be changed according to the environment and also the system. That's why we should conduct some analysis for it.
But you cannot guess how much successful can be to apply movable facade commonly, more than fixed facade. It will be successful, or what do you think about the success of this kind of facade?
For sure, it can be more expensive, but I think the success percentage is getting higher day by day, because we are using some simulation programs, more technology. That's why, according to the also material, I think the success is getting higher.
Thank you. Thank you so much.
Thank you.
Thank you.
Thank you, Dr. Mariam, for your question. Any other questions? I have one question then for Dr. Reham. Dr. Reham is there?
Yes, I'm here.
How are you, Doctor? I am very interested. I was very interested in your presentation. I want to ask you something apart from this presentation. I want to ask your opinion. Can biomimicry affect the aesthetic value in negative way? I hope you understand what I say, because mimicry, it's looking for the functionality, for sustainability, giving, we cannot avoid the appraisal and the respect to this kind of facade, but how much can be beautiful? I mean the in another way, in the eye of beholders, how can be mimicry beautiful in the eye of beholder? Not professionals, I mean, just people.
Normal people.
Yes, because for sure architects will or professional engineers can evaluate the things more than others, but how can we avoid to negative evaluation of the people to this kind of designs?
Well, in my point of view, I think from my readings and research, I found that the facades or the building envelope, as I mentioned in the paper, it has a visual comfort. And this is one of the points that I stated in the matrix. It should have a visual comfort so that the rest of the people, normal people, can understand it or can digest this type of architecture. This is, I think, my point of view.
Yes, okay. You don't think we can do something very useful but not beautiful, for example, in the future, especially with this kind of simulation programs and parametric design, etc.?
Of course, usefulness is more important than to be visually nice. Function is more important than it to be visually nice, but if we consider both or make a balance between both issues, I think it will be much more better.
Thank you. Actually, I agree with you. Functionality itself, it's beauty.
Yes. It's more important.
Thank you very much.
My pleasure.
Thank you. I have another question for Seida. Seida, I didn't follow 100% your data input. Seida is here?
Yes, I hear you.
Yes. Regarding the thermal comfort evaluation in the facades, in the walls, I wonder if you used thermal transmittance constants and thermal damping in your data input to design builder. Did you do that? Because it is very important in a humid, moderated and humid climates, like what the case study you select.
Yes, I use the transparency ratio and buildings form for different plans. So in order to compare energy loads of the buildings, cooling and total energy loss buildings.
And what about dumping? What about thermal dumping?
Sorry?
What about thermal dumping? Did you input thermal dumping in your data input?
No, I didn't add this value.
I think if you add that, maybe you will get much more accurate results. This is my opinion. You can discuss with your group, and you can maybe try once to see how much is the difference.
Yes, thank you.
Thank you very much. Dr. Hurash, are you there, Dr. Hurash?
Yes, yeah. Sorry, I was talking with
from our side. I want to express my gratitude to the group that they spent their time with us, and it was wonderful time. We spent discussing and listening to the different type of research, valuable research actually. And now the ground is yours.
Thank you,
Dr. Hurash, and thank you very much.
Thank you, dear Dr. Salar, our valuable session chairs. It was indeed a valuable 2 days of marathon in parallel session at the same time. It was very indeed powerful without stopping since 9 in the morning till even it is already half 8. So even yesterday was a little bit more. So it was indeed a good quality of contribution from all of you. I really appreciate that. And even our rector sent his gratitude to you all regarding the quality of the content of even the authors and contribution and the organization. We really appreciate all your support indeed. We will have our gala night. You are kindly invited to have, let's say, actually traditionally it's supposed to be gala dinner. I know that after the conference, the organizer is supposed to give you a dinner. So unfortunately,
Doctor, sorry for intervention. There is one question from Zainab to Dr. Riham.
Yes, of course.
Dr. Riham is there or not?
Yes, I'm here.
Dr. Riham, Zainab is asking, regarding, do you have any idea about how apply the parametric design with the biomimetic approach?
Well, parametric design is not my field, so I really exactly don't know. Maybe there is a relation between the two, of course, due to the new programs of simulations and 3Ds and so on. But the parametric design is not really my field, but maybe it gives me another new idea for a new research in the next conference.
That's great. This is the goal from the conference.
Okay.
Thank you. Sorry for disturbance and the intervention, Dr. Hurash, but we have to.
So in that case, I was writing that we thank all of the authors and session chairs, co-chairs, and contributors. You will always be in our hearts since now. Please keep in contact after the conference. If you have any question, of course, this conference idea, I believe that based on my experience during the last 5 years, that the conference is just somehow the starting point to start.
Yes.
You know that as an academician, the best possible place to increase your network is somehow the academic, such a kind of academic environment. So please, we are all academicians, so try to keep in contact with your colleagues in case if you see any topic or part or subject interesting. Try to find your network from different countries. So it will be a good memory of us. For example, I have gathered lots of our colleagues from these conferences, and I'm very happy with that. Even not only from my organization, with the time that we are going to other conferences, this is the best possible option for us as an academician to increase our network of collaboration. So please keep in contact with each other. Thank you for everyone for your great and valuable contribution. We will try to conclude, and I will send within 10 minutes, I will check the presenters, and I will try to publish your certificate of presentation and publication, presentation and contribution within 10 minutes for all of you, for sure. I will go to also finalize the other sessions as well. Please keep in contact and stay tuned, and see you soon in Gala Night within 20 minutes. Thank you for all of you.
Okay, thank you very much.
Work.
Thank you. See you soon. Bye-bye.
See you soon. Take care of yourself. Please keep in contact and stay tuned.
Bye-bye.
Bye-bye.
Nice to meet you all.
Thank you, dear Dr. Riham.
Thank you.
So you may, in any case, with this web platform, we will continue. I will try to come back within 20 minutes. So you may be around, or you may join within 20 minutes. It doesn't matter. Dr. Salar, thank you for everything, Dr. Mariam. And
thank you very much.
Valuable authors.
Thank you. Bye-bye.